Estão todos desligados?
Estão ligados, estão ligados. Estão mesmo ligados. Estão no mute.
Dois, dois.
Bom dia. Sejam bem-vindos à Universidade do Algarve. Iremos dar início à Conferência Internacional CIMA, subordinada ao tema Stress no Oceano, de abordagens multidisciplinares à investigação transdisciplinar. Good morning. Welcome to the University of Algarve. We will begin the CIMA International Conference on Stress in the Ocean, from multidisciplinary approaches to transdisciplinary research. Iniciamos a sessão de abertura com o reitor da Universidade do Algarve, professor Dr. Paulo Águas. To open this international conference, I would like to introduce the rector of the University of Algarve, Professor Paulo Águas.
Bom dia, good morning. Mr. Minister of the Sea, Ricardo Serrão Santos, dear Mayor of Faro, Rogério Bacalhau, Mr. Alan Simcock, Joint Coordinator of the Group of Experts of the World Ocean Assessment of the United Nations, dear Director of CIMA, the Marine and Environmental Research Center, Maria João Biano, dear authorities, dear participants, welcome. It gives me great pleasure to extend to you all a very warm welcome to the International Conference Stress in the Ocean. Mr. Minister, it is an honor and a pleasure to welcome you. Your presence means recognition of our work, and at the same time, it is an incentive to do more. Special thanks to Professor Bebiano, Director of the Research Center, the promoter of this event. The Research Center is celebrating 20 years. Congratulations and many thanks for your contribution to our university. The University of Algarve is a Portuguese public higher education located in the southern region of Portugal, the Algarve. We are a general university offering a wide variety of courses in a broad range of subjects. Founded in 1979, we received the first group of students in 1983. University means generality. University also means universality. But universities are not all the same. We used to say that all fields of knowledge are important within a university. It is no less true that many universities are recognized by the excellence they achieved in research in specific fields. This is the case of marine science and technologies at the University of Algarve. I'm not saying that marine science and technologies is the only field of excellence inside University of Algarve. We have more, of course. Marine biology and fisheries, today marine biology, was one of the 3 undergraduate programs that in 1983, as I mentioned before, received the first students at the University of Algarve. It was a strategic option for the foundation and development of this academy. Our degree student population in all fields is around 8,000 students, less than 3% of the total degree student population in public higher education institution in Portugal. Nevertheless, in the last evaluation of the research centers this year by the Foundation for Science and Technology, in the thematic area of marine science and technologies, the University of Algarve represents 30% of the integrated researchers. According to the Times Higher Education subject ranking, life science which includes marine science, is our stronger field. The marine science was an initial, not only option, but bet, I can say that. The marine science is a winning bet in our university, and the marine science is a future bet and a future option, because ocean is a societal challenge. Dear participants, I wish you a successful conference. Thank you very much.
Passo desde já a palavra à diretora do CIMA, a professora doutora Maria João Bebiano. I would like to introduce the director of CIMA, Professor Maria João Bebiano.
Good morning. Magnífico reitor da Universidade do Algarve, excelentíssimo Sr. Ministro do Mar, excelentíssimo Sr. Presidente da Câmara de Faro, excelentíssimo Joint Coordinator of the Group of Experts of Regular Process for the Global Reporting and Assessment of the State of the Marine Environment, including socioeconomic aspects of the United Nations, excelentíssimas autoridades militares, excelentíssimos senhoras e senhores, caros colegas, gostaria, em primeiro lugar, de saudar o Sr. Ministro do Mar e agradecer a sua disponibilidade e apoio desde a primeira hora que deu a esta iniciativa e desejar-lhe os melhores sucessos na implementação e desenvolvimento de políticas públicas na área do oceano. Estou certa que, sob a sua liderança, a jangada irá continuar a flutuar e seguramente chegará a um porto. I would like to thank also Dr. Alan Simcock, the coordinator of the Group of Experts of the United Nations, for being available to travel to Portugal in a particular difficult time of the work of the World Ocean Assessment. There's a crucial time, and as we're going to hear probably from his speech, we are in a very heavy task at the moment. So today we are starting today's conference on the stress of the ocean, integrating in the celebrations of the 40th anniversary of the University of Algarve, the only university created by Parliament initiative, and in which, since, as the director just pointed out, marine sciences have been the most important pillar, either teaching, research, and technology, and is recognized of excellence at the national and international level. The Marine and Environmental Research Center, established in the International Year of the Ocean, has been following the evolution, innovation that has shaped the ocean and the changes that we are seeing today, either supporting teacher or research and contributing to a solid science in the field of marine and environmental research. This conference also intends to reinforce the importance of the United Nations Convention on the Law of the Sea, whose 25 years we are celebrating today, along with the 500 years of the circumnavigation of Magellan. So this is a very good timing for celebrating the oceans. The theme of the conference is Stress in the Ocean, which we are unfortunately responsible for that stress. And it aims to discuss multidisciplinary and transdisciplinary approach to research linking science and society, because universities have to open their knowledge and also society and science. We have to transmit what we're doing to the society. We dedicate the first day of to science and society with the aim to disseminate in Portugal the work developed by the United Nations Regular Process for the World Ocean Assessment, stressing the importance of increasing interdisciplinarity and also the national participation on the process. In the first World Ocean Assessment, only 4 Portuguese participated, and one of them was the Minister of the Sea. And in this one, luckily, we already have 20 Portuguese participating, either being conveners, writing teams, or being reviewers of some of the chapters. So this is also possible because there was changes. We have a focal point, which is the Foundation of Science and Technology, and also the importance that the Ministry of Foreign Affairs had dedicated to this role. We also was to highlight the importance, which we're going to hear about the initiative that's the baseline, that the World Ocean Assessment is acting as a baseline for the Ocean Decade of the United Nations for 2020 to 2030 for sustainable development that is going to reshape marine sciences in the next decade. So I would like to point out to the students, they'll be aware for this initiative. Also in the first day, we'll be able to hear initiatives that are taking place by the Azores Air Center regarding the impact of the Atlantic, which is a major issue in a moment. And also on the second day, we are shaping on societal changes like pollution, plastic pollution in the ocean, tourism, literacy, and what's going to be the future. So I would like to end by thanking all the speakers who accepted to give their know-how and transmit their experience and to contribute to better knowledge of the ocean, and also the British Embassy in Lisbon and GALP that have also joined us in supporting the conference. I would like to wish you all a good conference, in particular to the many international students that we have in the room, that be able to have this opportunity to hear the most changes in the ocean at the moment. So thank you very much, and I hope you have an excellent conference. Thank you.
Vai agora tomar da palavra o coordenador do Grupo de Peritos da Avaliação Integrada do Estado do Oceano das Nações Unidas, Professor Alan Simcock. I would like to introduce the joint coordinator of the Group of Experts of the World Ocean Assessment United Nations, Alan Simcock.
Rector, Mr. Mayor, Mr. Minister, me desculpe que eu não falo português. É a língua do primeiro poeta do Oceano Mundial, Camões. Mas todos vocês vão entender meu inglês melhor do que minhas tentativas de falar português. What I would like to do, distinguished representatives of the Portuguese state and the students from around the world, is to put the foundation of the University of the Algarve and the Centre for Environmental and Marine Research into a little context of another anniversary, 50 years ago. 50 years ago, an oil tanker called the Torrey Canyon ran aground on a reef called the Seven Stones in the English Channel between the Isles of Scilly and the English mainland. 119,000 tons of oil were spilt. One of the features of what followed was the fact that the then Prime Minister of the United Kingdom, Harold Wilson, for whom I was secretary briefly, had his summer holiday home on the Isles of Scilly, and he realized immediately how serious it was and began a whole series of international activities to try and deal with this. Within a relatively short time, certainly by the standards of international progress, we had an agreement on the rights of coastal states to deal with pollution from ships in international waters. We had the Bonn Agreement on the cooperation between the North Sea states in dealing with oil pollution from ships. And then we had another event. A ship called the Stella Maris sailed from Rotterdam to dump 600 tons of toxic chlorine compounds in the North Atlantic. And this produced an outcry. And in the run-up to what was then being planned as the Stockholm Conference on the Human Environment, we had another bout of international action. The Oslo Convention on dumping at sea was agreed and signed in 4 months. And anyone who has tried negotiating international agreements will agree that to get 15 states to agree to a new convention in 4 months is very quick going. That then broadened out into the London Convention, which was to control dumping at sea globally. That was signed in 1972 and I had the honour of organising the signing ceremony in London, simultaneously with the signing ceremonies in Moscow and Mexico City, one of the few international treaties that was signed simultaneously in 3 places. And that then led on to the Stockholm principles, which laid down principles of international law on protecting the environment. We then saw the Paris Convention, which brought Western Europe together to control land-based pollution and pollution from offshore installations. And we then saw all around the world the emergence of the regional seas agreements, of which there are now 17, covering nearly all the coasts of the world. At the same time, the International Maritime Organization developed MARPOL, the Convention on the Prevention of Pollution from Ships. All these activities together produced a completely new outlook on protecting the ocean. People had been worried about it for half a century before that, but the 10 years between 1969 and 1979 saw, as the English poet Shakespeare said, a sea change, a total revolution in attitudes. And thus the Centre for Research into Marine and Environmental Matters and the University of Algarve came into being at a time when a new contribution was very much needed. I'm therefore very pleased and honoured to be here to help celebrate 40 years of that work and the very substantial contributions that are being made. Thank you.
Vai agora intervir o Presidente da Câmara Municipal de Faro, Dr. Rogério Bacalhau. I introduce now the Mayor of Faro, Rogério Bacalhau.
Muito bom dia a todos. Eu tenho o problema, ao contrário do professor Alan Sincup, que falo melhor português do que inglês. Queria, em primeiro lugar, cumprimentar Sua Excelência, o Sr. Ministro do Mar, o professor Dr. Ricardo Serrão Santos, magnífico reitor da Universidade do Algarve, Sr. Diretor Regional de Agricultura e Pescas, Sr. Comandante da Zona Marítima do Sul, professor Alan Sincup, co-coordenador do painel de peritos na avaliação global integrada dos oceanos nas Nações Unidas. Cumprimento muito especial à senhora coordenadora do CIMA, professora doutora Maria João do Biano, ilustres especialistas, palestrantes, caríssimos representantes das entidades oficiais aqui presentes, distintos membros da equipa reitoral, diretores das faculdades e escolas aqui presentes, professores, alunos e investigadores, caros convidados, comunicação social. A minha primeira palavra é para dar as boas-vindas ao Sr. Ministro do Mar nesta sua primeira visita oficial ao Algarve. Desejo-lhe toda a sorte e os maiores êxitos no seu mandato que agora se inicia. Faço votos de que as áreas afetas à sua tutela conheçam no seu Ministério um avanço significativo e com efeito direto na vida das populações. Faro é uma cidade de feição marítima e com uma orla costeira que pode ser motivo de orgulho para todos, e é certamente motivo de orgulho para nós. Contudo, a sua zona litoral ainda não acompanha os esforços que têm sido feitos no casco urbano, onde os setores público, privado e associativo têm transformado o meio circundante para melhor. E por isso estamos muito esperançados que o Sr. Ministro nos ajude a cumprir o nosso potencial no que respeita à nossa litoralidade. Nesse sentido, estamos a desenvolver diversos projetos para operar uma completa transformação de quase toda a frente da ria da cidade. E precisamos de um impulso efetivo a estes assuntos, para que as mudanças aconteçam e levem Faro a afirmar as suas notáveis qualidades enquanto cidade marítima. Também no que diz respeito à descentralização de competências da tutela nos municípios, Faro aí está para assumir as suas responsabilidades e a preparar-se para abraçar este desafio com entusiasmo. Estamos à sua disposição, Sr. Ministro, com sentido de responsabilidade e incontestável lealdade institucional para implementar as políticas de fomento do meio marinho e das zonas ribeirinhas para que, de uma vez, possamos atingir o formidável potencial de que dispomos. Para já, o Sr. Ministro dá-nos um excelente sinal, comparecendo no arranque de mais uma iniciativa de alto mérito técnico e importância científica aqui na nossa Universidade do Algarve. E assim pode reiterar o que sabe com poucos, que é a importância das contribuições dos centros de investigação da Universidade do Algarve para o desenvolvimento de uma ciência sólida no campo da investigação marinha e ambiental. Cumprimento o Sr. Reitor, felicitando uma vez mais por estes 40 anos de rica história. E saúdo a professora Maria João Bebiano pelo excelente evento que aqui organizou e que nos vai ajudar a todos a dar ainda mais valor ao assunto do oceano e a refletir sobre o papel que o CIMA e, em última análise, o nosso país poderão desempenhar nas próximas décadas nestas matérias. Ao cumprir o seu 40º aniversário, a Universidade do Algarve vê-se cada vez mais competitiva no panorama nacional e europeu e capaz de cativar cada vez mais alunos, professores e investigadores. E muito disso se deve ao trabalho daqueles que estão nos seus centros de investigação. Da nossa parte, penso que os dias que vivemos nos convidam a uma reflexão profunda sobre a longa frente de costa regional e sobre a sua vulnerabilidade em face das alterações climáticas que estamos a experimentar. Há já muitos estudos conhecidos sobre essa vulnerabilidade e outros podem ser concebidos e sedimentados. O que interessa é aprofundar o que já sabemos para que depois, todos juntos, possamos concertar as medidas que temos que assumir perante as nossas populações, perante o nosso planeta. Para já, os meus parabéns a todos por esta organização. Faço votos de que aqui saiam excelentes contributos. Muito obrigado.
O encerramento desta sessão está a cargo de Sua Excelência o Ministro do Mar, Professor Dr. Ricardo Serrão Santos. This session is closed by Minister of the Sea, Professor Ricardo Serrão Santos.
Muito boa tarde, ou bom dia, desculpem. Bom dia a todos. Magnífico reitor da Universidade do Algarve, Sr. Presidente da Câmara Municipal de Faro, Sr. José Bacalhau, que já me deixou aqui um caderno de encargos grande. Obrigado por esse caderno de encargos, que darei toda a atenção. Minha querida amiga, professora Maria João Bebiano, dear Alan Simcock, who is here representing the Second World Ocean, Senhor representante do chefe de Estado-Maior da Armada, representante da Capitania, caros colegas, caros amigos, autoridades. I now go to English. I'm really pleased to be among old friends at the University of the Azores and celebrating its 40th anniversary. As a personal note, I would like to stress that as an ocean scientist and academician, I have been strongly engaged along the years with the University of Algarve, and I still am. The university plays a major role in ocean sciences. And without diminishing the value of other fields of study and higher education at the University of Algarve, I must stress that this university is highly recognized, and the ocean science and marine science represent the bulk of its scientific productivity. Saturday, that means 2 days ago, the major weekly newspaper of Portugal, Expresso, made a strong reference to a book recently published on the evolution of science in Portugal, with the headline, Portugal on the way to become an European reference in marine science. I don't believe it's the right title. It's already a major reference in marine science. And the article mentioned that despite the widespread excellence in the country, the Algarve and the Azores are clearly specialized, with 20 to 30% of their scientific production concentrated in marine science. This fact per se is relevant, but it is also relevant that the media, this newspaper, gave particular attention to the progress on ocean science in Portugal and not to the others. And we are in special times where good science continues to be a basic tool in informing policies. And brings me to recall the Algarve Declaration issued in 2011 based on the results of the conference Sea of Portugal, Knowledge, Valorization and Development. The Algarve Declaration proposed guidelines for strengthening the role of knowledge in ocean affairs. And many of us were here, you are here, in this, sharing this same space as we did in 2011. This space today, we were involved in that process under the inspirational drive and coordination of Professor Mário Ruivo. Mário Ruivo got 2 honoris causa doctor degrees in marine science in Portugal. The first from the University of the Azores in 2011, and at the inaugural ceremony of the new campus in Faial, with the praise speech given by late President Mário Soares. He was president in Portugal, but he was also president of the World Independent Commission of the Oceans in the 90s. The second one was awarded in 2016 by the University of Algarve, a few months before Mário Ruivo passing away, but leaving with us a great legacy concerning the ocean, and we should all be proud of this legacy from Mário Ruivo. I'm, in fact, really pleased with the opportunity of joining you today as Minister of the Sea of the new government of Portugal. A government that includes the challenge of climate change and the oceans and national concerns for a shared global governance. Let me reveal to you that during many, many years, as a marine scientist, I had that inner sense or impression that the sea was understood as, by all, as a major asset of great value in itself. When I came to politics in sensu strict, and enter in a regular contact with different stakeholders, I begin to have the feeling that a huge part of the society did not share the understanding of the role that the seas and ocean plays on the safety of the planet and of their daily life and routines. But I also learned that this does not apply only to common citizens, but also to political leaders, administrators, and CEOs. In 2015, we are all aware, the distance between what I was thinking that was the motivation and understanding of the role of the oceans in the global aspects of the planet, I'd say this distance between the understanding and the denomination in policies was reflected on the almost absence of a reference to the marine environment during the COP21, apart from side events. A single reference, if you look to the main declaration of the COP 2015, a single reference to marine ecosystems was inserted in the declaration at the last minute. We cannot also hide that the first United Nations Global Ocean Assessment, where I was involved, came to light only in the year 2016. The fact is that not so many decades ago, mainly till the middle of the last century, science and politics have both been claiming that the oceans were inexhaustible and untouchable, or even immune to threats. Something that need not much care and was not offering much trust. The oceans have been, in fact, an incognito and opaque major asset on the safety of the planet, while it was absorbing carbon dioxide dumped in the atmosphere by the burning fossil. The Big Blue was also as being a remarkable, and is a remarkable contributor to the capture of extra heat produced as a consequence of the ongoing process of global warming. Ocean science knew it since long ago, warned about it, but politicians played dumb, not understanding how the oceans have their own limits. The oceans are going through rapid and dramatic changes, and these changes go well beyond some visible facts that are the issues of overfishing, when the fish does not arrive to our harbors and to our markets, and the pollution, including the plastics. These are two visibles. But the oceans nowadays are deeply hurt by acidification, increased average temperature, lowering of oxygen levels originate by the greatest blight of our time, global warming, that some politicians still deny. And these are cumulative stresses. Today's conferences is about stress in the ocean and targets this problem and address the substantial processes taking place in several international fora, and at the same time celebrates the role of Portugal accompanying these processes. One of the main topics of the conference is the World Ocean Assessment coordinated by Professor Alan Simcock. I see that several contributors are also present here today, and now I learned that we have 24 contributors. Congratulations for this big effort and this investment. And the World Ocean Assessment currently is in its second edition, provides integrated science-based information for decision-making, vital for all stakeholders involved in ocean affairs. And I also learned that the third World Ocean Assessment is already in the agenda. So it born late in 26, the first, but it's on the road and will never stop. And the World Ocean Assessment interconnects with the United Nations Decade of Ocean Science that is starting next year in 2015. It is worth mentioning that the Parliament of importance of knowledge in ocean affairs, present both in a decade and then the assessment, was already enriched in the preamble of the United Nations Convention on the Law of the Sea and constitutes one of the main challenges of next year's. I would like to stress that the high-level science panel of the Decade of Ocean Science for Sustainable Development, which I was honored to be until I initiated my functions as minister, identified several strategic objectives for the decade. The first three strategic objectives are scientific. One, understanding effects of cumulative stressors on the ocean system and the related impacts, including socioeconomic impacts. developing the science-based and capacities for ecosystem-based management, and 3, research and development to mitigate ocean-related risks and hazards. These will be complemented by bottom-up interests from a wide range of stakeholders, and there is a clear call for a multi-stakeholder dialogue and co-design of ocean science in the context of the decade and the Sustainable Development Goals. But this is not a decade for ocean science, but rather ocean science for sustainable development. And I would like to remind that the first World Ocean Assessment concludes that major disparities, and I cite as a citation, major disparities exist in the capacity around the world to undertake the marine scientific research necessary to proper management of human activities that can affect the marine environment. Sustainable development has to be a commitment that should take rather seriously the disparate and contrasting levels of development between regions and countries. The most in risk of deterioration, as you all know, the most in risk of deterioration of environmental conditions are the least developed. However, they have been the least to contribute to the new state of the planet and our oceans. It will not be an easy task to push forward the core objective of the United Decade of Ocean Science and the United Decade of Sustainable Development Goals to improve the scientific and development to regions limited in capacity and capability. In this case, we need a steady and progressive focus on education, training, and research, and universities have an important role on that, to enable the next generation of decision makers and marine research managers to exert their rights and duties with increased accountability. The close involvement of Portugal into processes, the World Ocean Assessment and the United Nations Decade of Ocean Science for Sustainable Development clearly illustrates the recognition of our country roles in ocean affairs. Also exemplified, among other cases, by the choice of Portugal as co-organizer of the next year's Oceans Conference by the United Nations. Finally, it is worth mentioning the topic chosen for the second day of the conference, the link between science and society, detailed in specific subjects such as the current plastic problem, tourism, and ocean literacy. These 3 domains are crucial. The presence of plastic in the ocean represents a well-known problem and one that will occupy us in the years to come. Tourism, and specifically ocean sea-based tourism, is an important socio-economic field, particularly in this region, the Algarve, and one where sustainable development, guaranteeing resources and ecosystem for years to come, is for that reason essential. Blue growth, other tourism or other, without scientific-based governance can go very wrong. And finally, the subject of literacy, cross-cutting to all the previous mentioned issues, deserves a special message. Scientific advice to policy is complex, and it is a difficult issue. It is far from being an easy and straightforward task. Science and policy nowadays involves a lot more than science and politics. It involves social license, authorization, social authorization. In that sense, there is a need to build a science-literate society. Turning scientific evidence in good governance needs the involvement of well-informed citizens, and nowadays needs also the identification and the segregation of post-truths that are sold as evidence. And And for that, we need a strong and engaged scientific community like the one that we see here, and we need initiatives like the ones that we see here for wider publics, including also initiatives for the politicians and for the politicians that are not strictly involved or directly involved in the sea and ocean affairs. Something that I learned when I arrived to politics, and I mentioned that I thought that everybody in the world was knowledgeable of the relevance and the importance of the oceans and as the regulator of the climate and the planet and the wealth of our societies was understood for everyone. I learned that it is not the case, and I learned from that for 30 years we were talking among peers, and we need to talk not only among peers, but we need to talk to the others more and more. Thank you very much.
Agradeço então que tomem os vossos lugares, por favor, para passar de seguida a palavra a Alan Simcock, coordenador do Grupo de Peritos da Avaliação Integrada do Estado do Oceano das Nações Unidas, para fazer a primeira palestra da conferência. The works will now start with Alan Simcock, Joint Coordinator of the Group of Experts of the World Ocean Assessment, United Nations, who will bring you the first presentation of the conference.
Simcock. It is S-I-M-C-O-C-K. It starts the title. S-E-M. No.
Simcock, this one.
That.
Okay.
It is the... That's it.
Só quando isso está ligado é que eu posso fazer. Estás apanhando? Estão a apanhar os dois? Toca os dois. Já puxei a pena. extend. Está no extend. Não percebo nada o que ele está a dizer.
Yes, I don't need that. I don't. Rector, Minister, Mr. Mayor, distinguished colleagues and students from around the world. What I want to talk about today, and I hope you can all hear me, is a conjunction of crises. We are not facing a single problem, we're facing a problem that consists of overlapping and interlocking problems. I would like to begin by just reminding you of some of the things I mentioned earlier and to take them on. In 1972, we had the Stockholm Conference on Human Environment, which was a landmark, a real step forward in bringing environmental issues onto the international stage. 20 years after that, we had the Rio First Earth Summit, which started to try to spell out the detail of that. It produced Agenda 21, the agenda for the 21st century, spelling out right across the whole aspect of the Earth's environment the things that needed to be done. 10 years after that, we had the World Summit on Sustainable Development, the future we want, when people started trying to put together the idea that we had to make sure that the planet had a sustainable future. 10 years on again, and we had the commitment to developing sustainable development goals. And then in 2015, we had the Sustainable Development Goals. That is the way in which sustainability has become part of the international discourse. It's still not sufficiently understood by everyone, but I think we are making progress towards that. I am one of the coordinators of the regular process, but why do we need a regular process? I think if we just think at a more microeconomic level, can you imagine a business that doesn't check on the state of 7/10 of its assets? It would be foolish. And how can we achieve sustainable development if we only concentrate on 3/10 of the planet and forget the other 7/10? So, as part of the development of the thinking on sustainable development, the World Summit in 2002 recommended a regular process of reporting and assessment of the marine environment, including socio-economic aspects. It then took 7 years to work out how to do that. It was not helped by the fact that we had the global economic crisis in 2008, which made people extremely reluctant to consider further expenditure. But we found a way of starting the World Ocean Assessment. What does the regular process consist of? Well, at its centre is the group of experts. Currently, we are 19 from 19 countries. Officially, we should be 25 from 25 countries, but unfortunately, we are lacking 2 members from the Eastern European group of states, and more worryingly, 4 of the 5 members which could be appointed by the group of Latin America and Caribbean countries. In the first assessment, the people from South America and the Caribbean played a very important role. We now only have 1 colleague. This, I think, is the result of political problems in South America between some of the states, which has paralyzed the group of Latin American and Caribbean states in the United Nations Assembly. To supplement those 19 people's knowledge, we have a pool of experts from around the world. Last time I counted, there were 770 of these from 76 countries, so that is an enormous input. And as we've heard, there are quite a number from Portugal. We also have help from the UN Secretariat and the UN specialized agencies. And what we have produced, are producing, and are going on to produce are the World Ocean Assessments. The first in 2015, the second due next year, and the third we are beginning to plan for in 2025. So, to come to the ocean, which is the theme of our subject, it is vast and unknown. Indeed, when you look at a picture of the Earth from space, you feel that the planet probably ought to be called ocean rather than Earth. We also need to remember that the ocean, that we have one ocean, even though we call it by different names. As you can see, the thermohaline circulation, which is the way in which water moves round the world, is crucial and links together all the different parts of the ocean. So we have one ocean and one planet. But how vast and unknown is this ocean? As I said, it covers 7/10 of the surface of the planet, but when you look at the actual volume of water, that's 97% of the water on Earth. And this is because the average depth of the ocean is 4 kilometers. So that this is an enormous part of the planet that supports life. In fact, somewhere around 95% of all the volume of the Earth that supports life is in the ocean. But we have studied very little of it. Vanishingly small part of the deep ocean has been studied, and we can still find completely new ideas. As recently as 1977, the new form of life, the hydrothermal vents, who get their energy not from the sun, like most of the life on Earth, but from the chemical processes involved with gases escaping from the core of the Earth. And also, again, as recently as 30-odd years ago, we found that we had cold water coral reefs as well as the tropical and subtropical coral reefs that we were all familiar with. And according to some accounts, a new fish species is identified every day. And against that, you have to remember that in the ocean are some of the most massively numerous species and genuses that exist. There is one genus, the cyclothone, the bristlefish, whose numbers are in the tens or hundreds of trillions of individuals. They're the most numerous vertebrates on the planet, and they play a crucial role in the carbon cycle because every night they come up to the surface to eat plankton and then go back down in the day to below the 200-meter isobath, and then as they die take their the carbon they have captured down to the ocean sediments. So there are enormous numbers and massive lack of knowledge about the ocean. But what we do know is that we have crises. I want to talk about 8 of these: climate change, fisheries, pollution, ocean space, shipping, biodiversity, energy, and to end with the question of governance. The first crisis, climate change. We are seeing a large number of changes in the ocean as a result of global warming. The sea surface is warming, the sea level is rising, both because the water in the ocean is expanding, and since there is such a vast amount of it, even a small increase in temperature will increase the volume, and also through the melting of the polar ice caps. We're seeing changes in salinity, we're seeing changes in stratification, that crucial factor about the ocean, that the water is separated into different layers which interact in limited ways, so that you can end up with a layer that is totally different from a layer a few hundred feet or a few tens of meters away. And we're seeing some changes in circulation, and most importantly, we are seeing the tropical storms moving nearer the poles. And this is particularly important in the northern hemisphere, where we're beginning to see areas such as the city of New York being affected by hurricanes in ways that they have not previously been affected. And this has massive implications for low-lying coasts. We are going to see some areas inundated. Coral reefs are affected by changes in temperature. If they go above 20 degrees Celsius, they tend to bleach. Changes in the plankton and consequently in the food web are happening. Fish stocks are moving. North Sea cod has diminished. Cod in the Barents Sea to the north of Norway has increased. We are seeing the loss of the polar sea ice and the beginnings of the openings of sea routes for ships round the north of North America and round the north of Eurasia, which have very significant impacts. It's 20 to 25% cheaper to go from East Asia to Europe around the north of Eurasia, and that is a big economic difference. And as it becomes more possible, we will see that happening. We're seeing changes in seaweeds. Kelps, which are a crucial feature of marine life, do not like growing in warmer water, and so they are moving polewards. And then we have problems with submarine cables. 95% of intercontinental traffic on the internet is carried in submarine cables. But when you have a tropical storm, the cables going over the edge of the continental shelf can be broken by submarine landslides. And this can cause major disruption with the internet, on which we rely more and more. The degree of global warming can be seen. This picture brings together 5 separate estimates, and although they differ in detail, the upward trend is obvious. And the rise in sea level is going to affect some of the major cities around the world. And as you can see, a lot of those are concentrated in South and East Asia. And we are going to see problems there with climate refugees as people have to move because their cities can no longer exist with the rising sea level. And there are other changes in the climate that are happening. Acidification is crucial. The carbon dioxide that we have been emitting for the last 2 centuries dissolves into the seawater and turns into carbonic acid, and that changes the balance between acid and alkali. And that affects plankton, it affects shellfish productivity. And we're also seeing changes in the ocean currents, which are bringing up more nutrients from the deep water, and that is contributing to nutrient pollution, to which I will come shortly. And the one good piece of knowledge here, though, is ultraviolet radiation. In the 1980s and early 1990s, it was very worrying that we had the hole in the ozone layer, which was subjecting the Earth's surface to higher levels of ultraviolet radiation, with effects on the reproduction of fish. The agreements on CFCs and the use of them in refrigerators and so on seems to have made progress there, and that shows that progress can be made, but it's a very small area. Looking at ocean acidification, you can see that the ocean is becoming more acid, more in the areas that are emitting more carbon dioxide, the North Atlantic, the North Pacific, but also, interestingly, in the Southern Ocean. And this is affecting the way in which shellfish produce their shells and the way in which corals are developing. The second crisis is on fisheries. We rely very heavily on food from the sea to give us protein. In some countries, as much as 1/3 of all the protein is coming from the sea. And a lot of this is being done in small-scale fisheries. 90% of the people working as fishers are in small-scale fisheries. And the more large-scale commercial fisheries take up much of the catch, the greater the threat to their livelihoods and employment is. Aquaculture is growing rapidly, and with it, the demand for food for the fish stocks that are being cultivated. We do not yet have major fish stocks under cultivation that use vegetable feed. Most of it is coming from fish meal of one kind or another. And we're also seeing problems in food safety. Subsidies are making the problems worse because they are encouraging increased catch without recognition of the constraints to which that should be subject. Reference has already been made to the long-standing view that the ocean was capable of dealing with human activities and that it was so vast. Thomas Huxley was one of Darwin's supporters who promoted the idea of the origin of species and evolution. In 1883 at a conference, he said that the multitude of fish was so great that human activities couldn't manage it, couldn't affect it. But he had an important qualification. In relation to our present modes of fishing, he said, and that is what has changed. We have bigger ships, much more mechanisms to bring fish on board and deal with them. We have GIS systems that enable ships to navigate much more precisely. We have eco-detection of shoals of fish. We have factory ships and freezing. We are starting to exploit species whose biology is not well known. A good example of that is the orange ruffy, where they do not start reproducing until they are 20 or 30 years old. And thus it is possible to fish out most of the stock before they have started reproducing and thus eliminate them. And this has been a real problem in many of the seamounts in the Pacific. But problems with orange ruffy also have occurred in the North Atlantic. And the way in which distant water fishing fleets are moving around the world is significant. The European fleets are active in Namibia and in the Pacific. The Taiwanese fleets are active in the Southern Ocean. We're therefore seeing large-scale mechanized fishing in areas that have never previously had it. This shows the way in which the global fish catch rose rapidly through the 50s, 60s, and 70s and has now peaked. It is worrying that we are now taking so much of the stock, and it is doubtful if that is sustainable. 25% of fish stocks are overfished, according to the FAO. We're seeing massive amounts of illegal, unregulated and unreported fisheries which are damaging fish stocks. And some policies, such as landing quotas, have had also damaged fish stocks. If you are told that you can only land so much fish, you will catch a lot more than that and throw away the stuff that is less valuable. It's known as high grading and has been a major problem. The European Union is making a significant change in requiring everything that is caught to be landed, but we have had 20 years of the common fisheries policy with landing quotas. The world population is increasing, and if we could manage our fish properly, we might get 20% more, so that we could have perhaps 100, 110 million tons of fish a year rather than the 90 that I just showed. The third crisis is pollution. We've got this from all sorts of sources: land-based inputs, sea-based inputs, solid waste disposal, and particularly marine debris, the plastic that is causing so much concern. There are two kinds of pollution: things that are harmful in themselves and inputs that are not harmful in themselves but which disrupt ecosystems. harmful in themselves are a whole range of metals, persistent organic pollutants, pesticides, oil spills, pharmaceuticals. And some of these are quite important because they may not be toxic, but they disrupt the reproductive process, the endocrine disruptors, and they can be found in various categories. And it's important that we understand that it's not just things that will kill biota that have to be thought about, but also things that will affect their reproduction. And there are other changes as well. I'm showing this slide because it shows the way in which in 9 years the Asia-Pacific region increased its chemical production. You can see how big a proportion the Asia-Pacific region was producing compared with the older European and North American production. That change is crucial because, as you will see, the Western Pacific is a very important area for biodiversity, and more runoff, discharges and so on from chemical industries will affect that. And marine debris is a big problem. We are seeing more and more concern about it, but the actions that are so far being taken are a small part of what is needed. And then inputs that upset ecosystems. They're basically nutrients. They get too much algal growth, then the dead the algae, the microscopic seaweeds exhaust the nutrients and then die. They die and take oxygen from the seawater as they rot. And we end up with all sorts of unpleasant consequences. One of the worst is in the northern Gulf of Mexico. This is the result of the river Mississippi's discharges of nitrates and phosphates, which is producing a dead zone every year. At its peak, it's about the size of Connecticut or the size of the state of Israel. And this is a large area in which nothing is living. The fish, if they can, swim out of it. The sedentary animals on the bottom die because there is no oxygen. And this is something that is happening all around the world. We have dead zones and low oxygen areas, hypoxic areas, in many parts of the world. Then the fourth crisis is ocean space. There is more and more demand for ocean space, particularly along the coasts. We have growing coastal towns. A growing proportion of the world's population lives within 100 kilometers of the sea. We have demands for space for aquaculture. We have shipping routes that need to have free movement. We have demands for ports. We have the need for more and more cables and pipelines, offshore oil and gas, offshore mining, offshore renewable energy, fisheries management areas, marine protected areas to safeguard biodiversity. All this is taking up more and more space, and there are conflicting demands, and we need to find ways of managing them. The Dutch fishermen a few years ago produced a campaign which they called Fishing on a Postage Stamp, as they argued that in the limited areas of Dutch territorial waters and exclusive economic zones, there were so many other of these activities going on that they were having less and less space in which they could fish, and they were reduced to, in their words, fishing on a postage stamp. You can look easily at the sheer numbers of different developments. In Faro, the marina will be an obvious item, but beaches, hotels, and the massive amounts of container shipping. And even where you have a beach, you can get it full, and that will also cause problems. Then the fifth crisis is shipping. Well, is there a crisis here? It's vital to the world's economy. Something over 3/4 of the world trade travels by sea. And we have the marine the Maritime Labour Convention, which lays down good rules, and we have MARPOL and its annexes, which lay down good rules for ships in relation to the environment. And the shipping industry is making progress. In 1912, when the Titanic sank and the first Safety of Life at Sea Convention was developed, we were losing 1 in 100 ships from a fleet of 33,000. By 2009, this was down to 1 in 670 ships from a fleet 3 times the size. And if you look at the loss of ships over 100 gross tons over the last 11 years, you can see that that too is declining. Very welcome actions. So the shipping industry is doing a lot. But where is the shipping crisis? If you look at the penguins around the Cape of Good Hope, you will find that they are being oiled by chronic discharges from ships. If you look at the seafarers, you find that more and more cases are coming to light of them being abandoned in port if they're ill and cannot pull their weight on board. And there are things like deaths on cruise ships, which never find satisfactory explanations for how people have died or disappeared. We have ineffective enforcement of MARPOL, ineffective enforcement of the Maritime Labour Convention, and we are seeing the shipping lines concentrating, and we're also seeing economic uncertainty, so that all is not well with the shipping industry. Then the 6th crisis, biodiversity. We have widespread patterns of biodiversity in the ocean. Temperature is crucial to this, and capture fisheries have a large impact, and we don't know a lot about a lot of the animals concerned. Oh, I'm sorry. I should have done. I'm sorry, I pressed the wrong button. Over biodiversity, we have a lot of challenges. We're seeing higher mortality and less successful reproduction. Part of this is because of overfishing and bycatch. Part of it is pollution from hazardous substances, including the eutrophication and noise. And some of it is changes in breeding and nursery areas as a result of climate change. And this has got a lot of implications for food security and the species structure of highly productive areas. As I said, it's important to know where species are concentrated. Biodiversity is particularly noticeable in East Asia and down towards Australasia. This chart shows in the brighter colours the areas where the highest levels of species are to be found. And as you will note, a lot of that is off East Asia, which, as I pointed out earlier, is an area where we're seeing massive increases in chemical production, and thus in the risk of chemical discharges and losses. Just to take one example, the whales. The southern right whale population absolutely plummeted as a result of whaling. It was the major source of oil for massive numbers of purposes and reduced the southern right whale population. It's slowly beginning to increase, as you can see, but it is still a very clear example of the way in which human activities can damage biodiversity. Then the next crisis is energy. We have the old issues about energy production from offshore oil and gas, exploration, exploitation with drill cuttings, oily discharges and chemicals, and then the problems of getting rid of the offshore installations. But we're also seeing new issues. Marine hydrates are a form of methane which is captured in ice at great depths of pressure and low temperatures. There are enormous amounts of marine hydrates around the coasts of the world. One estimate says that at the present rate of use of hydrocarbons, the exploitable marine hydrates would keep us going for 700 years. Now, we're all talking about the need to reduce our reliance on fossil fuel, but here is a fossil fuel that is quite massive in quantity and which, in certain circumstances, might be released to the atmosphere. The general consensus seems to be that at the moment there is limited chance of that, but there are real problems there. And then we have the need for clean energy to replace the hydrocarbons, and this is demanding ocean space and needs to be fed into the management of marine space. So the 8th crisis is that of governance. Have we got a system which can adequately manage all these problems? The regular process was told not to undertake policy analysis and not to make recommendations, but we can exhibit the facts and let people draw their own conclusions. My colleague Lorna Innes and I wrote a preface to the World Ocean Assessment 1, which we ended up by saying it remains for national governments and the competent international authorities to decide what action to take in the light of the assessment. We can only give the facts. We can't make recommendations. What we really need is integrated management that brings all these various problems together. We have to recognize that we've reached the point at which human intervention is no longer minuscule in comparison to the ocean. And the way things interact emphasize the problems from the lack of integrated management. Caribbean coral reefs can give you a very good example of this. This is what we think they should be. This is what we would like them to be like. With ocean warming, when they get above 20 degrees centigrade, they bleach. They can recover from that when the water cools down again, but not as well, and they remain at risk. Eutrophication happens because there are too much nutrients discharged from land, which encourages the growth of algae, and at the same time, overfishing reduces the natural controls on that growth of algae. We have invasive species brought about by the movement of ships. This is the crown of thorns starfish. It seems to have been brought into the Caribbean from the Pacific, attached to ships, because you can see it spreading out over time from the eastern entrance to the Panama Canal. And you have simple physical damage. The Caribbean is a popular cruising area, and the anchors of cruise ships damage the coral reefs. So that you have all those problems together. And then there are a lot of other issues. Benefits from the ocean are unevenly distributed from around the world. Some states have access to enormously productive shelf areas. But climate change will affect countries differently. I've already mentioned the northward movement of cod. We will see other changes in crucial stocks that support fisheries. And many countries don't have the capacities to benefit. We're beginning to see developing countries improve their position, but there's still a very long way to go. More than 50% of the ocean is not under any national jurisdiction, so it relies on international activity to set the rules. We at the moment have a very important negotiation in progress to protect biodiversity beyond national jurisdiction, the BBNJ process, which has been going on now for a good 7 years and which will, we hope, possibly reach completion in the course of 2020. But we've got a lot of international bodies with different responsibilities, and national jurisdictions do not have an easy thing because they have different powers in their territorial sea, in their economic zones, and on their extended continental shelf. And we have ships at sea moving round with very limited enforcement controls. If you just look at the list of international bodies involved, you begin to despair of the thought of ever trying to get this coordinated. So we have urgent action needed Some problems can only be dealt with globally, but many are local and they need to be dealt with as soon as possible. Not implementing those solutions imposes costs in environmental, social and economic areas, in other words, in all three aspects of sustainable development. So, my conclusion, we have massive problems. We're trying to provide the data for decision making around the globe, but we need national governments and international organizations to take up those challenges, and we may need to think more about the way in which we govern the oceans. There are helpful signs going on. There is an initiative from Norway, which is bringing together the heads of state and government from a dozen countries around the world, of which Portugal is one, and others such as Mexico and the Philippines and Japan and Australia are also involved. That may be a catalyst for further action, but we really do need to make further progress. If you want to follow it up, look at the Regular Process website. Thank you very much. Things they disagree with what I've said, I hope they will stick up their hand and let us know what they think. I've clearly either bored you into submission or stunned you. We have someone there.
Thank you very much for your presentation. Can you hear me? I don't hear very much.
Perhaps if you stood up and looked across the room, it would be better. We have a roving microphone.
Okay, thank you. Thank you. Nuno Lourenço from CEIA. Actually, you touched some of the points that I'm speaking afterwards, after the coffee break. Thank you for the presentation. And more than surprised, I got depressed because there are so many crises, so many issues that really bring problems. My question to you would be, and deals with governance, but deals especially with one of the questions which strikes me, even in the Atlantic, where margins are of well-developed countries with a lot of resources and means to act in terms of, for instance, scientific knowledge. Why can't we still have any capacity to at least articulate the infrastructure, the means to operate in the oceans and get the data we need for the policies we want to convey? Thank you.
In Western Europe, I think we have seen a major... I have a microphone here, so I think you can probably hear me. In Western Europe, we have seen major progress with the Marine Strategy Framework Directive, which has established a way for the whole of the European Union of looking at the way the ocean is developing and trying to highlight the problems that need to be solved. How that will develop, I don't know. And if my country is sufficiently foolish that we end up leaving the European Union, that will raise a whole range of further problems. So things are not very good. On the other side of the Atlantic, you find that Canada has remarkably little investigation going on about pollution, either on the Pacific coast or the Atlantic coast. The United States did have some very good surveys, the National Coastal State reports, but they don't seem to have been producing them since about 2012. The most recent periods, they just seem to have stopped producing some of the reports, perhaps because they were showing some things that the central government, the federal government found unwelcome. I don't know, but even in those areas, there are problems. On the other side of the world, in China, we are seeing much more development. If you look at the Chinese State of Marine Waters reports, you see that they have put very large areas in what they describe as worse than Category 4, which basically means they're more or less dead zones. This is the result of massive sewage discharges, industrial discharges, and so on. If you take the Bohai Sea, which is the little area of sea between the Korean peninsula and the Chinese mainland. That little area, it's not that little, it's considerably bigger than the North Sea, for instance, but it's still a limited area. That is receiving the sewage discharge from about 1/6 of the world's population, and they haven't got proper sewage treatment. So the Bohai Sea is a real problem, and getting cooperation in that area is not easy. If you look at the Regional Seas Programme there, the Northwest Pacific Action Plan, you have got Russia, China, North Korea, South Korea, and Japan. And you just have to list the countries round there to see what the chances of getting easy agreement on how to take things forward are. So there are real problems, and I would be misleading you if I suggested that we are making real progress in this area. Over there, please.
Hi, Joaquin Hernandez from Air Center. I would like to ask you in which way during the next 8 years we can maybe use much more data information tools. At the end of the day, we are treating with big data, and if in some way the centers, the research centers especially across the world, can have a mechanism in order to report and help on the assessment, perhaps that will be also a way in which we can have much more information and also make this information much more available through the whole community.
I agree with you that that's a very important area to develop. Obviously, developments have been going on. We have the International Council for the Exploration of the Sea, ICES, which is the oldest environmental international body. It's been going now for 116 years. They have very good systems for the North Atlantic, Mediterranean, and so on, for bringing together the necessary information. On the other side of the world, the North Pacific Marine Science Organization, which everybody I think calls PICES, Pacific ICES, is doing much the same, and which is doing very well. We have, at a global level, the Intergovernmental Oceanographic Commission, which has set up OBIS, which is the information center on reports of marine biota, which is based in Flanders. And that again is doing a very, I think, an important element of the international decade of ocean science for sustainable development will be improving this. But there is a big contrast between the Northern Hemisphere, where you have ICES, PICES, and so on, and collaboration, and the Southern Hemisphere. We have, in the Southern Hemisphere, we have the Nairobi Convention, which looks at the very westernmost part of the Indian Ocean, but which does not go beyond the national exclusive economic zones. We have the Bay of Bengal Large Marine Ecosystem Collaboration, which has done a lot of good work, but you only have to think about the South China Sea, which is one of the world's biodiversity hotspots, but where it's also one of the world's political hotspots as arguments go on over who owns which bit of rock. And trying to get collaboration there is not going to be easy. We also have South America. On the west coast, the Permanent Commission for the South Pacific does a good job and is increasingly working well. But collaborate, I mean, Brazil is a marine region in its own, and so is Argentina, but the relationships there, though not as bad as in the South China Sea, don't make for easy collaboration. But we really do need to get further progress. The Benguela Commission is beginning to work in the area to the west of the African mainland, but that is only just starting, and we haven't really got anything for the Guinea current area or the Canaries current area. So we need to see this, and I'm hoping that the International Decade will produce this, but it will take uphill work. I don't know whether you share those views or...
We have a lot of information, even with the satellite observation, we have a lot of information in the north, but not so much in the south. And the scientific diplomacy, I think that also could play a chance here, because sometimes it's difficult to work with some countries, but at the research level between the institutions, sometimes it's much easier to have permanent links and share information. And I think that is where the Air Center is working on and trying to connect the different centers and share information on that.
Thanks a lot for your speech. André Beirão from Brazilian Naval War College. I've looked at your crisis, and I'd like to ask you about the challenge of mining at seabed, not only at the zone, but including in under national jurisdiction areas. We are facing a growth of this kind of uses. And how do you see this? Is it already a crisis or just a challenge?
I think I would say that it's a challenge rather than a crisis. We do at least have the International Seabed Authority, which is looking at the zone, and where debate is fairly open and fairly detailed. What is happening in national jurisdictions is much more difficult to trace. Papua New Guinea, for instance, has problems. Dredging for diamonds off Namibia is another area where it's not clear that the discussions that ought to go on about the relationship between the possibilities for obtaining minerals and the impact on marine biodiversity. You need to have a debate, and in some parts of the world that's not happening. There is no doubt that the economic pressure is going to be very strong to produce minerals from the ocean. You only have to look about the copper, which is a crucial element for industry around the world. The richest ores of copper from Chile, I believe, produce about 0.9% copper per ton of ore. It's estimated that some of the sulfide deposits on the seabed could produce as much as 7 or 8% copper per ton of what is removed. And that's 2 orders of magnitude almost, so that you're going to see economic pressure for development there. And then the question is, how can it be balanced with preserving the marine environment? Some people would like to see a blanket ban, but I don't think that that is credible. The question is to get the discussions going about how you safeguard the areas, which areas you choose, and what techniques you impose. I mean, one of the problems with offshore oil and gas is that in the Northeast Atlantic, we have a very strict regulatory regime for everyone, and it's well observed. The oil companies have said that they will apply the ISO 14000 rules, not merely in the North Atlantic, but in their other activities around the world. But that, I think, is an undertaking that is frequently broken, and that the way in which some of the big oil companies operate in offshore areas of Africa or Asia is nothing like as good as they do in Northeast Atlantic. Can you, there's a lady sort of halfway back on the left-hand side.
Hi, Alan. Thank you for your presentation and participation in this event. I was hoping you could touch on how we can be better about translating science into action and the importance of science communication.
Well, scientific literature, marine science literacy is a crucial thing. It's very difficult to achieve. If you've even tried to read World Ocean Assessment 1, you will find that many of the chapters are very difficult to read. I think I found the most difficult one, the one on the biodiversity of the Arctic, where the people who wrote it were writing for themselves, not for a wider audience. And in spite of our best activities to get them to rewrite it in a more intelligible way, it is very difficult. Some chapters, I hope those that I was involved with, are more easy to read, but it is difficult. And you need a major activity to publicize it. You'll be aware of the Intergovernmental Panel on Biodiversity and Ecosystem Services, IPBES, which produced a global assessment of land and sea last year. I was brought into that to try and make sure that the ocean was covered somewhat more than the original plan, because that had been written mainly by terrestrial ecologists. But they have achieved quite a lot more than the World Ocean Assessment has, and this has been largely due to the fact that the Norwegian government has supported a special unit for putting out the story that was coming out of IPBES. The budget for the World Ocean Assessment has never contained anything like that. The UN Secretariat does not find that a particularly easy activity to undertake. They are focused on servicing the member states, and the idea of going out into the hedges and byways and trying to buttonhole people and make them understand is not something that the UN Secretariat is particularly structured to do. That's where IPBES is lucky in having a separate secretariat that has been able to mobilize resources. We need more on that, but it's not easy to get the resources to do it, and it's not easy to find the specialists who can write in the way that will attract attention. In the United Kingdom, we are fortunate in having David Attenborough, who is regarded as a national treasure. He's now 95 and may not be available much longer, but he is at the moment in the process of doing a very good series, which is going out on Sunday nights at the moment, which is highlighting the problems of climate change on both land and ocean. The episode on the Antarctic was particularly good on the ocean. Obviously, for some of the bigger land masses, it's not so good. But finding people who can do that, getting the resources to do it, is an uphill struggle. Gentleman in the middle of the back, please. Maria, I hope you'll tell me when I've got to stop.
Hello, and thank you very much for the presentation. I am a father of a 3-year-old boy, and as a researcher in the oceans, I'm trying since a while ago, give him some notions about how to protect the oceans, especially through plastics and small stuff. But I'm feeling like looking at the future, that is going to be really hard to explain to my kid how to protect the oceans at the same time as exploring it. I would like to ask you your personal opinion on this subject. Do you think we can continue with these ambiguous policies on ocean governance, at once exploring and the other one protecting? As how long can we go with it? And if not, when do we stop and decide which path do we want? Thank you.
Well, my personal view is that we have to keep on with it, and the problem is to find the right way to have that dialogue between getting what we need and protecting what is there. this is something that you can actually make progress in. I think the European Union's Marine Strategy Framework Directive is a first step in that direction, because it's trying to make sure that we know whether we have got good ecological quality and whether what needs to be done to maintain that. But at the same time, it's allowing for proper fishing rights. We need the food from the sea, as the statistics I gave, I think, show. So it's a real problem to find a structure that will do this. The United Nations at the moment is not well structured for this, because we still have the silo mentality. We have fisheries in FAO, we have shipping in IMO, we have the International Seabed Authority for seabed mining. Hopefully we will get something for the protection of marine biodiversity beyond national jurisdiction out of the current negotiations, but that will to some extent be another silo. And the problem is how to bring them all together. 15 years ago, I was involved in developing the idea of the UN Forum for Oceans, which could look at any aspect of it. I'm glad to say it's still meeting annually and looking at particular issues across the board, but we need to try to find a better way of bringing together the international organizations, and I don't think that will happen until we have got better integration at the national level. While you have got ministries of transport dealing with shipping, and ministries of fisheries dealing with fisheries, and ministries of the environment dealing with environmental protection and fighting each other, they're going to go on fighting at the global level as well. We need to find some way of getting better focus. It's not easy. I mean, for 10 years I was responsible for trying to integrate the UK's policy on the marine environment, and I had 23 different parts of the UK government to try and keep in play, which was a challenge. It was easier when I had a minister who was a powerful minister in his own right. It was more difficult when I had a minister who was regarded as lightweight and peripheral by some of the other departments. But it's that sort of struggle that we have got to keep up with. Fight on is, I think, all I can say. Yes.
Pedro Monteiro, Regional Director for Agriculture and Fisheries. I would like to first congratulate you for the objective and very relevant presentation. With so many crises, I keep in mind, I think it were 8 you referred. For you, what will be the most difficult to deal with?
Climate change.
Climate change.
You know, it's not merely the ocean. The climate change is a problem for the whole planet, and it requires so much to be done. I think other things are more easily managed than that. But they all need managing. And the crucial question is integrating the activities. Climate change is something that is actually fairly well integrated, in that the Intergovernmental Panel on Climate Change has now been going long enough that it has established itself. Its reports are authoritative and clear, and countries are beginning to respond to them. Unfortunately, the World Ocean Assessment has started 15, 20 years later than the climate change people, and it will take us, I suspect, 15 or 20 years to build up to that. I can only hope that successive assessments improve and focus on these. But unlike climate change, where there is a fairly single issue, how do we stop global warming? There are others, but that is the crucial one. Dealing with the ocean, as you can see from my presentation, spreads across such a wide canvas that actually keeping things in focus and in step is difficult. Have we more time? Another 5 minutes. I'm told we have another 5 minutes. Does anyone want to raise something else?
Nobody wants that one. I have to ask I would like to ask you one thing about, I came from an institute which I used to work in an institute which gathered atmosphere studies and marine studies, called IPMA here in Portugal. And so I got acquainted with the processes of the World Meteorological Organization. So why can't we have a World Ocean Organization?
I think probably because it covers too big a field. We already, as I was saying, you have these silos at national level, and it is not going to be easy to see how they are going to give up their independence.
Can we put an umbrella on top of them?
Well, that is what the forum under the United Nations General Assembly was trying to do, to try and get discussions that brought together IMO, FAO, and so on. The UN has a system called UN Oceans, which brings together all the UN specialized agencies and programs involved in the ocean. But it is at a very limited level. It has very limited resources. It tries to have virtual meetings, I think about once a quarter, but it isn't sufficiently significant. And this is really where the problem of the ocean comes, that it is such a big problem that it's difficult to see how you can do it. I mean, the present UN Secretary General, with his Portuguese background, is perhaps not surprisingly very interested in this. And he is being helped by the special representative for the oceans from Fiji, who is definitely making an impact. And these regular ocean conferences, of which Portugal is going to be co-host next year, are helping. But it is a very, very slow process. It's taken nearly 10 years to get the BBNJ process going. It took 7 years to get even the World Ocean Assessment off the ground after the UN General Assembly had said that it was a good idea. It's like the water dripping on a stone. It will eventually wear it away. The question is, can we get there before disaster has happened?
Thank you very much for this overview of the Second World War assessment. But I've seen that you have also on this World War assessment the issues about society and economy, social issues and economic issues. And these were not included in on the points of the crisis. And I remember that you mentioned on your list of international events the 72 Stockholm conference, where Indira Gandhi made a great speech that I think is still valid today. She said more or less how we can make people that live in slums and poor village to care about the pollution of the sea, the rivers, and the oceans when their life is polluted at the source. And this is a question. We cannot solve, in fact, environmental crisis without solving social crisis at all. And I think this is a major issue that we have to take in consideration in terms of governance. This is, at my best knowledge, this is the third United Nations approach for sustainable development, the third. The others were not called, the goals were not called SDG, they had other names. And the first was always end with poverty and hunger. In fact, in the two previous one was extreme hunger and extreme poverty. In this one, it's only poverty and hunger, and I hope that was an evolution in this kind of things. But the main issue is still we cannot solve any environmental issues without solving the social crisis. And what is the approach in this report? And how are you dealing with the issues of social economics?
Well, there are, I think, 4 points I'd like to make. The first is that I did try in my presentation to bring out some of the social issues. I referred to the fact that 90% of the people working in fishing are working at a minimum, at a very low level, and that their livelihoods are threatened if we see increases in big commercial fishing. We are seeing problems in shipping, where we rely on relatively poorly paid people from East Asia to provide a large part of the crews in the world shipping, and they are to some extent exploited. The crucial thing was my slide on distribution of benefits, because what we have at the moment is that there are a lot of countries around the world, particularly in Africa, but also in Asia and South America, who do not have the resources to get the benefits from the sea. And you then have further problems. I mean, the sort of tiny detail that it can't be brought out easily in this sort of presentation is that of poor landlocked countries, places like Mali or the Central African Republic, who are dependent for their trade on access through other countries to ports. And in many of those countries, the coastal countries, you have high levels of corruption, so that the customs, the border police and so on are extracting money from the drivers who are taking goods from the ports through the coastal countries to the landlocked countries. And they are really impoverished as a result of resources being siphoned off for the benefit of the corrupt officials in the coastal countries. And this is the sort of thing that you can only deal with as part of the whole structure of society. So there are so many facets of this that it's difficult. But I think one of the crucial things is making sure that countries are in a position to manage their marine resources well. And here again, I think Norway has made a really big contribution. I don't know how many people here have come across the research vessel called the Fridtjof Nansen, which is run by Norway for the benefit of basically tropical African countries. And what it is doing is giving them the scientific basis on which to establish fish stock assessments and start to manage their fish stocks in a sensible way. And it's that sort of very practical work that needs to be done. How you can get more of that is something I hope that the International Decade will look at. Certainly, we are looking in World Ocean Assessment 2 as to how we identify the capacity building needs and the information gaps that need to be dealt with in the International Decade and thus feed into the process. That's something that we shall be discussing at our meeting in December, because some of our colleagues are actively preparing for that. I don't know whether that answers your question, but certainly, you know, it's this sort of complex of issues that we have to deal with.
Okay, thanks very much, Alan, for your excellent and discussion. So we're going to break for coffee. So we reconvene in 15 minutes, okay? Thank you very much.
Som 2. Som 2.
Fechou, né? Agora vamos segurar. Está aqui o 2.
Não, deixa, isto é feito no Chile, isto não respeita nada agora. Eu vou testar lá embaixo. Empresta-me esse também.
faz ruído nenhum. São 1, 2, 3, 4, 5. Não há ruído nenhum.
Não, está ótimo. Está fixe. É. O
aprender só com o Alberto, ele vai querer fazer o filme lá, e conforme for se precisar.
explicar. E depois, inglês este para funcionar? Já vou falar já uma? Se você não quer que funcione, mete-se em mute. Já está. Explica. E este é o ponteiro laser. Direita, quer ver? Direita para a frente, esquerda para trás. Deixa eu passar assim. Você se quiser apontar, vai. Se quiser. Não, desculpa. São estes dois. Este é para trás, foi o que fez o barulho, está a ver? Este é para a frente. Só que já não se vê, né? A seta já desapareceu. Se tocar no de baixo faz mute. Se fizer muita imagem, carrega outra vez. No final. Colocaram, não sei.
Pois. Bom, vamos recomeçar. Atenção. Vamos recomeçar esta sessão da manhã. Let's start with the new sessions in the program of this conference. The subject of this session is strategic steps for the ocean. That you know on the program you can see it. We have two guests on my right and on my ultra right. Miguel Marques is a partner of PricewaterhouseCoopers. He is an expert of the problematics and challenge of the sea. He is also a member of the advisor committee of the Center of the CIMA, Center of Marine and Environmental Research of these universities. And Nuno Lourenço, on my right, is a former professor of the University of Algarve in the area of marine science, in the CIMA, I think. And now he is a researcher at the CEIA. It's a Center of Engineering in the north of Portugal. Thank you very much for your presence. I can ask to Miguel Marques to present, to start. Thank you very much for your...
Good morning, everyone. I'd like to thank Professora Bebiano not only for this fantastic event and relevant event, but also for inviting myself to be in the advisory board of CIMA, and I'm so proud of that and the work CIMA has been done, and also the example of the executive members of CIMA that are always asking questions to the advisory board. Thank you so much. So I'm here just to share with you part of the challenges of the problem on the oceans and also maybe some attempts of solutions. So as a background, I'm an economist. I've been working in PricewaterhouseCoopers for the past 21 years. So my vision is company visions, economic challenges of the countries and of the regions. So, and one thing I've learned in the ocean is that it is so much multidisciplinary that we only can take part of the pictures and of the photographs of what is happening in the ocean. So I became a kind of photograph of numbers of the ocean. So, and what to do with that numbers? We decided to offer to society that numbers without any analysis of it. Because we also learn that each individual thinks differently, each community thinks differently. So what we can do as people of science is gathering facts, release that facts, and jump to discussions. So this is the reason I'm here, to share facts and jump to discussions, because the solutions will not be in a computer button as everyone is saying with the digital revolution. Is much more efforts needed than that. So also thank the organizers about the title of this Stress in the Ocean, from multidisciplinary approaches to transdisciplinary research. So some months ago, the UN asked us to go to New York to share these numbers because it seems that they are relevant. And part of what I'm going to share with you today is part of what I share there. And the results come up that there is the need of a transdisciplinary research to solve these problems. The first fact is that the Paris Agreement is not in the right track. As we are people from numbers, our office in London tried, and I think at least did an estimation of quantitatively how far are we from complying with Paris Agreement. And if you go to the arrow there, the 7.5 is what it was needed to decarbonize to get the global warming up to a maximum of 2 degrees. But what is happening, in fact, is that we are only decarbonized at 1.6%. So this is just an estimation for our colleagues with the information that exists that shows how deep are we not complying with Paris Agreement. So, and in these talks we have, yes, there is a lot of energy to try to comply, to try to be sustainably, but in practice, in the field, at a global level, the track is not that. Our behavior as human beings does nothing to do with sustainability. We are diverging on that sense. So in the past 15 years, we've been releasing the numbers, the reports. So we also have worldwide reports, reports for Portugal, of course, for regions in Portugal, but also for the US, for Turkey, for other countries that we prepare here. PwC has its Global Center of Excellence based here in Portugal. So we support all our countries. We are in 150 countries and we are about 270 people worldwide. And so our aim here in Portugal is to share with our network to help their countries. So, and we release these reports for free. But for us to try to photograph as economists the numbers is fundamental to understand some words. So what does it mean for PwC, the integrated approach? For us, in practice, pragmatically, we are in the field of an integrated approach if we find a common benefit for the silos that the world has. So, for instance, if we go to Bergen in Norway, as Norway was stressed here as an example, and we see that when we are going to the tourist office and we are invited for a visit to aquaculture plants and we are served food, we see here that the aquaculture sector joined forces with the tourism sector, which in the past was difficult, and in the world we are not yet there. So this is a tiny example of which is for PwC the execution of an integrated approach. Or if we go to Hamburg and we see how in the past Hamburg was strong in shipping, and I totally agree what was said that shipping is under stress for sure, and Hamburg at the moment is an example of that stress. So more and more, if you go to Hamburg and you speak with businessmen on shipping, you see they use words like merging, cost reduction, dismantling ships. There are too many ships, and also there are the need of new ships, and the old ships are no longer of use. So there is a huge transformation that is happening. But about Hamburg and integrated approach, in the past, there was a win-win situation in between shipbuilding, shipping, finance, and insurance. These four industries together won a lot of money and profits because they come up together. So these are the kind of practical examples when we use the integrated approach, what we mean with that. Also for us, when we speak about blue, for us is a tri-dimensional context with water surface, water column, seabed, wind above the water, sky above the water, aerospace above the sky. So all these three-dimensional aspects must be considered in the equation. If not, we will not come up with the right solutions. What we do with the numbers, as I told you, we offer the numbers with society in our report called HELM, the PwC Economy of the Sea Barometer, that is available in the internet. But the way we communicate to society, try to take out of the space the communication barriers of the specialists to common citizens. So we try to use infographics, we try to use sentences and numbers that everyone understands, and there is no need to be a mathematician or an economist to understand the main conclusions. As with this map, which we call the Economy of the Sea map, we see how unbalanced the ocean is being used by mankind. This is not a hydrographic or geographic map. This is a socio-economic map. The dots there are the head office of an industry or of an activity. And you see that the Asia Pacific, the Far East, mainly led by China, took the lead in just 10 years. In just 10 years, China is number one on ports. For instance, in the top 10 of container ports, China has 7 ports, and only Asian countries are in that top 10. If we go for top 20, it comes Rotterdam and maybe LA or New York as the North Asian ports. So to understand the magnitude of the unbalanced use of the ocean when we look to continents. But also China is responsible for about 20% of fisheries in the world, about 60% of aquaculture in tons in the world. So if China wants, can somehow control food protein prices that come from the oceans. Unfortunately, also this map shows us that there is a kind of piracy belt around the equator with hot spots in Indonesia or in the Gulf of Guinea, that it seems that is being replaced. The past problems in Somalia, they moved to west, and also we find that black dots on the equator. Internationally, there is some debate about what is piracy, what is robbery, so I'm not entering on that. If there is a gun issue in the ocean or in a port, we put here a black dot. This means that South Hemisphere will be a lot of difficulties, for instance, in explore sustainability tourism, because if there is a security issue around their oceans, at least tourism will be affected. Unfortunately, here in the West, despite of we being very much developed in terms of technology, we are yet very extractivist. So oil, particularly in the northern part of Atlantic, is a relevant industry, so we extract oil. We also are good in tourism and sports, and we are becoming very good in terms of renewable energy, particularly on the northern countries. Also, cruise is an industry that the West leads. So the world is unbalanced in terms of the use of the ocean. Let me just bring the attention for some key figures that we have always in our mind. So 3 countries in Asia represent 84% of shipbuilding. 3. How can the world be sustainable if produces 84% in the same spot? 2 countries in Europe represent 65% of renewable wind capacity. Okay, it's an emerging industry. We hope that other countries join also to the party. If not, it will become like the issue we have with the shipbuilding. 4 countries in Asia represent 86% of world vessel demolition, even worse. 86% in 4 countries that we are demolishing vessels. Caribbean and Mediterranean Sea represent half of cruise passengers, so, and the Caribbean Sea and Mediterranean Sea is a little percentage on global ocean and seas. And 3 countries in Asia represent 75% of world aquaculture. And if we would put also, we are upgrading this map. In January 9, we are going to release our upgraded version including plastical islands and also pollution, extreme pollution in the shores. And unfortunately, this huge quantity of aquaculture produced in Asia also coincides with major issues with pollution in their shores. So this is about the dimension of the unbalanced use. But about speed. The speed is even more spectacular. So we have here, for us in PwC, we consider that the ocean needs more time to do things than on land. We count time in slots of 5 years. For us, 5 years in the ocean, it's almost the same as 1 year on land. So 20 years for us is 4 short-term periods. And in these 4 short-term periods, at least we can quantify that almost all industry double the use of the ocean. So the ocean is being, has a lot of pressure. And one thing that technology did was that no longer the ocean can defend itself only by its wildness. What do I mean with this? In the past, parts of the ocean were unreachable with the level of technology we have. At the moment, we already have a lot of technology that became that spots on the ocean became less protected by their wildness. What do we think about the blue economy? We think it is an answer for all the SDGs, all, not only the 14. For us, we see the blue economy as an answer for all the SDGs. If I had time, I would love to share with you in each topic of each SDG, the ocean has more strongly or less strongly an impact. But let me go with you with these challenges that are the mega trends. So more and more, the big cities are in the shores, and they are growing fast. And interestingly, a lot of the population of that big coastal cities are not very much aware of the challenges of the ocean. Also, the technology breakthroughs, I already told with you that with satellite monitoring, also robot use, more and more we can reach to different places that were kind of protected by the wildness of the sea, and no longer they are protected. About the climate change, in the previous presentation, a lot of things were said, but if we cannot tackle this huge challenge, massive problems can arise, particularly because more and more people are in coastal cities. About demographic and social challenges, we are analyzing that, unfortunately, less people want to work on ocean. Particularly if, as more developed is the country, less people want to work on the ocean. I'm talking about massive population. I'm not talking about researching. More and more people on research. That's an outlier, which is very good. But for instance, recently I was in Singapore, and when I spoke in the schools of the new skippers of Singapore or people that work on the shipping industry, I do not see the anger of the past. And the nationalities that are arriving are more Indonesian and Philippines, which is good. They are good sailors as the others. But it seems that there is a tendency, as much developed is the country, less interest on working on a day-to-day basis, floating on a vessel. In terms of shifting in global economic power, we know that China has a strong project that is called One Belt, One Road, and that is impacting. First decision of Chinese government was to massively bet on shipbuilding. So it is why they are number one in shipbuilding, because they have a strategy for the ocean in terms of transport. But they also have a strategy on ports. It's why they are number one. And almost everything sums up, in our point of view in China, to the execution of the One Belt, One Road initiative. To conclude, so in these 15 years of experience, which is a part of the picture, as I told you, what we saw in numbers is, for us, is clear that there is a natural infrastructure on the ocean that is much more heterogeneous than homogeneous. What does it mean? It seems that when we are in a table discussing about the ocean, and I truly believe on the concept of one ocean, yes, the ocean is interconnected, but it's a kind of interconnection of different fingerprints. Each spot on ocean, in terms of chemistry and in terms of physics, and I'm not on that field, but it seems from talking with you that is different. And also tradition in Portugal showed us it's not a matter of hazard that our traditional boats are different from some kilometers to some kilometers. It's because currents deep, the fish is different. So, and this is a urgent call for the natural scientists to do the draw of these differences, of these fingerprints. But the challenge is that with the global warming, what happens is that in different years, we will need to do different pictures because this is a dynamic situation, and unfortunately, we didn't study a lot in the past, but in the future, we will have to catch up. But more than that, we must have an infrastructure that continues to study because of global warming. There are huge differences in between years. But a thing that is of my area of studies, which is socioeconomic, when I speak to a surfer, he speaks to me with the value of the wave. If I speak to a diver, he speaks about how clean is the ocean, the biodiversity. If I all the coastal states of Brazil, if you go to Bahia, you find religious aspects related to water. So, if we only study the natural infrastructure and we jump to solutions based on that, probably we are going to create massive social conflicts. So, hand in hand with the need of characterize the natural heterogeneity of the ocean, we need to understand the socioeconomic infrastructure. And on that area, we are in the beginning, and we, PwC, are here to try to help on that. Thank you so much.
Thank you, Miguel, for your speech. And now it's Nuno Lourenço.
So good morning to you all, and I would like to thank Maria João Biano and the CIMA team for the invitation of SEI to be here. So it's a pleasure to be back to this university where I used to work. So my point on this presentation, which will have to be short because I think we are running short of time, is to pick on what Alan was speaking earlier about governance and about the difficulties of governing the oceans, especially in the areas which are not related with territorial or sovereignty seas. This is called Science and Governance Convergence for Ocean Sustainability. It exists. The problem here is not the convergence, is the speed at it converges for science to help governance. It could also be called defragmenting a fully and highly fragmented system, okay, which is the governance system internationally for the oceans. So this is the contents. I'll set the scene for ocean governance, especially in what relates with the pressures from blue economy, the constraints posed by UNCLOS, the Convention on the Law of the Sea. How can we improve governance through scientific cooperation in the oceans? And I would like to leave 2 or 3 take-home messages from this presentation. So I think that scheme taken from ICES makes the right point for what we have to discuss on this presentation is how do we find the balance between sustainability on the environmental terms, to the left, the natural values, and to the right, sustainability in the social and economic processes. And this balance is not easy, and of course it should be science-based, okay? Of course, governance deals with policy. Policy has to be taken from, through information taken from science, regulation, and enforcement. Alan already showed some of these, so there are a lot of pressures over the ocean. I've just selected these ones, the hypoxia zones, acidification, has been spoken before, overfishing, marine litter, all of these in a changing ocean, where climate change is the key factor affecting all of this. And so governance would be an answer, but there's a problem with international governance. Carmo Vela, the commissioner, the former commissioner, with the High Representative for Foreign Affairs in the EU, issued this document, International Ocean Governance and Agenda for Future of Our Oceans, and put it to public consultation. And you can see from the results that about all the stakeholders involved in ocean were reporting that they consider international ocean governance ineffective. And they all focus on the same 3 main pitfalls, okay? Lack of knowledge about the ocean, inefficient implementation, insufficient coordination, and gaps in existing international ocean governance framework. I would argue that part of this comes from UNCLOS itself. UNCLOS is a constitution for the oceans, okay? And of course, seabed is taken through Article 76, comprises territorial seas, contiguous zones, continental shelf, and the area, which is run by International Seabed Authority, a UN body. But when you go to the water column, you have problems because, okay, everything is settled from the baseline until the EEZs of the coastal states, but then you get into high seas. And high seas is a problem because high seas is subject to not a single regulatory scheme, but a myriad of regulatory schemes, as I will show. So what is studied in part 7 of UNCLOS high seas, I would go directly to the second point. These freedoms, freedom of high seas, shall be exercised by all states with due regard for the interests of other states. So basically, there's not a ruling and governing body. What it is a state speaks with another state or speaks with several other states in conventions or creates committees to resolve problems. And this is a tedious process. It takes a huge amount of time. Alan was speaking about BBNJ, 10 years, 20 years, it goes on. And probably the answers we need from the oceans to take care of the oceans should be sooner than that. Of course, this kind of approach for the high seas, the freedom of high seas, makes what you would suppose to make a huge fragmentation and a myriad of institutions, committees, conventions that deal with different regional areas, with global areas, with, as you pointed out, some of those, shipping on IMO, International Seabed Authority for the seabed, UNESCO, IOC, International Oceanographic Committee, it goes on. And then we have a second round and the third realm and the fourth realm, so it's too much to really get coherent, effective answers to the governing of the ocean. So this deals to, one, fragmentation, of course. The second will be lack of coherent uniform regulations and lack of clear enforcement mechanisms. And this is where really the main twist occurs, because even when something is going wrong, and even when this is covered by some of the conventions, there's no enforcers to correct what's been done wrong. I'll show you an example. So, first of all, this is a picture in the paper from Colasso on the assessment, which hopefully will come out. Let me try to go very fast on the colors. So white is the area, but white is also the high seas. When you go, it doesn't show, but you also have the extended continental shelves across the Atlantic. This is, of course, sovereignty for the countries. but is also high seas in terms of UNCLOS. And what you see there is that the blues are ecologically and biological significant areas. Greens are national parks, marine protected areas, sorry. Reds are high seas, marine protected areas. It goes on and on. On the reds, on the right side, you have concessions from ISA. And one thing that is noted already is that when you see the abscess there, they overlap with mining concessions. So we have a marine spatial planning problem. I don't have a pointer, but I hope you see it. I have a pointer? Okay. Okay. So this here matches that segment there. So there's a conflict of uses and of conservation versus use. Wait, sorry. Another thing is that you see these RFMO, so regional fisheries management organizations. So you have a lot from the North Atlantic, some on the Antarctic and the Southeast Atlantic, but they are unregulated areas for fisheries. And this poses enormous problems in terms of illegal fisheries, illegal, unreported, and regulated fisheries. You can even figure out vessels fishing within EEZs and coming out to transfer the fish to other ships on the high seas. So nothing can be done about it. There's a thing here about Brazil. I hope I'm correct. The oil spill in Brazil, northeast, still the source has not been found, I believe. Okay. But there's a convention that regulates marine pollution, MARPOL. Of course, if it was on high seas, even if they violated the convention, who is going to enforce? On high seas, I don't believe that the Brazilian Navy can do it. Something to discuss afterwards, if you like. Yeah. So marine protected areas, just another example. You see the CBD, the Convention on Biological Diversity, had a target of 10% to 2020, okay? And we are at this point, this is the protected planet net, we are at 7.5% of the maritime space is already with some status of protection for maritime protected areas. What you can see is that the disparity between sovereignty terrain, which increased by 70% in the past years, and high seas, less than 2. So it's very hard to regulate and to put into force measures on the high seas. This was the point for this one. Anyhow, because there's no ruling body, this is why I was asking about one ruling body, there are top-down political initiatives, politically driven initiatives, which can help the case for cooperation in science for the sake of marine protection and the development of the blue economy. So there's one big initiative that came started in 2013 by EU that started with the Galway Declaration, then it got a big project called AORA, Atlantic Ocean Research Alliance, and recently in 2017, another initiative called the Belém Declaration signed in Lisbon with Brazil and South Africa to cover the South Atlantic. And the idea was always to get a whole Atlantic perspective on one side economy, another side blue jobs and blue economy and development, and in the end of the day, also do that with sustainability and protection of the environmental values. In the case of AORA, which is finishing, they created several groups, thematic groups, to develop specific themes on the Galway Declaration. It's considered fundamental to have the oceans mapped. The oceans are still not mapped fully. Systematically, they are mapped for 15%. The problem of aquaculture, the need of aquaculture to stop wild catches or to reduce them strongly, the work group on ecosystem approach, and the work group of ocean literacy. These were considered the most important work groups. The Belém Declaration, Sophie is there, she probably will speak after about that, but the idea is again to create a linkage between all the players, all the actors on the different sectors to have common approaches. Meanwhile, with some overlap, but again with an important perspective of creating networks of knowledge and networks of infrastructures, Joaquin is here, is the CEO of AIR. Several initiatives, also top-down from the Ministry of Science in Portugal, related with Brazil, with South Africa, different countries. They started having these high-level meetings, putting together politicians, industry-related and scientific personnel, which try to define a common agenda for the Atlantic, a common research and development agenda. And at the end of the day, this led to the creation of Air Center. So Joaquin Hernandez here is the CEO. And Air Center takes one different step compared to AORA and the All Atlantic Initiative, brings the space to the equation. So it comprises Earth observation and satellite approaches to get regional data in the Atlantic, so space science and technology. Wait, sorry. I'm struggling with the pointer, but okay. Data science, because we have huge amount of data that we have to tackle and process, store, and ultimately turn into information, and also monitoring systems in ocean technology. The goal was also to use the Atlantic islands to make a network of natural labs, and at the same time, make use of the participating countries' infrastructure. BlueMed initiative was a different initiative that has been occurring for the past 4 years in Europe, also strongly pushed and fostered by DG RTD, and basically was an initiative led by Italy to try to convey a program for the Mediterranean, again to develop sectorial areas, to create jobs, but doing so in a way to protect and to even restore the marine environment in the Mediterranean. So Portugal has been involved, and now all the North African countries are also involved. It was possible to identify a lot of gaps, necessities from previous sponsored projects, and these were incorporated in RIS3, so the Smart Specialization Strategies of Regions, as to have a full coherence between the local, the regional, the national, and international scale. So the idea here was bring knowledge, management, operation, and awareness through the right stakeholders, so science community, enterprises, citizens, and public sector, to really glue them with the strategy, okay, and make the Mediterranean thrive. Private sector is normally put aside from these conversations, like this is a public problem, not a public and private problem. So any stakeholder acting on the ocean, and these companies normally are more on the ocean than most of the decision makers, they know about the problems, they get data, and they are part of the problem and part of the solution. So it was created a United Nations Global Compact, which comprises all major companies, shipping companies, mining companies, aquaculture companies, fishing companies, to really tackle and discuss how can they operate on the oceans in a more sustainable manner with less impacts and with more regulations. So they made a mapping of ocean rules and regulations. This is a public document. And they designed a sustainable ocean principles and due diligence for best practices in the ocean, okay? And at this point, these guidance, especially for the ocean, are being tackled one-on-one on different subjects, what should be done, what should not be done, what concerns operations, data, decommissioning, tracking of the processes, so on and so forth. Apart from that, it was created an Ocean Accelerator Network. It's 5 themes which are depicted there: set sail for zero on shipping, decarbonizing shipping, traceable seafood, ocean energy is mapping the ocean. So these tipping points are challenges for the community and for the young researchers and entrepreneurs to really find new businesses at the same time helping solve ocean problems. For instance, here on the right side, we had teams from, this was in Carcavelos in Lisbon. It was called Innovaton, about the oceans, Ocean Edition. And we had about 100 students from universities across the country. There was a team from the Algarve University which had second place on the contest. And this is, well, this is a bit violent. It's 24 hours of thinking on a problem and finding a solution. They don't sleep, they eat, and it's very tedious, but they were very committed. It was a very nice experience. So we are now in a good spot in terms of research, because we are going into the decade, UNESCO decade for science, for ocean science. And I feel that many problems, we tend to see the problem from the developed country or the North Hemisphere, but if you go south, there are little resources, little infrastructure, little data, little support system for the knowledge which is needed, okay? The goals for the decade of science are, cleaner ocean, a healthy ocean, a predictable ocean, a knowledge ocean, and so on and so forth. The question is, how in 10 years are we able to do so if we take it from the perspective of SIDS or, underdeveloped countries? It's a really hard task, really hard task. One of the things needed, of course, is data. And this is a map, the catalog of data, information, and knowledge from the EU. Is quite complex. For instance, those of you who know EMODNet is again, lost the pointer. I give up on the pointer. So on the right-hand side, on top of the graph, there are EMODNet cloud, okay? There are a huge amount of data systems, and this is just for Europe, okay? Put China, put Russia, put US, of course, and all of these data should be available. So the policy from Europe and the US should be spread around. Open data, easy access point in terms of regions and not on themes. Easy integration, interoperability. And I was talking about vessels because this is some subject which is dear to me. We are on the 21st century, and we still don't know what the vessels of developed countries are doing on the next. There's no single spot where we can know what this vessel is going to do, which data is going to collect. So articulation of the fleet, which is highly expensive, is very complicated, okay? And I always tell this story. Lucky Strike, which is a thermal field, was mapped 5 times. This is the things that we have to avoid in the future because money is not abundant. So that one of the work groups that I was talking to you about, the seabed mapping work group, which I was involved, developed this data portal which integrated EMODNet and NGDC, so US data, for the bathymetry of the North Atlantic. This kind of approach will have to happen on the other basins. And if you would do, this seems quite nice, but the amount of holes, of data holes on the world's oceans and on the seabed is huge. So the fact that we have guys doing exploration for mining, which is, of course, a complicated subject, but a necessary one to debate, more data will come into place. Industry, laying cables, more data is going to come around. And somebody has to try to optimize this. Another thing is long time series. This is a good piracy compared to the ones that Miguel was speaking about. So Pirata is a setup in equatorial and subtropical Atlantic, initiative led by Brazil, USA, South Africa, and France. It's been monitoring the subtropical gyre and the physical and chemical parameters on the ocean, and it's been there for 25 years. It's the long-lasting system for monitoring with a regional scope, okay? So it's a transect across the ocean. We don't have many examples like this, and we have to multiply them if you want to have real data about the ocean change paradigms, okay? Of course, the new perspective in the future will be easily deployable, expandable, low cost, and environmental friendly sensors to map and study the oceans. Another initiative which Japan has, US, Canada has, and Europe now has is ocean bottom observatories and water column, so EMSO. But again, we are talking about 5 or 6 points in the ocean. The ocean is very big. And of course, no single country, even if it's UK, US, Russia, or China, are able to tackle the problems it poses. So my final remarks for you is, I would consider UNCLOS freedom of high seas regime a driver for a complex, fragmented governance framework. And of course, it's not foreseeable that the convention will be changed in the upcoming years or decades. The high seas is there because they were fighting with the concept, so they were able to tackle everything on the seabed after 15 years of debate, but they could not get to a sound conclusion about the high seas. And so they just put it there like that in the convention. So what's going to be happening is that we need more international cooperation. So initiatives like AIR or like AOR or the Land Declaration or Anchor, which is the supporting mechanism, are fundamental. They exist in the Atlantic, they exist less in the South Atlantic, and they exist even less in the other oceans. And these oceans are critical. And these mechanisms are critical for concrete R&D and innovation agendas. And then the third point is we need articulation for scientific infrastructures. So we need to speak more with each other's, each countries, and I hope AIR, for instance, in the Atlantic will help doing so in ways that we can make value for money, get more data, and make more use of the data for the development of industries and for the protection of the oceans. So thank you very much for your attention.
I don't know if you have time to discuss some remarks, yes? Some questions?
10 minutes.
10 minutes? Okay. So, someone wants to make questions or to remarks? One. Thank you very much.
Thank you to both presenters. I believe the presentations were great for those that are not used to these kinds of themes. But I would like to ask if the top-down strategy would be the best when we have so many problems to deal at a local level, especially in the social-economic levels of our society, and if that actually works properly.
I would say I agree with you. So it always has to be a combination between top-down and bottom-up approaches. But if I was to do a graph like I showed, which was a graph from World Ocean Review, for instance, in Portugal, from the local authorities that have to tackle specific problems in the coastal areas, for instance, it would be something similar. And so, of course, when you have top-down, you have at least three things. You have commitment from the ruling powers. You have coherence, if everything goes well and if the right articulation is set up at the political level. And so you have steering. It's much harder to have steering if it's a bottom-up approach, okay? Which normally is led by us scientists, which want to do what we want to do. And some of the things are fantastic, some other things are fantastic as a scientific value, but not concrete application. So there's room for everything. But having top-down steering on these processes, if we were rich, that we are not, okay, it would not be so significant. But when you have limited resources, we really should narrow it to get concrete actions. This is my view.
Thank you for the question. I think we must have a bottom-up strategy that I call the geographic strategy, to try to answer to the challenge of the silos. From our experience, only when we sit everyone from the different expertise to look at the same place, and for that I have to congratulate Maria João Babiano for the fantastic work Sima did with the Formosa book, which is clear that what we need. If we sit down and look to a geographic position with all our different way of looking to things, including the socio-economic aspect, that will solve our silos issue. Because yes, there exists IMO, seabed authority, so on and so forth, but let's go together to the same spot. That can be a little spot like Rio Formosa, or it can be southern Portugal or the archipelagos or Europe. And when we put geography on it, everyone understands what we are talking about. This is one thing. Another thing, I think oceans are suffering for two things. One is the one we are discussing here. Another one is caused by the shift of power, of the change of power. There is, on the past 20 years, a change on how mankind produces. And that change means that we are producing, caring less of the environment and the social when we look to the global. And the only solution for this is the World Trade Organization that I don't see, never. I never see that. So, and for the past 10 years we are saying that it's fundamental that World Trading Organization comes to the table together with the scientists. Also, WTO is part of United Nations, so there is a call to call them to the table. If not, what will happen that this will be discussed as it is, but individually by very powerful people like the ones you see in the newspapers. So if you are taking this issue of the, and let me say the names, the dumping on the social and environment, and then, as we see, because of rain and everything flows to the ocean. So part of oceans issues, nothing has to do with ocean industries, are totally affected by the very fast change on how we produce. And what is happening is that in the same spot, we are producing much more. And this has nothing to do with development of countries, because all the countries have the right to be rich and to be healthy. This has to do with global management, and we are reaching to a point, as you saw in Delhi, the unbreathable place, which is a first sign. Thank you.
Thank you. Well, just completing what Nuno was saying, I'm Sofia Cordeiro and I'm the coordinator of the Anchor project. Implementing the blank statement. And as Nuno said, the steering from the political side is very important. It has been crucial in order we can achieve what we have been achieving both in Aurora and also in the South Atlantic Cooperation and all these All-Atlantic initiative. But in addition to the steering from the political level, which are on a daily basis almost reminded us that we really have to do things that impact our society. So really society challenges are in the heart of our governments at the moment, at least the ones that have signed the blind declaration. But in addition to this, as I was saying, we have working groups or stakeholder platforms where we have a bottom-up information on what is needed to be done. So it's very important that we have the steering at the political level, and then we have ideas from the communities that at the end will be the ones implementing and the operationalizing all these willingness to make change. Thanks.
Thank you. Other questions?
Joaquin Hernandez from Air Center. Just a small remark. I think in relation with what has been presented before about top-up or bottom-up, I think that also, of course, we need the political support because otherwise there's no way to move forward. But also at the same time, if we like to have the bottom-up support, I think that we have to do much more in the promotion side. And also we have to do to work on the promotion side much more closely to the scientific activity. Normally, we used to diffuse our results only on the scientific arena, and sometimes, for example, just today, we don't have here the cameras, we don't have here people doing Twittering. I mean, sometimes we have to combine together. And in this case, in Portugal, we have Ciencia Viva, that is a wonderful example that is doing that. And sometimes we have to do much more cooperation between us in this sense of get through all the news and in the news all the activities that we do.
If you have not other questions, perhaps you can podemos terminar. Okay. So. The break for the lunch. Thank you very much for the session.
Hello, good afternoon to everyone. I am Luís Menezes Pinheiro. I'm from the University of Aveiro. I'm a marine geophysicist and I'm also with the Portuguese Committee for the IOC. So we welcome you to this session. This is a wonderful session on the world ocean assessment, particularly on the thematic areas. And we will start with Maria João Bebiano. We will tell us about anthropogenic changes in the ocean and remediation measures. Queres começar?
Eu queria. Okay, so good afternoon. As Luís told us, we're going to start the session on the World Ocean Assessment after the excellent contribution that we got from our coordinator. But we designed this session with the contribution of some of and as you probably are aware, I'm also a member of the and I'm in charge with the anthropogenic changes, basically on on the first World Ocean Assessment, 55 chapters with almost 1,000 pages and contribution of around 650 experts covering all the areas of the ocean. And at that time, there was report was prioritized relating to the Sustainable Development Goals. We are a group of 1920, some of them changed. So these are the last picture where there were some changes already, the beginning with our colleague from United States that went to being chairman of NOAA, so she disappeared and was replaced by Jorn, which is the one here. So we are representing 5 members from each UN group. And on this World Ocean Assessment 2, we have outlined the scientific understanding of the ocean based on drivers of the changes in the ocean, pressures and trends, and also trying to take into account the current states and trends like physical biodiversity, human society in relation to the oceans, and lots of pre-planning. This time we're going to have 31 chapters for their appreciation, going to be finished by April 2020. It was mentioned already here that population is increasing. So you're probably going to be 11 billion in 2100. And also by cities, which will have more and more people living near the oceans. And 40% of the world is already affected, or world ocean, by anthropogenic pressures. The other thing is that life expectancy is also increasing. So here you can see the life expectancy in the different parts of the world. Some of them are higher, some of them are lower. And also the projections, there's the life expectancy is going to increase. Alna did mention that already. There's some new numbers which are also frightening. That the increase of China on world chemical production will carry on, and the projections for 2030 are the ones like that. So if you can see, and within these, there's no inclusion of pharmaceutical compounds. So this is another problem that we need to adapt to this one. And also, unfortunately, there's already data that indicates there are some deaths related to chemicals. And there's a lot of illnesses already reported to be linked by, say, cancer, chronic and primary diseases, cardiovascular. There might be related to these environmental problems. So today, they're already mentioned, we have huge ship movements, and well, this is an instant picture of the ship movements here. And if you relate world traffic with ocean-based pollution, there's a direct link. So this is an important picture to see how heavily contaminated we are in this area, and especially either from land-based sources or from the shipping problems, and also in other areas of the world. So this there is a relation already. So these anthropogenic things, the old contaminants, in the old contaminants we have the metals, and here this data shows you the metal deposition from atmospheric sources. In metals like lead, cadmium and mercury, they are of great concern, also because of the effects they have in the ocean, but because of the effects they have on humans. And you can have here a picture of the atmospheric deposition to the ocean. And also mercury, which was dealt with very well for 40 years, which has decreased a lot, became again a problem. And there's the different sources of mercury, like power generation, industrial sources, or product waste. All these things are contribution to the global deposition of mercury, and mercury levels in the ocean are increasing again. But not only mercury or metals that are coming from atmosphere, we also have the benzoylpyrene or oil problems related to that. And also here you have the impact of the atmosphere on all these into the ocean. So which is something has not been very well linked to the levels in seawater. But if you sum up everything, we end up with levels of biota, which are medium to high. The red are high, related to cadmium, mercury, lead, organic contaminants, and PCBs, and all sorts of things. So the situation, although it has improved a lot in the last 14 years in Europe, you still have a lot of concerns here. And if you go to other regions in the world, the situation is a lot worse, or there's not even data in some parts. So these contaminants here, well, the metals, the organic compounds, these are called old traditional contaminants. Today you also have heard about invasive species, so this is related to movement of shipping. And here in this area we are still having a lot more of these invasive species. And although we have the Brazilian problem today with the spill, which we don't know yet where it came from, the situation has a lot of improvement in this area because the ships are starting to have a double hull, there are less accidents, but the production of the oil is increasing, which is in the blue side, and the green side is showing that the accidents are diminishing. Now we're having this problem in Brazil. We are waiting to see what's happening. Probably these will increase again, but the information is one of the things that we can say that's improved, but you can also take attention that oil spills are only 1% of the contamination in the sea. There's a lot of media attention, but it's only 1%. And now comes the fashion, plastics. So everybody is talking about marine debris and lots of plastic particles floating in the ocean, with probably 8 million tons a year getting there. And these are a picture of a satellite image that you can find in World Ocean Assessment, where the World Economic Forum just reported that if nothing is taking place in 2050, there's going to be more plastic than fish. There's a lot of initiatives. There's also Paolo, which is in the audience, which is related to chapter 12, which is the chapter which is deal now with marine debris. And also, we can find all of these marine debris in different areas of the bottom of the Atlantic Ocean. Huge particles and all sorts of these marine debris. So this is a concern. And also, a lot of reports that reported that the plastic bag has been found in Mariana Trench, which is 10 kilometers. And also in the seafloor, they travel between the surface and the seafloor. They can take 170 days. So, and we can find plastic that came from 1,000 or more kilometers from the coast because they are transported in the currents. But one of these new things is personal care products and pharmaceutical compounds. We have 3,000 pharmaceutical and personal care products currently used in the market, and there's new entering in the market every day. And with this life expectancy, we're going to use a lot more of these pharmaceutical compounds. And that's why we are having all sorts of these compounds in the ocean. Some of them are highly more toxic than when we took them. Some metabolites are even more toxic, and when we go to the cancer drugs, they keep their properties in the ocean. So that means that these are more or less a picture what we can find in the water. Now we can find even more, because if the analytical methods improve, we can detect a lot more, and levels are very low, but they keep having the same situation as when we took them. And in the Algarve, I didn't show, but I didn't give the numbers, but here in the Algarve, we can exactly know what the doctors are prescribing. So, and for instance, you normally tell you this, in Portimão we have the Prozac, and in Vila Real de Santo António and Guadiana we're having painkillers because the population is a lot older. So, and so we can have this situation also all over the world. The levels here in the south of Portugal are the same as the level in the estuary of the Thames in Paris. So it's a little worry having that all over the world. Some of the areas we don't have information, but in the new World Ocean Assessment, we're going to have a lot of information also from China Seas and all the other parts of the world. So remedies, the first thing is we have to decrease land-based pollution a lot. It represents 80% of the pollution that we are introducing into the ocean. These you also have to improve, and that's from the land side. We have to improve a lot wastewater treatment facilities. We have to implement green shipping initiatives. So far, shipping has not been dealt with very much with pollution. Now we know there's a big impact. And we have to strengthen and modernize the strategies to assess the levels. There's a lot of areas of the world that there's no information yet. And here is a picture made by an artist here from plastic that was collected in one of the beaches in Portugal. So it's quite nice, so I would like to show you this. So again, the World Ocean Assessment is, well, being the initiative and strengthening the progress from the ocean decade. Here you have, I'm pretty sure they're going to have a lot more information on that one. So the regular process is helping to guide and plan the UN decade for 2020-2030. And we are trying to this summary of the World Ocean Assessment to be approached with include the progress in research and technology relating to the 6 societal outcomes outlined in the UN decade, which are already here this morning: clean ocean, health and resilient ocean, a predictive ocean, a safe ocean, and a sustainably governed and predictive ocean, and then transparent and accessible ocean. So our summary, we're probably going to go along those lines. And so by April 2030 or even after, you can probably have access to the information already aligned to the ocean decade. We have to take measures, because otherwise we end up with the oceans being there, but we probably not. So these, we cannot continue without the oceans, so we need to take actions, we heard this morning, rather quickly. It was also mentioned that Lisbon is going to host in June this year the World Ocean Conference of the United Nations in co-production between Portugal and Kenya. And so we probably going to have also a session about the World Ocean Assessment during the conference. It's probably being planned. And so it's for you to become aware of. And if you have additional information, Alan will also mention that one. So the website with all this information is, you can download it, all the information of the World Ocean Assessment is there. Thank you very much.
Thank you, Maria João, for a wonderful overview of the objectives and what we are doing with World Ocean Assessment and its contribution to the decade. And we continue now with noise in the ocean with Sergio. This is another topic which is fundamental because although we do not hear it, it has an implication on marine life, and so it's crucial that we deal with it.
Exibição da página é aqui.
Isto está em PowerPoint? Costuma ser aqui?
Não, é o Ctrl S, não é? Ctrl S. Eu ponho em inglês, mas... Okay, good afternoon. Thank you, Luis, for the invitation for this conference and the introduction. I'm going to talk about ocean noise. Whether this is a new global stressor, it's probably not new. We view it as new, but it has been there for quite a long time. Okay, we already mentioned the first global integrated marine assessment. What is new, in fact, is that in this second World Ocean Assessment, there is a chapter about ocean noise. This is chapter 21, trends on inputs of anthropogenic noise to the marine environment. The group that was formed to draft this chapter is composed by Anna Sirovic, that is leading the group, John Hildebrand, myself, and John Miller, which in fact they are co-authors of this presentation, and the draft was submitted last August, is under review together with all the others. Why is ocean noise so important? There are, of course, many reasons, but maybe the two main reasons are that one of them is that sound is much less attenuated in water than in the air, so it can reach very large ranges up to hundreds or thousands of kilometers in the ocean. I need a microphone here to reach the end of the room. If this room was filled with water with the same energy, I would not need a microphone or an amplifier to do this. So the sound propagates much better in the water than in the air. Up here there is a picture of an experiment that was carried out in 1991, about 30 years ago, where sound was transmitted from a source located in the southern Indian Ocean, and it was propagated all over the ocean to the east and west coast of the United States over thousands and thousands of kilometers. And actually, it was received at the same position after going around the Earth on a path of about 40,000 kilometers. So this propagates really far away. Well, the second main reason is that animals in the ocean rely up to an estimate of 85% on information that is gathered through sound, while for terrestrial animals, it can oscillate between 20 and 30%, because, well, the main reason is because we have vision, and underwater sight is very limited. So these, I think, are the two main reasons for noise to be so important in the ocean. This is a picture that was already shown, well, a similar picture. This is something that you can really access in this website called Marine Traffic. That's not the only one. There are many sites that show this type of information, but here you see ship density all over the world at a certain moment in time. You can see very easily, this works. Yeah, well, the red is the highest levels, and you can see that these are concentrated mostly on the northern hemisphere, in Europe, around Europe,
North America, and then Asia, China and Japan mostly. So this is where, of course, noise is concentrated. Now, what makes noise? Of course, propellers, and cavitation and turbulence, machinery noise that we can understand, and then flow noise as ships advance through the water, which is depending on a number of parameters like dimension, tonnage, draft, etc. And how much noise do they make? Well, shipping noise is the main contributor for frequencies. Well, it's not above, it's below 200 hertz. Well, to give you an idea, one modern container ship at 12 knots, which is a typical speed, can produce up to 195 dB of noise, but is measured in micropascal at 1 meter. Now, to give you an idea, the jet plane produces between 120 and 140 dB, and hearing damage may occur above 85 dB. So it's really loud. Okay, this is another picture. This is a picture that was produced by George Frisk in 2012, and it associates shipping noise with the world GDP and the ambient noise and the gross tonnage of ships. Now, you can see that there are three parallel lines that are increasing. The time span is between 1950 and 210, so it's a span of 60 years. And you can easily see the correlation between these two variables. So there is a real impact or connection between globalization and economics, and then shipping, and of course ambient noise that is associated with it. Now, another source of noise is, of course, seismic exploration for oil and gas. The principle is there: a ship, a sound source that emits a sound that penetrates into the bottom and then is reflected and received on hydrophones. Now, the operation is something like this, where you have here the ship that is towing the sound sources, and then there are hydrophones that are towed behind, lengths up to 10 kilometers in some cases. And then, of course, we have to penetrate the solid earth, so the signals have to be really powerful in terms of sound. We are talking about what are called arrays of air guns that may produce up to 260 dB. We can compare with the previous number we had before, in a band between 10 and 50 hertz. And this band is the one that is used by large whales in this low frequency band. So they interfere one with the other. And these seismic surveys, they may last for weeks, sometimes for months, depending on the areas that are to be covered. Of course, these very powerful sources, they may have consequences like heavy hearing damage, and they can be heard thousands of kilometers away with this enormous amount of energy. Another topic is industrial activity noise. This is mostly occurs around our coasts. Here we see, is this one? Oil, gas platform. These are the distribution in the Gulf of Mexico, so you can see that it is really dense. They produce noise during operation. Here we see the offshore wind farms. This is in the North Sea or in the Baltic. Noise is produced during the construction, but also during the operation later on. And here we have other sources like wave energy, generators, and so on. These are being installed by many countries around the world, and this produces noise as well, of course. Now, other sources of noise, sonar noise, can be civilian or military. Here, in the civilian part, we have side-scan multi-beam sonar that are normally used for eco-sounding, either for the topography of the bottom or to know the material in the bottom or to detect fish, but this is generally higher frequency, so it doesn't propagate so far, and in these cases is directed to the bottom, so they are not so harmful, or the arm is limited in space. Now, for low-frequency sonar, we are talking about the military applications here. They produce noise. The noise is really loud, as well as low frequency, and it's generally done on offshore and propagated towards shore to shallow water, so the energy concentrates, and this can be also very harmful for marine animals, and accidents have happened in the past. Now, why does it matter? Well, it matters because now we are becoming aware of the importance and impact of this noise on marine life, marine mammals first, because they are very similar to us, but there are over 100 fish species that are soniferous, so they are sensitive to noise, invertebrates, larvae, etc. Increasing noise levels make species change their behavior. I'm talking about migration paths and so on, and also to reduce biodiversity, because by emitting noise and injecting noise, we are selecting species to those that are noise adaptive or resistant species. Also have economic and social impact. One of them, of course, is to replenish marine life in noise-stressed areas, so the catch is reduced, and maybe also less tourism opportunities. This is also true here in the Algarve. Things are moving on the policy side. Of course, in 2008, the EU was a pioneer with MSFD, that was already mentioned this morning. The descriptor 11 is one on the list that specifically addresses ocean noise. So ocean noise is now part of the GES, the good environmental status that we are supposed to monitor starting next year. We are getting there. In 2018, anthropogenic noise was the topic of the informal consultative process on oceans and the law of the sea that was promoted by the United Nations. And sound was also identified as an essential ocean variable by GOOS on the biology and ecology panel. In summary, the remaining key gaps in this area for ocean noise: first of all, a knowledge gap. We are lacking fundamental knowledge, since we don't know what was the ambient noise before the industrial era, for obvious reasons. We have been studying the impact on species, but we don't know the impact on populations. We are lacking that. And we also lack standardization in terms of measurements and values and thresholds, and this requires the agreement between countries, etc. We also have a capacity building gap, since most of the monitoring is concentrated in Europe and North America for obvious reasons. So we need cooperation for other areas of the planet in terms of observation, but also to establish broad policies, since, as was said this morning, ocean noise, well, together with the other variables, has no borders and no frontiers. It goes everywhere. There is hope. So the outlook is that regarding shipping, the International Whale Committee and IMO have agreed to reduce noise and about 13 dB in the next 30 years. I don't know whether this is going to happen. Well, the points where improvement can happen is on propeller blade optimization and engine isolation, but all that costs money, so I don't know. Others that are a bit easier to do is to reduce ship speed and to divert from marine sensitive areas. On the seismic side, there are suggestions of using vibrators instead of air guns. A vibrator is a device that we pose on the bottom that produces vibration, and that's probably less harmful than air guns. But that, of course, requires consensus and agreed thresholds among partners. The last slide is to mention to you, it's a bit advertisement. We are part of a project called JONAS. that is a joint framework for ocean noise in the Atlantic seas. Of course, is to address the threats to biodiversity and the noise pollution. And the partners are listed underneath, and we are part of this effort that started this year, will last for the next 3 years. Thank you very much.
Thank you for an excellent talk. And next we will have the impact of nutrients in the ocean, and Alice Newton is going to tell us about it.
Deve ser o seu correto. Ok, já está. Okay, well, thank you very much for the invitation to talk about the impact of nutrients as a marine stressor. And when Maria João invited me, I was a little alarmed because this is something I talk about for a module of about 10 hours normally. And it's also something I've devoted 30 years of my research to. So I'm hoping that I'll be able to give you a quick overview in 20 minutes. So what am I going to talk about? When I was reflecting on what I would like to talk about, I decided that instead of packing my presentation with information, which you'll find in Chapter 10 of the upcoming World Ocean Assessment, I would present something that would make you think a little bit and makes me think a little bit about what we know and what we've learnt about nutrients. And what we know and what we've learnt are different things. We know a lot about nutrients in the ocean, but we've learnt very little about how to manage the problem. And this is what we really need to address. So what are marine nutrients? Most of us know the definitions. They're nutrients, they're chemicals necessary for growth. And growth in the ocean is usually limited by the most deficient nutrient, or light. So the main nutrients in the ocean are nitrogen for amino acids and proteins, phosphorus for energy metabolism, also iron, which is very important for the biochemical catalysis of phytoplankton, and for certain species, but fundamental species of diatoms of phytoplankton, also silicon. So what we've seen in the past 60, 70 years is a growing pressure by anthropogenic loads of some of these nutrients. And that's what we're going to explore today. So first of all, let's go back to the idea of nutrient stress. This talk is about stress. Nutrient stress in most of the ocean is not enough nutrient. Most of the ocean is nutrient poor. Then there are some privileged areas of the ocean that are nutrient rich. For instance, off the coast of Portugal, we have upwelling, and so we have naturally nutrient-rich waters. And then there's the enriched areas. They're enriched, but not in a good way. They're enriched because we, as human beings, have added a great number of nutrients, great loads of nutrients, or we've retained some of the essential nutrients. So instead of having these beautiful, clear waters, which are typical of nutrient-poor areas, then we get these areas where we have enormous blooms of algae, and this is Qingdao in China, a wonderful place to study nutrient enrichment. So waters, natural waters, are different from their point of view of natural richness. So here we have, I brought my own pointer because I was scared of the other one. So here we have the Mediterranean, and nice clear waters because it's actually a nutrient-poor area. And then here we have this upwelling off the coast of Portugal, and we're very happy because they're nutrient-rich waters. And then you have areas here, like in the north of the Adriatic, where you have nutrient-rich, but not in a good way. And it's because there's an imbalance in the nutrients, because these nutrients have come from the Po, from the big river that goes into the northern Adriatic. So what causes this nutrient stress? Well, as I said, first of all, not enough of one nutrient. That's a big stress for a lot of organisms. But more and more now we're finding that the problem is too much of one of the nutrients. It's an imbalance in the biogeochemical cycles, and it's an imbalance between the ratios of nitrogen and phosphorus and the ratio of nitrogen and silicon. And because of that, we think that we can also geoengineer. We can correct the problem by adding more of something, for instance, adding iron in some of the areas that are nutrient poor. So who causes and what causes these imbalances of nutrients? All of us. We're all guilty. It doesn't matter who we are, whatever our feeding habits are, whatever our traveling habits are, we are all guilty in some way. It's because of sewage, it's because of our use of detergents, it's because of our reliance on cheap food sources, it's because of our use of fossil fuels. But apart from that, there are specific economic sectors that are particularly active in this imbalance of nutrients. And they include things like agriculture, because of the use of fertilizers, and animal rearing, transport, because of burning fossil fuels, industries, particular industries. So just to summarize so far where we've got to, and this is where I'm proud to be European. We've got the Marine Strategy Framework Directive, and we're working on these issues. So this is the definition from the topic group 5, which included several Portuguese. Nutrient enrichment is due to compounds of nitrogen and phosphorus, and it leads to increased growth, primary production and biomass of algae, changes in the balance of organisms, and water quality degradation. So it clearly states that it's about enrichment by our actions as human beings, and that there are negative consequences to this. So what are these negative consequences? Well, we can summarize them in 3 ways. Poor state of the environment, for instance, poor oxygen condition, smell of the water, discoloration of the water, hypoxia and anoxia, so the fish die because there's not enough dissolved oxygen in the water, but also a poor state of the aquatic ecology and loss of biodiversity. And these 2 are really fundamental. So we can have harmful algal blooms. They're not all toxic, but they can be harmful without being toxic. We get macrophyte blooms. We got an enormous macrophyte bloom that I showed you in Qingdao, the photograph of in Qingdao in China, is completely dwarfed by the blooms we're seeing now. Loss of benthos, especially benthos that cannot move away. Loss of fish when the fish are trapped by anoxic water. Loss of seabirds, loss of sea mammals. But also, and very worrying, is the loss of whole ecosystems, such as seagrass beds, salt marshes, kelp, and coral. So the consequences are undesirable, especially because they degrade the ecosystem health and they degrade the sustainable provision of goods and services. This is also from the Task Group 5. And it's so important because it explains why this matters. It's not because polychaetes are dying. People, the general public, is not interested in polychaetes. It's why it's important to all of us. It's because the provision of goods and services, the ecosystem services of the ocean, are being damaged. So, who's impacted? Again, all of us, even if we live a long way away from the sea. It impacts drinking water, not the one in the sea, but nutrient enrichment in general. We had a problem here in Faro, if you remember, some years ago. It impacts bathing, so coastal tourism. It impacts also seafood consumers, and the Portuguese like their seafood. But it also impacts specific stakeholders, such as fishers, aquaculture producers, and the tourist industry. So they're groups of people as well as all of us as individuals, the general public. So what can we do about this problem? Well, we do monitor nutrient enrichment, and we've got different levels, different degrees of monitoring, intensities of monitoring. First of all, we just do the general surveillance monitoring, but then if we see that there's a problem, we go into a more intense monitoring. And then if we see that we still have a problem, we try to identify exactly what is the problem. We also have different types of monitoring. There's some monitoring where we have to go and get the water and analyze it, but also nowadays, more and more, we can use proxies and we can do some remote monitoring using satellites, using ferry boxes, all sorts of new technologies that we can use. So how do we assess nutrient enrichment? Again, we have loads and loads of ways of assessing nutrient enrichment. So some really good work's been done by OSPAR, and Portugal belongs to OSPAR. And also in the Water Framework Directive, there was a big activity on how to control nutrients. And also it's carried on in the Marine Strategy Framework Directive. So we've got some really good policy instruments that can help us tackle this problem. So how do we solve it? We seem to have the scientific knowledge. There are thousands and thousands of papers published every year about nutrient enrichment. We know a lot about it as scientists. We know how much, we know where it's coming from, we know where it's going to, we know what happens when we have these nutrient loads. And we have the policy instruments. So we know what to do, so why don't we do it? Why are we still having this problem? We seem to have some barriers, and what we need to do is to build some bridges to overcome these barriers so that the knowledge is actually taken on board and implemented in the policies, and that the policies are not just empty documents. So how can we reduce nutrient loads effectively? I've just read this year one of the most interesting papers I've read for a long time on eutrophication. It's published by an American who has worked for many years on Chesapeake Bay and who really knows a lot about eutrophication and nutrient loads. And he tells us that nutrient balance is more than just the nitrogen-phosphorus ratio. We need to consider more than one nutrient. There's always these arguments about, oh, nitrogen's limiting here, phosphorus is limiting there. We need to think beyond that. We also need to understand that controlling one of the nutrients can actually promote algal blooms. We need multiple nutrient control. We need to control N and P and SI together. It's holistic. It's not just one individual nutrient. We also need to consider things like atmospheric deposition. Atmospheric deposition is a big source of nutrients, especially further away in the ocean, not in coastal areas. We need to change the way we use financial instruments so that we go towards polluter pays rather than pay the polluter, for instance, by subsidizing agriculture. We also need to consider time lags and legacy, and this is a big problem. Sometimes you start working on a restoration of an area, of a regional sea. The Baltic is a very good example of this. But even if you control the flow of phosphorus to the Baltic, it's going to take decades before the Baltic recovers. And the length of political cycles is not always compatible with that sort of length of application of a policy. Last of all, we can use nature-based solutions. We can really understand that riparian vegetation and wetlands have a big role to play in retaining nutrients before they can reach the sea. So, no spoilers about chapter 10. You have to read it coming soon. I've been told now April 2020. If you want to read more about nutrients, then I can recommend these two papers. They're probably the best papers, I think, it's my personal opinion, of course, in the last 20 years on this problem. So there's a paper from 2001 by Jim Clowen, excellent paper, really our whole conceptual understanding changed completely with this. And then also this more recent paper, which is marvelous, where it explains what the barriers are, why we're not solving the problem, although we have the scientific knowledge, and what are the bridges, how we can overcome this. Thank you very much.
Thank you very much, Alice. And now we will have Pedro. He's going to talk about deep sea research and sustainable goals. We do look forward to reading chapter 10.
Yes.
Actually, it has implications for Portugal, as we are starting to have lots of problems, even with Ciguatera and other components of eutrophication that are starting to affect us.
Okay. Well, good afternoon. Thank you very much, particularly to Professor Maria João Babiano for her kind invitation to be here today. Presenting something, well, that I was challenged to talk about the deep sea research and sustainable goals. And of course, I will do it within the scope of the World Ocean Assessment 2, which this is one of the relevant sites of the UN site where you can find relevant information about this process. And in fact, it is a fantastic process because, as Alan said in the morning, it looks for making a regular assessment of the state of the environment in the ocean to provide and to be part of the feed for policy and to help policymakers. And this is quite relevant. And here you also can have some information on the outline of the second World Ocean Assessment. Unfortunately, I had the pleasure to be involved in Chapter 19, and particularly due to the joint efforts of Maria João Babiano and also our national focal point, the Foundation for the Science and for Technology. And well, we started the first meetings, I think, back in 2018, I guess, and then I went with my colleagues Luís Pinheiro and Ana Colasso to Qatar, the Qatar workshop, where we listened for the first time Alan
talk about this process, and it was quite useful because then we started to work and to understand what would be the main objective with this process. And so we became members of the writing team, and I think we really work in a proactive way, in a very fruitful way, and it was quite interesting to me to be part of the process. And here, well, to talk about something about deep sea research and sustainable goals, of course I cannot say much about this chapter because it's under review like others, but I will talk about the mining beyond national jurisdiction. And of course, if you want to talk about mining beyond national jurisdiction, we must introduce the International Seabed Authority, because the jurisdiction over the seabed and subsoil of the areas beyond jurisdiction, national jurisdiction, is granted to the International Seabed Authority by the United Nations Conventions on the Law of the Sea. And well, it is important because for now, there is like 30 contracts for exploration for marine minerals. And here are the areas. We have basically 3 types of marine minerals that are taking the attention of the industry. They are the polymetallic nodules, where you can see in the abyssal plains at depths greater than 4,000 meters, and lying at the abyssal plain, and it's like potatoes of iron and manganese oxides and hydroxides that lie in the ocean. Here you have one of these big areas, the Clarion-Clipperton Zone in the Pacific Ocean. Also you have some in the Indian Ocean. And you have, well, all these colored areas are areas for exploration, and you have a lot of yellow areas that are, in fact, reserved areas for developing countries. Because the ISA recognized that the capacity and the technical capacity of developing countries is quite different from the one of developed countries. And so these reserved areas are some areas that are reserved only for these developing countries, because there is already some information and the potential on the marine resources in these areas, in those areas, and they can take advantage from it. And then you have here also these areas along the mid-ocean ridges. You can have here in the North Atlantic. You also have here in the Indian Ocean. And these are basically areas to look for polymetallic sulfides, which are these deposits made of sulfides that are produced by the outcome of fluids rich in sulfur and metals like copper, zinc, with high contents of gold and silver along the mid-ocean ridges from the hydrothermal vents. And then, well, and just because I think it was Nuno that before lunch said that these are mining licenses. These are in fact licenses for exploration for minerals. So exploration in Portuguese will be prospeção, while our exploration in English it will be exploitation. So these are licenses for exploration, to search for these mineral deposits. And of course there are big areas in the beginning of the contracts, and then over the time period of the contract, the contractors must relinquish some of the areas, and it end up with areas much smaller. And here also you have these seamounts in the South Atlantic or in the Northwest Pacific, where some contractors are also looking to iron and manganese crusts, which are crusts that are deposited over the substrate, the rock substrate, and are enriched in manganese and with high contents of rare earth elements and tellurium and many other metals. So these are the areas that there are some activities occurring, exploration activities, and for now, these are the list of contractors that are working with the International Seabed Authority. Here, these ones in the beginning were viewed as the pioneer investors because they did a lot of work and invest a lot of money before the convention entered into force in 1994. And here you have some of the developing countries that applied for reserved areas. So those areas that are reserved for these specific countries where there is already some limited information that help them to pursue the work. And you can see here these countries like Nauru or Tonga or Kiribati, so small islands of the Pacific that are trying to build capacity over these minerals, and also getting a lot of capacity on ocean research, deep ocean research. For now, what we have in the International Seabed Authority are regulations that give some that provides the instrument for the contractors to operate, doing prospecting, where there is no time limit, and exploration under a contract that has a duration of 15 years. And now we are trying to pursue and to finish as soon as possible the draft regulations on the exploitation of marine minerals. So here in the exploration, what you have is the contractor must describe and must get data to have and to develop a good baseline, and of course to do a characterization of the mineral resources they are looking for, test of some mining components eventually, and eventually looking to some processing technology. In the draft regulations, we are looking for the need to have feasibility and feasibility studies, to have an environmental impact statement, environmental impact management plan, and monitoring and mining and equipment construction, of course. So this is still under discussion. It will be a contract that will be given for 25, 30 years, 40 years. We don't know yet. What is important is that, well, this is a change of paradigm because for now, mining is operating mainly, is land-based and is under the jurisdiction of one country, for instance, China or Republic Democratic of Congo for cobalt. And now we are trying to have here is mining operations that are monitored by the international community, because this will be approved by the International Seabed Authority Assembly, which is composed by 168 member states, including the European Union. So this is really a change in paradigm to have mining activities that are monitoring by the international communities, quite amazing. So looking to the deep sea research, because we need a lot of deep sea research to take these, to take these activities on board and to develop these regulations. And of course, you need to have some technology because you need to access the deep sea. And for instance, this is a conceptual model to exploit the polymetallic nodules. This was developed under the project Blue Mining, which was looking more on the technology side of these kind of projects. And of course, you will have this difficulty to have different jurisdiction, as Nuno pointed out in the morning, because here you have a production vessel which is remaining in high seas and is in fact operating in the seabed beyond national jurisdiction, which is known by the area under the convention. So it will be difficult to cover all the jurisdiction and all the legal issues that may arise from these activities, and also to look for the environmental impacts. The environmental impacts of this activity are particularly two that are here expressed. You will remove the substrate, part of the substrate that you can see here in this image, for instance, and of course you will create, most probably, a benthic plume, which is difficult eventually to monitor. So we need to do much more research, to do much more work on these issues, and we need to know about this benthic plume and eventually the creation also of a surface plume from the production vessel, how big and how far these plumes will develop, and to try to understand better what is the dynamics behind. Also, this is, relatively easy in a way, because this is a deposit, the polymetallic nodules, or even the crust, although there is a thickness involved. Basically, these are 2D deposits. For some of them, like polymetallic sulfides, you need to think in a three-dimensional perspective. So you can from 2D into 3D, because you have this kind of deposits that are formed from the emanation of these fluids that are coming from the subsurface. And eventually, most of the interesting deposit, because it's not oxidized, will be here under the surface. And well, this is also different because probably most of contractors will look to search and to look for inactive deposits because you don't have any, or you will have less problems in terms of the ecosystem, fauna and biodiversity, and also you will protect your equipment because these fluids are really acidic and hot, and it will be also difficult to operate, to make and to put machines operating under the influence of these fluids. And also it can be also, well, relatively more easily because the plume that you will create, you need to understand that in some cases you have a natural plume venting from these kind of structures, and eventually it will be, some of the problems will be more easily solved. And also, you must take into account that technology is being developed. So there are many ideas and many different ways to look at these activities. And for instance, this is a system that was developed by a German company. And here you can see how they envisage the exploitation of these deposits in depth, so in tridimensional structure. And eventually this can cause much less disturbance than other type of vehicles. So we need to provide information, we need to gather data because we need to inform these contractors and the industry to develop a technology that could be as much as environmental friendly as possible. And of course, also the ISA is issuing a lot of information. And for instance, these are the list of recommendations for the guidance of contractors for the assessment of possible environmental impacts arising from exploration only, not exploitation. And of course, much of this information that we have here in this document, which is quite recent, it was issued in the summer, or, well, it was made in April, but issued in the summer, also rely on the data and information that was gathered by recent projects, namely the Midas project, this one that was funded by GPI Oceans, also this one that was funded by European Union, and also developed with the South Pacific countries. So there are a lot of information that is being gathered looking to this specific issue of the environmental impacts that are linked with these marine minerals. So in terms of sustainable goals, well, very quickly, I would say that the mining, and particularly the mining beyond jurisdiction, which will, again, it will be monitored by the international community, can have some importance in some of the sustainable development goals of the UN. And for instance, I will say, and I personally think that we can have some importance in objective number 1, 7, 8, 9, 10, and 14, and I will address only 2 or 3 as examples of the possible contributions that can arise from this new industry. Well, the first is no poverty. And in order to have no poverty and to try to avoid inequality, in the context where the world population is growing, I put this sentence here that is very known: if it can't be grown, it has to be mined. So if we need to have safe access to drinkable water, if we want to develop sanitation for everyone, we need to have metals. Metals are needed to provide this basic infrastructure. Also, we must also take into account that there are more than 800 million people in extreme poverty. So even, for instance, for these people, the concept of circular economy does not work, because in fact they don't have the basic infrastructure to feed the circular economy. So we really need to have metals, and mining will continue to support development of these areas. Also, the access of affordable and clean energy. Again, well, if it can be grown, it has to be mined. And if we want to have this electrification and the change of paradigm in terms of energy, if we want to have electric cars, and this car is fueled by mining, by metals, when you don't have the fossil fuels, you must change this by metals in batteries. And also, if you want the access of this renewable and clean energy, you also need metals. And in a way, this is a kind of bottom-up approach, because we have students out there in doing environmental strikes, and in part because they want this. So they are talking to us, to the policymakers, to everyone, saying, we want this, we want this change of paradigm. And we must be aware that while the wind, for instance, is a clean energy, wind turbines are not so environmentally friendly, because in order to have a wind turbine, for instance, for 2 megawatts production, you need to have 300 tons of steel, you need to have 5 tons of copper, you have to have 3 tons of aluminium, a lot of concrete, so you have to have quarries, you have to have a lot of rare earth elements, which are not so easy to exploit. And finally, life below water, and this is mainly related with the conservation measures and the protection of marine areas. And well, I'm very glad to show here, this is again the map of exploration license in the Clarion-Clipperton zone in the Pacific. And you can see here these squares are what they are called the APEIs, areas of particular environmental interest. These are areas of protection. By no means any mining activity or any minerals exploration or exploitation activity will occur there. And so, in a way, this is already protecting, the ISA is responsible since 2011 or so, that this was adopted, by the protection of almost 25 to 30% of the area in the Clarion-Clipperton zone. So I think that we are, in fact, in the good direction to provide some feed for these sustainable goals. And I will end up by showing that, well, you see these are the large areas for exploration for polymetallic nodules. But, well, depending on the abundance, but on average, this area here can support about 50 years of mining. And we must look at it to the scale of the ocean. And we need to make choices. What do we want? If you want this change in paradigm in terms of access of what is called the clean energy, we need metals. We need metals to support this. We want to do this by business as usual, so based on land-based mining, or we can think on these kind of approaches that we need to know much better the impacts, and we need to develop a lot of deep sea research in order to be able to do it, or we can think on this scale in terms of the ocean basin to provide the metals that we'll need. Well, and of course, this will be the part of the support of the decade for ocean science and sustainable development, and we are looking for it, and we hope that this can be a great success for ocean science and to provide some of these important steps towards what is called sustainable development. And thank you very much.
I'm sure we will have many questions from the audience, as the other topics as well. And now we will finish our session with Ana Colasso. She's going to tell us about sustainable biological exploration.
Well, this is opening. Thank you for the invitation to be here. Thank you, Maria João, to Professor Maria João Biano to be here. And I have this task of talking about sustainable biological exploration, the process. Everybody talked about the first world ocean assessment. And the first world ocean assessment was based on this framework, this peer framework, which were looking for what are the driving forces that are causing pressures and changing the state of the oceans, and what will be the impact of these pressures, and what will be the responses of the environment of the ocean. And after this first world ocean assessment that was supposed to be driven in 2010, but it was released in 2016, the second world ocean assessment is going to look to what was done on the first global integration marine assessment and describe the environmental changes between the 2010 and 2020. So we had to see a little bit in the future too, and try to understand if those changes will have economical and social consequences, including benefits and these benefits related to the concept of natural capital. And towards the end, we should also address the main information gaps in relation to the subject that we were dealing with, and what will be also what are or will be the main capacity building gaps in the field. And if appropriated, we should do this by basin, like Arctic, Atlantic, Indian Ocean, South, North, etc. And if also appropriated, like Pedro has done brilliantly, how they were contributing to the achievement of the relevant Sustainable Development Goals. Due to my background, I was mainly related to the trends in the state of marine biodiversity on the different habitats. And they were divided. This chapter 7 is huge. It has lots of subchapters. Each subchapter is a marine habitat. We have the coastal ones and the deep sea and open ocean related ones. And I went to Qatar workshop with Pedro and Luis, and I was part of the writing team of the hydrothermal vents and cold seep habitats. And I came out of the workshop being a convener of the ridges, plateaus, and trenches, and also contributing to the environmental aspects of the chapter 19, changes in seabed mining with focus on deep sea ocean minerals and mining. And you can see here what Pedro was saying. These are the polymetallic nodules in the bottom of the ocean. This is a rich area with polymetallic nodules. This is a cobalt crust with all the associated fauna, the cold water corals and sponges. And this is an inactive hydrothermal vent that exists in the mid-ocean ridges and back-arc basins. But the ocean does not like to be divided like this in marine habitats. So if you look, we have all the deep sea, we have the continental slopes, the trenches, the seamounts, the abyssal plain, the hydrothermal vents and the ridges, and the insular slopes. So it was a kind of, all the deep sea chapters, we were communicating with each other to see what was being addressed in one of the chapters that was different from the other, how we can combine and relate to each other. And first thing, what is an environmental change? An environmental change is a change or disturbance of the environment that are caused or by human influence, which is most often caused, or by natural ecological processes, and can include numerous things if they are natural, like disasters, human interferences, or even animal interaction can give an environmental change. And when we look to the scales and to the processes, we can see that we have here, this is the time scale, and this is the spatial scale. And we can see that when we talk about organisms, we can have, the processes can take from a few minutes to more than 100 years. And why is that? It's because the deep sea organisms, there are lots of deep sea organisms that have characteristics that are very vulnerable to any disturbance. They live very long. This morning we are talking about the orange roughy. It can live until 200 years, and it reproduces the first time around 40 or 50 years old. And the offspring is very, very low. We have the black corals on the deep sea. They can live until 2,000 years, and they reproduce the first time around more than 100 years, and the offspring is very low. They grow slowly. The black corals, they grow 0.08 millimeters per year. So to have 1 centimeter, it's more than 10 years. So there are lots of processes that in the deep sea, they can be short in terms of spatial scale, but they can be very long in terms of time scale. So this is something that we need to remind when we are talking about environmental changes on the deep sea. Also, another thing is that the deep sea, except on the deep sea hydrothermal vents, that also rely on what is coming from the inner Earth, they depend on lots of oceanographic processes like fronts, eddies, like mesoscale phenomena, decadal oscillation. So everything that arrives to the bottom of the ocean that will contribute to the environmental change, some of these processes, they are decadal or centennial. So when we talk about environmental changes on the deep sea, is something that we need to have also in mind. In 2010, there was a review that was saying what are the temporal changes in deep sea ecosystem and how can we measure them. So we have here the local disturbance, the interaction between the organisms, competition, predation, and this is a local scale and in a short time frame. Then we start having the resuspension of the sediments, for instance. Pedro was talking about this potential impact of the plumes, the resuspension of the sediment, and it's something that on the deep sea, it takes at least a lot of time to resettle again, and it can go on for long periods of time. Then we start seeing what's happening in terms of all these green, which are biological changes that will influence the bottom of the ocean. We can see that in terms of scales, it increases the scales and also start increasing the time that are related. And this we can infer by proxies because it's not observable. It's about observation, remote observation. This is about things that we can do experimentally or measure in situ, and these ones are the ones that we need to use proxies to understand. And what are the changes that are made by humans? So we have, on the deep sea, we have the disposal, and the disposal goes from the sewage, dredges, pharmaceuticals, radionuclides, munitions, litter, even CO2. There are lots of experiments to store CO2 in the bottom of the ocean, shipwrecks. Then we have all of these climate impacts that will change the nutrient loading, the stratification, hypoxia, etc., that was talked also during this morning. And when we go from the exploitation of the fossil fuels, we have the pipelines, the ghost fishing, the potential mining, the trawling, long lining, etc. So these are the potential impacts, the human pressures that can change the bottom of the ocean. When we look to the climate change, and this was a recent paper of science from Lisa Levin and Nadine, we can see that there are three main aspects of climate change that can affect the deep sea, which will be the warming, the acidification, and the oxygenation. And some recent papers show that parts of the ocean, including the North Atlantic, will be very much affected by the warming and by the oxygenation. And here we can see that these are already the human impacts that we have in the different habitats of the deep sea. And why do we care about this? Why do I care if I maintain the biodiversity, if I maintain the function of these systems? It's because the deep sea provides a lot of services, and these services can be regulating services, supporting services, or provisioning services. For instance, if I have a cold water coral, the cold water coral is very important because it contributes to the carbon sequestration. It's also very important for habitat formation. Also, the cold water corals are very important for the local nutrient cycling, regional local circulation, secondary production, and biodiversity. And why do I care about this? Because all the living resources that we are taking from the ocean depends on this. So we really, when we think about the impacts, we need to care, because it's not only what we see that provides a lot of services. The deep sea has very important services. The nutrient recycling also depends on the deep sea, etc. And what will happen on the deep sea under global change? Well, we can have two major impacts. We can have the impacts on the biology of a single organism that can alter the biogeography, the demography, and can do local extinctions. And the global change can be in terms of food, circulation, oxygen, temperature, pH. And we have the impacts that are on the interspecific interactions of the different organisms, including the microbes, that will change the function of the system. And you can see here that they will influence all the different size classes and the different types of organisms. And this is not to scale, but of course the bacteria, it's the large biomass and virus, and of course the top predators are the lower biomass. So we think that when we are influencing, it's not just about one type of organism, but we are influencing the system. So we had the hard task to try to see what are the environmental changes in all the deep sea hydrothermal vents around the world and cold seeps. Also, we had to see if there were environmental changes along all the ridges around the ocean, and we tried to link with several chapters like climate change and all the others habitats, like the seamounts, because there are seamounts associated to the ridges, like the open ocean, etc. And with the deep sea mining too. And this is a picture of what we can see in the mid-Atlantic ridge around 1,000 meters. And also, what is the importance and the environmental changes on the trenches. One of the things that we realized is that despite in 10 years the technological developments are huge, in all of these chapters about deep sea, we realized that there are huge, huge knowledge gaps in some of the most basic things, like when do you reproduce yourself? How many eggs do you put? How do you connect to the other environment? Also, in terms of capacity building, we realized that all the knowledge is basically on the Northern Hemisphere and in some Asiatic countries. So we need, if we want to really understand what's happening on the deep sea, which is the largest environment on Earth, we really need to build capacity in all the countries, African countries, South America, all of them, because we need to create awareness that deep sea, it's very important. It has an amazing number of services that the global planet depends, and we need to develop this capacity, we need to improve these knowledge gaps, and we need to improve technological aspects. And when we say improve technological aspects, it's not just about creating new submersibles. It's creating technology, low-cost technology, that can be used by everyone. Even from a fishing vessel, we can have a drop-down camera to see what's in the bottom of the ocean. Thank you for your attention.
I think, for questions. So I'm sure there are some burning questions. So anyone wants to start? You, please.
Okay. Good afternoon. My name is João Janeiro. I'm a researcher here in the University of Algarve. I have a question to Pedro Madureira regarding deep sea mining. And following the presentation from Ana Colasso, how can we regulate something that we don't understand? And how can we monitor something that we don't have technology available for everybody to monitor?
Well, you can listen to me. I would say that, of course, well, for now, I think that we understand a lot of things. We don't have enough data to get all certainty. But I would say that technology is there. So there is enough technology to monitor this kind of impacts. It costs money, of course, but I don't see any problem of technology. But you must realize that this is not happening, actually, in fact. All that you have is exploration licenses. So in fact, when you are talking in the areas beyond national jurisdiction, one of the issues is who is going to go there to collect data, because it costs a lot of money. And in fact, these contractors are the main driver, and these contracts are the main driver to collect data on the deep sea in areas beyond jurisdiction, national jurisdiction. So in fact, you can see these are big research programs that are being monitored by the international community. And there is a lot of projects that have been funding, like MIDAS or GPI Oceans, others. There are new projects now that are mainly the driver for funding these projects are, again, these contracts for exploration. But the exploitation is not happening. You don't even have the regulation. So we are now trying to end by 2020 or 2021 or 2022, we don't know. We'll take as the time that the International Seabed Authority will need to have these draft regulations in place for exploitation. And we expect to have very strict rules in terms of environmental protection, and much more tight than national regulations that we have around the world. So what we need to realize is that our way of living requires a lot of metals. And a lot of our, a lot of our wealth in terms of living is coming from the minerals availability, also including, for now, until now, fossil fuels. This was the driver for humans to be so successful and to be now 8 billion and keeping growing. So, for instance, now if you need cobalt, and you need cobalt and nickel to have these batteries for cars, for instance, you will rely on national jurisdiction in countries like Republic Democratic of Congo, where you know that there is child labor. And it will be very difficult to have an action in these countries, because they are sovereign countries, to improve things. Now, when we talk with the deep sea mining, which is still a concept for the future, you are talking on something that, in fact, is controlled, is monitored by the international community. And I think this is a big difference. It's a big challenge as well, but I think I would rely more in something that is monitored by all than only in some national jurisdictions where we know that it will be difficult to trust.
Any other questions, please?
Sorry.
Hi, Joaquin. I just like to make some comment on that. Normally, I don't know in geology, but in chemistry, when we don't know the things, we go to a lab. We take very much care of what we are doing there, and then we do experiments, and then we learn, and then from that, we start to develop maybe legislation in the future or whatever. So I think at the very beginning, what you need is some very small places in where you can do very small experiments, ensuring that you are not going to cause any damages. And from that, you can learn. And later on, you can do what is dangerous, what is not, what is costly, what is not, and so on. So, and in that direction, I think that the Azores, have a wonderful potential for doing that. Because already you have a wonderful environment with a lot of biodiversity and things like that. You have a lot of, and you have an area that from one island to the other is bigger than from the north of Portugal to the south. So the extension of the sea in Azores is almost like the rest of Portugal altogether. So yes, using a very, very small area to experiment and to learn, that will be, I think, that an opportunity for the world.
Thank you, Joaquin. Any other questions, please? We would also encourage some of the younger people to make some questions. I'm sure you have them. Don't be shy. So,
hi.
This is your opportunity.
Hi. Hello. Yvonne Figueiredo from IPMA, the Portuguese Institute of Sea and Atmosphere. Thank you for this interesting talk. And I would like to address something that is now talking about the new experience and the new challenge of exploring deep sea. And I would like that the panel can at least identify what are for you the main, given the experience that we have already with the explore or more coastal zones, what are the guidelines for a sustainable exploitation of the deep sea in terms of what we have learned? So ecological, what do you think are the main guidelines to be made in the framework in order to address what you tried to answer in terms of the given our experience with the coastal zones that you lovely explain all the problems of nutrients, of the impact of humans. So, thank you.
Thank you. We will have 2 more questions and then we will address all the speakers. So there is one up there, one other here, and the last one there.
Hello. Sorry. Mr. Pedro, you were talking about circular economy, and you've convinced me about the deep sea mining for minerals, but what about the recycling and reusing the minerals that we already used and they are abandoned? And I know it could be useful. I know it's not the area of, the topic of this conference, but I think it should be also an area of interest.
Yes, just one more, please. Here. Aqui. Please show me.
Hello, thank you for your presentation to all the members of the panel. My name is André Moraes, I'm from the Capitania de Porto de Olhão, and I have one question. I'm sorry, I wrote it on my phone just to doesn't forget anything. To Mr. Sergio about regarding the noise pollution. What is your opinion about the increase of the traffic traffic of touristic maritime activity in Rio Formosa, and the number of recreation boats like yachts and etc. And do you think it's urgent to limitate the number of boats in Rio Formosa regarding the now it's a team that is actual about os cavalos marinhos. Seahorses, yes, I'm sorry. What is your opinion about that? Thank you.
Okay, we have one last question there, please. And then we will pass the answers to our speakers.
Hello. I would like to ask Pedro, what kind of regulations are being thought of for the royalties, and if that money can actually be used to improve research once it's an international jurisdiction?
Thank you very much. So we will start with Anna, then Pedro, then you.
I'm going
Para cima.
So, one of the things that we are trying to do is to be able to predict.
Tens que chegar mais perto.
Okay. It's to be able to predict. So one of the challenges that we have is, can we model the environment? Can we predict as we do for weather forecasting? So to do that, we need to acquire data and sometimes use proxies. You're saying, okay, João was asking, if we don't know what's there, how can we protect? So we know how the species are distributed. We know that they depend on a certain current speed, they depend on a certain substrate. So with multi-beam, we try to understand the terrain and try to predict, and then we need to go there and validate. That's modeling, distribution modeling. And it's something that it's easy to go there and to test and to validate in shallow water. Of course, it's much more difficult to go to the deep sea. But it's one of the challenges that we are having in terms of all the science, in terms of reproduction, in terms of recovery of the species, and try to understand these processes. Of course, lots of things we cannot do by modeling. We need to go there to understand how they function. This basic data that is still missing. But it's a process. But the most challenge is that, are we able to predict at the end what is going to happen? Can we model and start improving our models? So that's what we have as a decadal change, is modeling the deep sea.
Thank you. Pedro? Até sim.
Yeah, thank you for the questions. Well, the last one was the easy one, I think. The royalties, yes. The financial mechanism is one of the main targets in discussion now, and is still under development. Well, the United Nations Convention for the Law of the Sea says, well, the royalties that will come from this activity will be used, should be used for helping the developing countries and also landlocked countries that they don't have access to the sea. So this is we are framed from this. So this should be used by helping developing countries, landlocked countries, and to help the humanity in general. So of course, I think that deep sea research or ocean research is part of it. It could be, I don't know. So how it will be used, I don't know, but the goal is to have royalties, to have some incomes to help different activities for human development, I would say. In terms of recycling, yes, of course, but of course. So we really need to increase our rate of recycling of metals. The problem is you need someone to do it. And of course, you need to formulate policies that will help to do that. But to recycle a cell phone, for instance, the main problem is what you have in the resources themselves, is the processing. So the main difficulty with these marine mineral resources is that they have a group of metals that are lying in this piece of rock all together. And the challenge is to separate each one, and this will be economic, and to be economic in doing that, because you don't have metals that are mixed. You have copper on one side, you have manganese, you have lanthanum, whatever. So this is the big challenge. And the processing plant is something that costs billions of dollars. Is really what is really costly in this industry. So in order to do this recycling, for instance, for cell phones, the problem here is that you have all metals mixed. So one thing that I think we need really to improve is the production of this kind of tools, of gadgets that we have. Because it must be easy to separate components, the plastic to one side, metals of one kind to other side, and this will make the difference in the future. But for now, the problem is that this will cost a lot of money to process these materials. That's why it's not so developed, I would say.
Thank you, Pedro. And Sergio?
Yes. Okay, thank you for your question. I understand that it may be seen as a stress to have a number of, I don't know, I think you are talking about speedboats and... Yes, yes. Well, I think that one of the factors that is very important that should be taken into account in regard of recreational boats is that the frequencies are relatively high when compared with shipping noise that I mentioned in the presentation. So what happens is that the signal is very much attenuated. So the effects, there are effects, but the effect is very local or where the boat is. So it doesn't propagate very far. And this is even particular when you talk about the Rio Formosa, which is, it's enclosed, but is very shallow. So in shallow water, the signal is, the energy doesn't propagate very far because it's attenuated by the bottom and surface reflection. So I would say that the effect in global terms is low or very mild regarding speedboats and, I don't know, jet skis and so on inside the Rio Formosa.
Thank you. Pedro, would you just like to elaborate a bit on the question on the royalties? Or do you think it's enough?
I think I answered. Just to mention that there is a question of sustainability. Well, this is a word that I really have some problems. I'm always struggling when in the context of mining, because what mining, we are removing something that is not renewable in a human scale. Although the mineral resources at sea, that formed at sea, the rate of renewal is much faster than any metallic resources on land. On land, if you exploit any metallic resource, the age of these rocks will be hundreds of millions of years, and at sea is at least one scale below. So it's much faster. But I don't like very much the word sustainable in the context of mining, because I would say that our way of living is not so much sustainable. But will be another question.
Thank you very much. So can I ask a round of applause just to our speakers? Thank you very much.
Quem é que é primeiro? Inês Gomes. Deixa-me. Quer ficar? Fica deste sim, estou só. Ai, qual é que é? Estou só a passar aí da Inês e do professor Fábio. Só mais um. Já está, já passei, já está no fecheiro da conferência. Sim, exato, sim, eu reparei. 11 de novembro é esta. Depois do resto não tinha nada lá de cima, a conferência, então achei que fosse aquela. Está a passar. Falou?
Sim. Não pega. Olha, como é que é? É para baixo? É para baixo? Como é que é? Este é para cima. Para cima é para falar.
Vai ser moderadora?
Sim.
se fazendo um intervalo naturalmente.
Fugiram todos.
Fugiram todos.
Vá, vá, vá.
Calhar era melhor realmente falar, olha.
Só que eu não tenho coffee break agora.
Não, sem coffee break falar, olha. Vamos começar.
Está a trabalhar.
Se calhar é preciso também usar isto?
Não, não.
E como é que eu desligo quando...
Tem aqui. Agora está.
Agora está.
Está e não está.
Tem uma contacto?
Quem é que faz-me logo? Dá um logo isto. Ah, 1, 2. Tchau, vem cá aqui.
Não podes esfregar contra a roupa, porque depois faz-me som.
Ele está encostado, ele não vai esfregar. Sabe?
Não, depois...
Pode falar, professor? Fale normalmente.
Hello? 1, 2, 3.
Manda falo para o microfone. Deixa estar.
One,
Agora eu
two.
vou pôr em mute. Fica
1,
logo
2,
ligado.
3.
E lá em cima, se depois se ver que a sua voz não está...
Pois. Vamos começar a sessão, se faz favor. Já estamos meia hora atrasados. Portanto, esta sessão tem o título de UNCLOS Anniversary and the UN Decade of Ocean Science, Critical Moments Ahead. E, portanto, a primeira pessoa que vai falar é o Luís Menezes Pinheiro.
Isto funciona. Isto... Há aqui qualquer coisa que isto não está a passar para ali. Isto está aqui com... Ok, acho que está. Ora, muito boa tarde a todos. So I will now turn to English and I'm going to take you through what we are preparing in the IOC and which then became a UN Decade of Ocean Science for Sustainable Development. So we've been all looking at the different problems associated with the ocean and also the important things about the ocean. So as we know, it's a source of oxygen, it's a sort of where we regulate the climate, it has a huge importance. It's a huge, vast
amount of diversity is in the deep sea. Resources, food, water, energy, also very important for economy, for health, for jobs, for maritime transport, for leisure. But of course, it's also an area where we have lots of natural hazards. And all these concerns, so if we want to have a sustainable development with jobs, with economy, at the same time working against poverty, we need to look at the oceans. And 70% of our surface of the Earth is composed of oceans, which are actually very deep. And so we need to put the science at the work of humanity so that we can address these problems. So, as you know, one of the main issues is that everything is connected in the ocean, so anything you do in a particular place can affect everywhere. So we have seen this in the atmosphere, but in the ocean, it's not as fast, but it's almost as efficient in terms of propagating problems. And as you can see here, this is an image from NOAA with the modeling of eddies that we have, and what we can see is that it's very, very dynamic environment, which means that anything that we do in one place will be spread very fast. Also, sometimes we forget that we live in a very, very thin shell that is surrounding the Earth, and the proof is that we have all these, I'm not sure, I have one here. So the proof is that we have all these ridges in the deep sea, and we have these plateaus and so on, which show us that we are in a very, very dynamic planet. And this is also the source of where we have the origins of life, is the ocean. And we are now starting to understand many of these things and many of the processes in the deep sea. For instance, here, in the left, top left, you can see carbonate chimneys. And these are dolomite. These are made of dolomite. This is a way that nature has found to get rid of the problem of methane. So it can precipitate into carbonates, and this is done by consortia of bacteria and archaea. So these are processes that we start to understand, which may help us in the future to deal with problems like carbon and methane and so on. Also, we realized when we started exploiting the deep sea that when we think about photosynthesis, this is just a small part of how life is sustained on Earth. Chemosynthesis is highly important. The role of bacteria, and we have there, this is a bacterial mat offshore Egypt. We can see that here the consortia of these bacteria and archaea, they have a huge role in controlling methane emissions, also in supporting deep sea extreme ecosystems. And they work in symbiosis, and they are responsible for lots of issues concerned with carbon sequestration. Also, we need to think that the ocean is also a source of natural hazards, and we need to be prepared for those. So these are images from the Sumatra earthquake. As you know, we have all the plate boundaries, and earthquakes and landslides, massive landslides like this. So this is a massive landslide offshore Norway. It's the Storegga slide. This is the size of Iceland, so you can see it's a huge event. So these events, which are natural, they will produce huge impact on communities. So we need to properly address those, to have effective warning systems. We have to have monitoring, and of course we have to have education, because as you can see, many of the people are totally unaware of what's going to happen. Instead of knowing the signs, we had just said on the past day 5 of November, on the 5th of November, we had the Tsunami Awareness Day. And as you can see, many people, they stay there and just take pictures when the tsunami is coming. So something needs to be done on that. So the other thing that we realized in the past few years is that we need an healthy ocean if we want health, human health. So we need healthy oceans because climate regulation depends heavily on the oceans. Sustainable development will depend on us having an healthy ocean. Of course, like we were seeing this morning when we are sending pharmaceuticals, all the rubbish litter that we are sending into the ocean, we are compromising our own health. And the problem is that what we don't see, we think it's a place where you can send things you don't want. And actually, we are sending all this rubbish into the sea, and we are compromising all the ecosystems, and so we need to take action. So during the whole sessions that we have, during this day, we have seen most of the anthropogenic impacts concerning eutrophication, acidification, global warming, deoxygenation, and so on. and their causes. And this has caused us to realize that we need to act, and we need to act now, because it's past the time on which we were talking about these things. Of course, we also need to separate clearly what are anthropogenic effects from natural effects. So in the past 400,000 years, we had huge changes in climate, and these are independent of human. But what we can see is that in the last, since the Industrial Revolution, we are inputting a signal on top of this, which is our own fault, and this one we can control. So the Intergovernmental Oceanographic Commission, which was created in 1960, and we work in the UNESCO, and Portugal is a member since 1971. We are 150 member states, and we are promoting programs and international cooperation in marine research, services, observation systems, hazard mitigation, this is one of our key issues, and capacity development. So, as we have seen before, it's fundamental that we work on capacity development for least developed countries, because they have a critical importance if we want to sustain the oceans. Also, one of the things that is important is that we need to improve governance management, and this is something we do. The other thing we also do is the coordination of global ocean observation, which is fundamental and needs to be linked, and is already quite linked with atmospheric observation through what was the JCOM, and now we have a new advisory committee to work together between the IOC and the WMO. So one of the things that is important is that we are starting to work together now, and we need the commitment from all countries so that we can properly address these problems. So one of the things that we want to do is to ensure that we will have healthy marine ecosystems and services. Many times the value of this service is not properly assessed, so we need to do it. We also need efficient warning systems. Many of the causes, for instance, when we have tsunamis, last tsunami in Sumatra, we could have saved many lives in India if the things were properly done. So we need to improve these systems, we need to improve communication systems, we need to improve early warning systems. So the other thing is that we need to increase the resilience and adaptability to climate change. Climate change will happen anyway, always. Now we are inputting a sign which we can control, but many of the things we have to adapt because they will happen anyway. And like when we talk about resources and the need for new resources, one of the things that we have to address is the consumption that we have nowadays, which is totally unsustainable. We cannot be changing mobile phones every year or twice a year. It's totally stupid. It's not sustainable. Again, we cannot continue to build on top of the sea, very near the sea, because this is something that is not sustainable as well. So we cannot start to do lots of work in trying to protect these areas when people are building just on top of the beach, because this is not sustainable. Even, for instance, concerning the Sumatra earthquake, before there were always tsunamis in that area, and much less people were affected, because the locals, they would pass on the message to their children and to their grandchildren that they should not build near the beach. Of course, when the gringo comes, they make the hotels near the beach and so on, and then we start having these problems. So we need to address these very well, and it's absolutely important that we work on capacity development for these least developed countries. Also, increasing the knowledge of the ocean, understanding the ocean processes. It's not only understanding a few key issues or a few topics, you have to understand the ocean as a whole. It's extremely important, so we need to work a lot on ocean literacy. So, taking account of all these problems and all the crises that Alan mentioned this morning, which are real, we need to take action, and so the IOC started a few years ago on a project to build a new decade of ocean science for sustainable development. This had a large contribution from Mario Ruivo, whom I think all of you know, and the idea is that we promoted this as a UN initiative. And so in late 2017, at the end of the year at the UN, this was proclaimed the UN Decade of Ocean Science, 50 years after the previous decade on ocean exploration. So Here we have an opportunity, and this is a lifetime opportunity, and it's our obligation to do something to work against what could be an irreversible process if we don't act now. So we need to reduce marine pollution, we need to manage and protect coastal ecosystems, we need to address the question of ocean acidification. This is something where we need to act. And of course, this is not acting only at sea. We need to have an interface between what is happening on land and at sea. As you've seen, the questions of nutrients coming into the waters and causing algal blooms, toxic algal blooms, the question of ocean acidification due to our emissions of CO2, these are things that we need to work on land. So the other thing is that we need to protect, and we need to be able to do a compatibility of uses. As Pedro was saying, we need to exploit these metals, these minerals, but at the same time we need to protect. Finding the balance, this is the challenging thing. And of course, building the science that will help us to support this new view of the ocean, integrated view of the ocean, which will give us the tools so that we can exploit in a sustainable or in a responsible way. So it's important, the question of information, so we need to have digital atlas of the oceans. It's important to have observation networks, distributed networks. IOC is coordinating GOOS, which is Global Ocean Observing Systems. We need now to use distributed systems with satellites. We need to use science citizen new tools, like for instance having distributed networks of observation in ships, in major ship liners, but also in small fishing vessels and things like that. So this is a new era where we need to take action, and one of the key issues is that we don't know the ocean floor. So this is just a quick overview. A few years ago, well actually 2 years ago, we had about 6% of the ocean floor mapped with adequate resolution. Thanks to the efforts that we've done in the past 2 years, we were able to get lots of data from private companies like Fugro and other service providers, and now we have about 15%. But still, we need to map all the other 85%. And this needs to be a global effort. In particular, for instance, in shallow waters, we need this coverage, because if you want to model tsunamis, you need to have this information. If you don't have it, you cannot properly model the run-ups, and you cannot estimate what's going to happen. So this is a major endeavor where we have to work together. We are doing that. There is the Seabed 2030 initiative, which is progressing, and there are all the initiatives that Nuno mentioned this morning on the Aura, everything we are doing for the Atlantic. And of course, this is what we can map, the type of maps that we can have onshore, and this is what we want to have offshore. We need this, absolutely. The other thing is the global observation systems. You can see in the top left, this is in the 1950s. This is the coverage we have now, for instance, with Argo systems. We have about 3,700 buoys nowadays. And this is something that we absolutely need. And for instance, Portugal is still not having its own Argo buoys, so we need to do this. And particularly in the recent years, we were able, and also at the IOC, we were able to negotiate what type of sensors we could use, biogeochemical sensors we could use to map the ocean. And we agreed on this. Besides temperature and salinity, we have oxygen, PhD, nitrate, chlorophyll, backscatter, and irradiance. So these are the new sensors that we are using in Argo. We are also using new deep Argo floats. And this is what we have with the new Argo system, the coverage that we have now, and the coverage that we have with the traditional Argo. So we definitely need to improve the biogeochemical Argo coverage. This is fundamental for all states. The other thing is, as you know, concerning ocean acidification, we will have huge problems, particularly this is the situation that we had in the 1850s, according to legacy data. But nowadays, what we can see is that if we continue to increase the amount of carbon we release in 2100, we will have serious issues here, because the organisms in the water that segregate either silica or carbonate shells or endoexoskeleton, they will not be able to do it. And so this will disrupt all the chain. The other thing is the regional tsunami warning systems. We still have a lack of warning systems because we don't have enough monitoring capability. Nowadays, many of the deep sea cables are going to be changed soon, and we need to be starting off smart cables where we can use sensors, when we can tie in deep sea observatories, and this is something that we are doing now. Portugal has just been operating a warning system for the Northeast Atlantic since end of 2017, and very soon it will be an authorized service provider. So what we want to do is a clean ocean. So we want to address the sources of pollution. We want to have a healthy and resilient ocean. So we need to first map the ecosystems, identify the ecosystems, investigate how they work, look at connectivity between ecosystems, and see how we can reduce the impacts. Also a predictive ocean, so we need to be able to understand what are the hazards that can affect us and to properly forecast them. We needed to be also able to do safety operations at sea, so we need to have a good surveying systems, and nowadays even with microsatellites we are looking at ways in which we can observe the ocean in a much more effective way. We need to be able that we are able to get our food from the oceans, but at the same time be able to conserve the stocks and do proper stock assessment. And we need to have all this data available to everyone, and we need to have it available so that we can inform decision makers based on the best available science. So don't have time to go on this, but just to tell you that within the decade, which is going to start in the next year, it's going to start in 2021. But we are now already working on concrete actions that we want to do, things like a complete comprehensive eDNA sequence of ocean life, so environmental DNA. We need a coordinated program on ocean acidification. IOC is responsible for this. We are looking at the potential impacts of environmental and climate changes at local, regional, and global level, and provide actions, for instance, like adaptation, not only mitigation, but adaptation. And of course, you will find all these in the preliminary roadmap that is available in the IOC website. So all this information is there, and we are hoping that we can get a complete mapping of the ocean floor. Also, when we do the multi-beam bathymetry, we can get the backscatter also processed, which is not being done routinely, and this will be most useful tool for habitat mapping. So there are all these actions. Why is this important for Portugal? Because we have a huge area under national jurisdiction. Of course, the jurisdiction that we have in the extended continental shelf is for the exploitation of the resources. Okay, it's not for anything else. And this is something that is important. Also, it's important for Portugal that we look at hazard, seismic hazard, because we are near the plate boundary. We have these huge faults. Some of them have 1,000 meter throw in the ocean, so you have a scarp of 1,000 meters. It's higher than any skyscraper that we have on Earth, and so this is areas where we had the strongest earthquake in Europe in historical times. So we have a lot to do concerning warning, tsunami warning, and protection. Also, the question of materials, critical raw materials, which Pedro has already addressed. And as you know, most of the wars, the wars always are rooted in problems connected with resources. And if we look at critical raw materials, and these are the ones that have been identified by Europe, you see that most of the production, this color is from China. So they are controlling most of the production of these. In 2011, they threatened to stop exporting rare earths to Europe. This would cause a huge economic crisis. So we have to be very careful about this. And why is this relevant for Portugal? Because we have crusts rich in cobalt and nickel and other metals. We can find them here. We've been looking at this for a long time. We also have areas here near the Mid-Atlantic ridge, near the Azores, where we have hydrothermal systems, where we have massive sulfides. And we also have areas in the southern Portuguese margin, and also the Spanish and Moroccan margins, where we have all these mud volcanoes, where we have extreme ecosystems, extremely interesting, associated with methane. We have gas hydrates, which could be a cleaner source of energy than conventional hydrocarbons. And putting all this together, it's clear that in Portugal we have a responsibility because of the area that we have, because of the extreme ecosystems we have in the deep sea, because of the biodiversity we have. We need to be working together. And one of the things that we would like to mention also is that very recently we had an agreement between the IOC and the commemoration mission for the 500 years of the Magellan circumnavigation. And the Sagres will do a circumnavigation voyage around the world, and she will be an ambassador of the objectives of the decade. So what I would like to finish is by saying that at the Portuguese Committee for the IOC, we do look forward to hearing from you, particularly the younger generation. If you have good ideas, we do welcome them, and please come and talk to us. We need help, we need your contribution, so thank you very much.
And about all the work that the IOC is doing. And now we have Inês. Inês is going to talk to us about the law of the sea.
Conferência acima, 11 de novembro.
Onde é que está isto aqui? Conferência acima. Vamos lá ver se o teu funciona direitinho, sem problemas, tá?
Eu preciso de pausar aqui alguns. Não está? Está assim meio...
Eu acho que é o cabo academia aqui. É este aqui, é isso. Está fora. Tá, se não mexer aqui, acho que não fica amarelo.
Ok. Tá. Obrigada. I'll now turn to English. So, today and tomorrow we are celebrating a few anniversaries. The creation of the University of Algarve, already mentioned, more than 20 decades of CIMA, and the 25th anniversary of UNCLOS, marking the entering into force of the Convention on the 14th of November of 1994, after the ratification by the 60th state. During this whole time, a lot has changed in the law of the sea and broadly in ocean affairs. But interestingly, a few of the trends developed during the negotiation of the Convention and for a while considered perhaps less relevant are now at the top of the priorities for the ocean. And that is the point that I would like to address, and that has been also addressed in several other communications. So, a bit of history. The United Nations Convention on the Law of the Sea was the last step in what we might call an evolutionary process that began in the first decades of the 20th century with changes in international law of the sea and in ocean science and technology. The first conference on the law of the sea was drafted by the International Law Commission that started its work in 1949 following the Second World War and after the technological developments that accompanied the two wars. The first conference led to the adoption of 4 different conventions that we call generally the Geneva Conventions, and that we might see over there: the Convention on the Territorial Sea and the Contiguous Zone, on the high seas, on fishing and conservation of the living resources of the high seas, and finally the Convention on the continental shelf that introduced the important changes in international law by formalizing the concept of continental shelf in conventional international law. Later, in 1960, a second conference on the law of the sea took place, but no treaties were adopted. The political circumstances of the time were pretty complex, including with decolonizing movements and the appearance of new countries in the international arena. Throughout this whole time, and throughout the whole 20th century, two trends, communitarian and expansionist, faced and battled each other, with their effects being felt in the several regimes defined by UNCLOS. Third conference on the law of the sea began its work in 1973 in this whole context and finished in 1982 with the signature of the convention in Montego Bay in Jamaica, and finally entering into force in 1994, as I previously said. In the words of René Jean Dupuy, a very famous, well-known international lawyer of the sea, even during the meetings of the preparatory committee, we could see a microcosm which perfectly reflects the new political forces confronting each other in the new international society born in the post-war period. 3 committees were created. The first dedicated to the seabed and subsoil, the second one beyond national jurisdictions, the second devoted to all the substantive regimes of the Convention, with the exception of the first and third committees, and the third one to marine environmental protection and preservation, marine scientific research, and development and transfer of marine technology. Several other groups were created, formally or informally, to deal with specific issues or to solve particular negotiation problems occurring during the conference. This whole process of 9 years of negotiations were strongly influenced by intense political convulsions and by some persuading political and economic movements, including the new International Economic Order, the Treaty on the Peaceful Uses of Outer Space, the United Nations Conference on Human Environment, already mentioned today also, and the United Nations Conference on Science and Technology for Development. The new International Economic Order and the Charter of Economic Rights and Duties of States in particular affected significantly the negotiations, namely through the key concepts of solidarity among nations, including developed and developing countries, and equitable economic development. And obviously, throughout this whole context, we must not forget that at the time, there was a political, particular context, the Cold War. All of these influences resulted in a treaty that, according to Arvid Pardo, the Maltese behind the Common Heritage of Mankind principle, is one of the most, if not the most, exhaustive and complex documents ever drafted by an international conference, translating the tendencies in confrontation at the time, innovative and conservative, nationalist and internationalist. This whole regime of an uncommon complexity and magnitude introduced important and numerous innovations. However, the ones that I would like to focus are 3 main ones: the importance of scientific knowledge, of science and technology, the role of cooperation, and the relevance of environmental protection. Evidently, other aspects are absolutely relevant in the Convention: the establishment of exclusive economic zones, the definition of a continental shelf regime in greater detail, the creation of an international court to deal specifically with ocean-related disputes, and the groundbreaking principle of the common heritage of mankind associated with the establishment of the area as a humankind trust, including the creation of an authority, already mentioned here today as well, to administer such space on behalf of all of us. And even many others, like the formalization of the concept that land dominates the sea, with different sovereign and jurisdictional rights being implemented in different maritime spaces. All of this was revolutionary, even from an international law perspective. But going back to the features I would like to highlight in this occasion, they are the ones that are cross-cutting to all these matters within the Convention and that are also highly innovative. The roles of science, cooperation, and environment. These are the dimensions that were groundbreaking for the period when they were being negotiated and that in sort of avant la lettre move are now the current priorities in ocean affairs as we have seen today in different circumstances. The first one, broadly referred to as science, scientific knowledge, transfer of technology, all that, is of vital importance in UNCLOS. The relevance of science is pretty obvious in current-day society. We mentioned that plenty today, but the right to share in scientific advancements and its benefits has been established in the Universal Declaration of Human Rights and also in the International Covenant on Economic, Social and Cultural Rights for many years now. The Convention dedicates 2 entire parts of its 17 to the Marine Scientific Research Regime, Part 13, and the Transfer of Marine Technology, Part 14. The MSR regime, in particular, is a comprehensive chapter of the Convention. It was the focus of high contestation from the scientific community during the 70s, afraid that it would endanger the freedom of research, and convinced that somehow they should not be subjected to regulations. However, this regime is exhaustive and well adjusted, creating a consent or limited consent or freedom regime, depending on the maritime spaces, balancing the importance of conducting scientific research and the sovereign rights of the states. Part 14, on the other hand, is less detailed and unfortunately has not been so widely used. The transfer of marine technology of the utmost importance ended up by, I don't want to be too negative, but ended up by being an almost wishful thinking project of the drafters of the Convention. The International Oceanographic Commission has tried to advance this subject, Intergovernmental Oceanographic Commission has tried to advance this subject, and that should be mentioned. The need to further develop these aspects has been recognized recently with the adoption of the Decade of Ocean Science for Sustainable Development, already mentioned, by the United Nations from 2020-2030, with the specific goal of providing science and better knowledge for better decision and policy making. But also we should mention the World Ocean Assessment already discussed here in detail today. The second dimension is cooperation. It's closely related with the first one in the sense that both parts 13 and 14 emphasize the importance of cooperation when conducting marine scientific research and when engaging in the transfer of marine technology. Cooperation, in fact, is widely present in the Convention and was a clear influence of the socio-political and economic context mentioned before. It is also closely interrelated with science and environment. This is evident, for instance, throughout articles of Part 12, where the relevance of cooperation at the international and regional levels is mentioned, and, for instance, also Article 200, that determines the duty of cooperation between states in the promotion of studies and research programs, and in the stimulus of information and data exchange regarding marine pollution. I'm citing articles of the UNCLOS Convention. Finally, I should also mention Article 263 that states that member states or parties are responsible for the damage caused by marine pollution resulting from marine scientific activities, also in a cooperative mode. But as the Minister of the Sea mentioned this morning, knowledge and scientific capacity are not well distributed around the world. Socioeconomic inequalities are linked and are at the origin of scientific gaps in present-day contemporary societies, so dependent on knowledge and information, with some countries persisting in lacking basic knowledge and scientific equipment. And this is one of the problems that we must definitely address. Finally, but not at least less important, the environment. UNCLOS was the first convention to dedicate an entire part to the protection of marine environment, Part 12, in a treaty that is binding. The requirement to protect the environment is stated unequivocally in Article 192 as a general mandatory prescription for the protection of the marine environment. This is probably the dimension where bigger changes took place as a result of the development of environmental protection and environmental law in the last decades. In a period of climate emergency, the concerns and fortunately the awareness is quite different from what it was in the 70s. However, one should notice, interestingly, that the seed of some of the current concepts was already in UNCLOS. I mentioned the precautionary principle and the idea of environmental impact assessment. Article 204, regarding the monitoring of the risks or effects of pollution, introduces the idea of precaution previously to the proper enactment of the principle in the Rio Conference in 1992. Also, Article 206, regarding the assessment of potential effects of activities that may cause substantial pollution or harmful or significant changes to the marine environment, has similar characteristics with the current concept of environmental impact assessment, nowadays a requirement in several situations. The Convention has not been exempted from criticism, sometimes in a vocal and strong manner. One of the biggest critics, in fact, was precisely the responsible for one of the most important concepts of UNCLOS, the common heritage of mankind, Arvid Pardo. Disappointed and discontent with the path the Convention took, especially after the 1994 agreement, Pardo stated that this historic opportunity was lost. However, the main take that I would like to transmit in this brief talk is that the contemporary nature of the Convention, pushing already in the 70s for subjects that are now, I would argue, among the most relevant ones, is remarkable: environment, science, and cooperation. And it is worth mentioning that the above-mentioned third committee of the drafters of the Convention was entirely dedicated to these subjects, revealing the importance they already had at the time. The regulation of ocean affairs, from the mare liberum that governed for centuries to the changes that took place in the 20th century, were the result of a growing globalization movement where the need for proper international regulation, and not only within borders, was starting to become more and more evident. These anniversaries are somehow a pretext to take a trip down memory lane, but they are also an opportunity to reflect on differences and similarities between 25 years ago and now. One of the most striking similarities is the importance of knowledge, the role of cooperation, and the environmental emergency. During the negotiations of the Convention, and 25 years ago when it entered into force, these aspects were important, and the way they were enshrined in the Convention was highly innovative. Today, they are no longer just important, they became urgent. Thank you.
Deixa eu ver se consigo sair aqui. Será que é aqui? Apareceu. Cadê ele? Sumiu de novo. Foi aqui? Cadê o mouse? Fugiu. O rato sumiu. Cadê o rato?
Está ali?
Está lá.
Está lá.
Tá.
Aqui não está.
Ui, não. Está aqui.
Apareceu. Está escrito Beyond. A quarta de cima para baixo.
Tem que passar para lá.
O ponto
ser aqui, né? Isso. Mas tem que passar para lá, acho eu. Isso. Agora só aqui embaixo. Ah.
Tá não, mas espera lá. Com licença. Ah, tá, desculpa. Você trabalha... Ah, ok. Era assim. Qual é o seu trabalho?
É o quarto, é o que está marcado mesmo. Esse é o Beyond. Esse mas está lá no canto.
Ela puxou para lá. Não sei porque que ela puxou. Ela...
Okay. Let's hope it's function. Well, good afternoon, everybody. Everybody tired? I'd like to thank you so much for my previous speakers. When Luis was speaking, I was looking at my phone. Why I do that? Rio de Janeiro is underwater now. Never rains like that in this November. Something strange is happening with our climate. And I'd like to also thank Inês because she has done a very specific and complete revision about the UNCLOS. I live in Rio de Janeiro, and I started to study the law of the sea before the UNCLOS entered in force. In 1985, I started to study it. And I'd like to thanks a lot for Maria João to invite me to be here. And I will try to share with you some aspects that they are not writing in these papers, where what we have beyond the horizon. After more than 30 years, I will focus in these 6 big questions. Where are we going to at sea? The search of right of rights, the delimitation of maritime spaces, the search for universal rights, the resolution of maritime disputes peacefully speaking, the importance of cooperations, as Maria was telling to us, between states and governance, and the unfilled gaps. Well, the first one I will pass very quickly because Maria spoke a lot about this process. But what I'd like to highlight, since we started to use the sea far from our coasts, we are living in a balance. And this balance and all the theories that becomes studying sea, it is very, very close to the power of states. If we see from 14th to 16th century, the sea was divided by Portugal and Spain, and Netherlands wants to use it. So it has to create a theory that the sea is not from Portugal and Spain. That's why the Netherlands government, the kingdom, asked and paid for Grotius to create the Mare Liberum theory. The sea is for everybody. And as the Netherlands becomes a naval power, in front of Netherlands, we had the UK, an island. Oh, it's a big problem for us. So that's why England paid for Seldon to create the Mare Clausorum. Oh, a little space of sea is mine, and it's not liberum. And this kind of power balance continues during the Pax Britannica in 18th and 19th century. Oh, as I can go everywhere I want, so we have the freedom of seas. I want the sea free for everybody. But when the Pax Americana becomes, after the Second World War, the Truman Doctrine says the American interests is where it is. I don't care where it is. If I want something, I will go there and take it for my country. What we see, this kind of balance has always, in one side, states without big powers, choosing, I have a small piece of sea, but this small piece is mine. And on the other side, the big powers wants the freedom, because they can do what they want and where they want. And it still are until nowadays. So the first great teaching, the privilege of will of states are still nowadays. Look, we're talking all day long about science, scientific problems, but all of these talk faces to what we states do with that. Conventions are signed by states, not by scientists. States sign that. So the Leviathan domain is still nowadays. States are the main actor in international scenario, including for the sea, there's no states. The second challenge, the delimitation of maritime spaces. We have already said this afternoon, more than 70% of the earth are covered by waters. Okay, but let me try to do that. Yeah, 70% could be in this color, but all of this are EEZ or continental shelves. Look at here, and here we don't have still in this map, because it's from 2012, the Elevação do Rio Grande, a big area that Brazil included in the his extended continental shelf claim this year in March. What we see, we don't have more 70% of Earth of freedom of navigation. A sea for everybody. No. It's not this. This. National claims together are bigger than North America. All the sea could be in light blue. All of this could be light blue. Nowadays, we can put more 6 squares in green and blue. So we are almost finding about 55% are freedom. 45% of the sea are national claims. Some of these claims are much bigger than their land bases. One of these is here, Portugal. Other one, United Kingdom, France. So, the second great teaching, the appetite for expansion of exclusive powers over the sea are still nowadays and growing and growing. If we look, for example, just for example, Australia, when Australia, the third country, put their claim over extended continental shelf, she put it together a huge area from Antarctica and said, oh, you don't need to look that. You don't need to analyze this data because I'm a part of an Antarctica treaty. But if this treaty ends, this is my claim. All the states are doing this. Norway, Russia. So the expanding Leviathan domain still remains. The third point, the search for universal rights, freedom of navigation, good order at sea, jurisdiction on the high seas, sustainable use of the sea, and safety navigation. I think after the convention, the fifth one, the safety navigation was the biggest one that we achieved. Nowadays, we are really more safely navigating at the sea. But the other ones were typically asking for great powers during the 9 years in the middle of Cold War. The big powers want to put that principles because they could go where they want. So they didn't think about China. So the third great teaching is the search for cooperation are increasing, and there's no more money to have big naval military powers. So we are increasing maritime alliances, as NATO, for example, as the dreaming of European Union Defense Force. And the maritime domain awareness to share information, because I cannot be everywhere. And I will not talk about piracy because it's very difficult, another different problem. But the fourth, the resolution of maritime disputes. It was a big initiative from the convention. The creation of a specific international tribunal to face with problems at sea. Why we cannot use international justice, for example, the ICJ in The Hague? Why do I have to create a different tribunal? Because here we are in a different jurisdiction. We are facing problems beyond national jurisdictions. And that's why this tribunal was a big initiative in the world. But still nowadays, it has problems. And to face, for example, with arbitral courts, that's a part, it's very law specific for law. The arbitral courts, that some countries agreed and other one did not agree of using these arbitral courses, we have some problems like this. The South China arbitration, that China says, oh, I don't agree with this decision, so I will not legitimate this forum, this court. But it's still a good perspective to have an international tribunal to face with legal problems at sea. So the international society has not legitimated the solution by use of the force. They are day by day legitimating supranational decisions by arbitral courts or international tribunal for the law of the sea, or even for International Court of Justice. The fifth one, the importance of cooperation between states and governments. This cooperation at sea, after the beginning of this century, grew a lot. A lot of forums were created. Southeast Asia has a specific regional forum to face the regional problems of the sea, Mediterranean, including the big Mediterranean with United Economic Zone of Europe, Antarctica with a specific regime, a very difficult problem, 53 countries in a treaty with a date to finish. And to renew it, all the 53 countries have to sign. If one says, oh, I think I don't want to sign, it's ended. What will we do with Antarctica in about 20 years when the treaty ends? Functional arrangements, we have shown in one presentation some regions of fishing, identities, including the CPLP, created to integrate culture, language, but we have the forum to face the sea problems from CPLP, so we use CPLP for that, for example. And the ocean governance. Why we are always speaking about ocean governance? Because ocean governance includes new players, not only states, as I was talking to you. As we are facing for an area, there is no state's jurisdiction. We have to talk with different actors, NGOs, fishing companies, and exploiting companies, shipping companies. So it's bigger of this huge community to decide what to do with the sea. And we have a big gap. The convention created the International Maritime Organization, for example, to face with shipping. The use of sea as communication of ships created a tribunal to face the controversial problems, but did not create an organization to take care the sea. The International Seabed Authority only takes on the floor of the high seas. And just for example, it's so difficult to decide what and where are the jurisdiction of the seas. Nowadays, we are in, I will show you, in a conference of BBNG, all of you know that. And I asked it, why this conference is beyond national jurisdiction? Where does the national jurisdiction ends, and where is it? The answer I had, we don't know where the national jurisdiction ends, but it's beyond that. Because each country says his jurisdiction ends in one place. Oh, it's written in Article 22, in Article 58 of the Convention, only a territorial sea. No, it's not what is written in the Convention. It's what the countries indeed are exercising their jurisdiction. Our countries saying they have jurisdiction on other waters above their extended continental shelf, as they have the power to explode, so they have the power of exercise their jurisdiction over the extended continental shelves. So why they didn't call this conference the Conference of Biodiversity Beyond Extended Continental Shelf? No, because it's beyond the EEZ. No, it's beyond territorial waters, because on EEZ there's only a functional jurisdiction. It's not a planned jurisdiction of the states. So it's very difficult to establish exactly who can do what, where in the sea. And unfilled gaps. Antarctic and Arctic, new regimes for the high seas, access to genetic resources, security at sea, cybersecurity, and increasingly autonomous systems. The race to Antarctica. In this left, in 70s, Terezinha de Castro, Brazilian geopolitical professor, proposed this distribution of Antarctica, with a big problem here. Everybody wants this part, the hottest part of Antarctica. Here's too cold. Here, it's a little bit hot. And we have Argentina, we have United Kingdom, and we have Chile overlapped in this area. They forgot, when the Treaty of Antarctica were signed, well, forget this. It was overlapped. But 2 years ago, Paul Yoten proposed this for Antarctica. So they are still nowadays trying to share the pizza. The new international call, the High Sea Convention, the BBNJ. I was talking during the lunch. This decision of General Assembly signed officially in 19th January 2018, when it was approved by the General Assembly. 5:30 p.m. on 24th December 2017. I'd like to ask you, who is at General Assembly at 5:30 p.m. on 24th December? Why they wanted to approve in this time when they were running to home for Christmas night? Because they were trying to approve this since 2005. But big states, they didn't want this. It's better to unregulate, because if the high seas are unregulated and we have the freedom of navigation, I can do what I want, where I want. And just the small countries were that to vote and to approve this BBNJ. For 3 years, the last one meeting will be next March. I really don't have big hopes for this conference and for a big convention. I hope I'm wrong. And this conference has this, all the scientists know a lot of these 4 goals of the BBNG. But I would like to highlight not this, but this. It's written in the same decision. Institutional arrangements, creation of decision-making or scientific authorities. What is that? A new international organization for the high seas? Do you think the big want that? Links with existing international and regional organizations. Share of power with IMO, fishing. It's not easy. And financial provisions. If the big ones doesn't want this and they have money, who will pay for that? So, not this is the problem. Here is the problem of this BBNG. The creation, the possibility of creation of international organization to take care of the sea, the high seas, and the support of that. Security at sea. IMO was created to take care of the safety, just safety at sea. But we don't have vacuum of power. So IMO started to legitimating and regulating security. For example, the private armored and merchant ships. It's typically a security problem. The international environmental crimes with security repercussions. This is a picture last week on Brazil. Probably this oil comes far from our national jurisdictional waters. What can we do? Nothing. Nothing. Human traffic, if they ask them, are you slaves? Okay, No problem. The convention says we can do the universal jurisdiction for slaves. But if you don't ask him, if you just see them outside in a small boat, a lot of people, how we can say they are slaves, migrants, refugees, and I don't think I put it here. I put it, no, I didn't put in this presentation. There's one interesting point of view of master students. I have never saw one master student show paper, show references. What this Netherlands student said. These people in the Mediterranean, in that small boats, before they entered in the boat, they can realize that it will be sank. So they are suicides. They want to die. And if they want to die, I'm not able to take them from there. They want to die. I cannot intervene of this decision of this person. Look, we can create a theory as we want. This will be a big problem. Why it will be a big problem? We are normally and we are accustomed to hear about vans, autonomous systems, airplanes, but they are much faster than in the sea. Why we don't have nowadays cars without drivers? Because they have to decide very quickly. We cannot put the artificial intelligence as quick as to see a dog or children running suddenly. But at sea, it's difficult. Things occur so quickly. They are very slowly. So it's the perfect space to use the artificial intelligence to take off person from the sea. Miguel Marques this morning told to us the high-level countries, I'm finishing, is just one after this one. They don't want to work at sea. And in a few years, we will see this. And this is a merchant ship, a warship, United States. This one is from Turkey. We have from Russia, from Israel, a lot of, and is this a warship for the UNCLOS? No, there's no captain there inside. It's not a warship. What is that so? I don't know. Something. So the sixth great teaching is this constitution of the sea, the UNCLOS, has not exhausted the need of states to regulate the sea, the high seas, and the resources are still a new horizon to be mastered. Autonomous systems are now a reality, including military proposals. So this is the big questions and the great teachings I want to show you. Thank you so much for your attention.
Thank you very much to the panel members. We're a bit short on time. Should we break now? I think so. I'm sorry, there's no time for questions because we're running so late already.
Oh.
But I'm sure the panel members will answer questions during tea break.
Consegues aparecer aqui? A Inês tinha aqui o computador mini dela.
Mas isso tem as notas.
Sim, tem. Isto aconteceu-me na defesa da tese.
Então, peraí.
Só que eu apaguei as notas todas, porque eu achava que não ia aparecer.
Nós vamos ter, não se esqueçam que nós vamos ter um cocktail no Ciência Viva depois da próxima sessão, portanto não desapareçam. No Ciência Viva em Faro, e agora temos um coffee break.
E agora em inglês para quem não percebe português. Estou a brincar, professora.
O que foi?
Ela foi em português, agora em inglês para quem não percebe português. Estou a brincar.
Onde é que está a pena? Vai, que eu já me fiz muito.
Vocês são mais... Vocês são 6, não é? Sim, tu disseste que o último era 6. Temos é que dar os copos.
Quer dizer, já, mas não fiz nada.
Opa, isto
eu já fiz alterações. Não sei, por exemplo, casaco, eu tiro o casaco.
Fica frio, fica calor, bem de repente.
Eu acho que o casaco fica bem.
Sim, estás...
Catarina, tu estás de protocolo, a gente apresenta de casaco ou sem casaco? Pode ser sem casaco.
Eu tenho ali mais. Eis a primeira.
Não. Mas já estou tão nervosa que a minha forjava-se.
Deixa-me calar.
E agora deixa lá ver se isso aparece aí então mais.
Está aqui. Queres abrir só para verificar?
Sim, que a gente vai apresentar as duas, então não
Eu sei, está lá o vosso nome.
E depois entrar.
Queres ver se aparece lá?
Roupa igual, deixa lá ver como é que isto aparece. É que a gente não está habituado. Eu isto vou tirar. Aqui já não se consegue fazer nada.
Ninguém
não é?
vê. Só tu aí consegues ver.
Ok.
Aqui em frente.
Ih, pá, mas isto é estranho.
Estás para estranho, não?
É que estranho, tu estás a falar e tens que...
Está para baixo daí?
E depois como é que... É sempre com a setinha, não é?
Eu preciso de um café, porque isto tem tanta coisa que vai deu-me um sono. Não, já vou ficar.
Vocês podiam...
Uma coisa que tens, eu leio.
Porque eu ia começar a colocar a linha CPI para mim.
Já temos mais 50 programas para amanhã, consegui.
Já foi buscar.
A Tana disse que já foi buscar. A Tana já foi buscar, a Tana já tem. Já estou muito contente.
Então isto é deste, não é?
Isso é desse.
Ok,
Isso é deste. Isto é o que está a seguir. É para tu saberes, por exemplo, tens este, depois este é o que vem a seguir. E isto é o que está neste slide. A aprender a fazer isto?
Porquê que este está branco?
Nunca dei, não sei.
estou a perceber. Será porque é preto? Parece que está sublinhado.
Não, tem um sublinhado.
Basta sair e ver.
Yeah. Está tudo sublinhado.
Está tudo sublinhado. Porquê que está sublinhado?
Deve ser que sabes o que é, se calhar cortaste isto de algum sítio.
Não, isso é...
Ou já tínhamos isso nos slides. Ou se calhar foi qualquer coisa que eu colei, não? Que isso já estava nos slides que eu tinha feito.
Epá, não, olha, leio assim, não há problema. Como é que leio já a apresentação?
É ali?
Epá, poças, não conseguimos melhorar isto? Espera aí. Que estranho, pá. Será que o slide é preto? Não, isto está mesmo uma coisa na branca. Mas eu não estou a ver onde é que está... Será
Faz aqui.
Não, porque isso é a cor...
Não. Vai aqui.
Onde, Sónia?
Vai lá aqui neste. Este cá em cima.
Ah, já está. Então, vá. E agora?
Agora vais à apresentação.
Ai, é aí que... Tem que só cuidar para não mexer aqui, que isto fica verde.
Ok.
Deixa eu ver, tem mais imagem. Eu não gosto nada das coisas de lei.
Pronto. Já está.
Já podem tirar a pen.
Sim.
Eu vou só fechar. Está ligado. Eu vou só
Está
fechar.
ligado.
O microfone. Vou só desligar aqui, que vocês não são as primeiras. Guardar. Está guardado. Boa.
Não sei porque é que está sempre a dar isso.
Ok. E já podemos tirar a pen?
Já.
Estava só a tentar.
Ela está a tirar.
Olha.
Obrigada.
Ya le dieron el coffee break.
Alô? Tá. Senhoras e senhores, vamos retornar. Por favor. Deixa isso ligar, deixa eu desligar. Se não falo, daqui a pouco está todo mundo ouvindo. Alô? Vamos lá. Well, let us continue this tired but very interesting day discussing the future of our sea, the stress in the ocean. This panel, we have 4 presentations, and the first one is my friend José Joaquim from the Air Center. Please, we have not so much time, so let us put them to speak as soon as they can.
Okay. So, shall I? Okay.
It's not easy. Is this one?
Yeah.
That.
And then. Okay. Okay, so thank you very much for having me. I'm just to try to do the presentation shorter. Today, really, I was trying to talk about international collaboration in order to tackle basin scale problems, especially when we have to look at the Atlantic and problems like has been indicated this morning that are really relevant, like climatic change. We have to do that all together. We cannot do that in a single basis of a research group or a region or a nation. We have to work together, all the countries and institutions around the region in order to tackle with these problems. So there are already several platforms trying to achieve that, as has been mentioned before, through United Nations, through UNESCO. There's several initiatives going on that in relation with observation. Also within the European Union, there is several initiatives going in this direction too. For example, the Berlin Statement or the Galway Statement in order to coordinate activities in the North Atlantic, in the South Atlantic. Also, a lot of flagship projects, like, for example, Atlantos. Also, several initiatives have been developed and now going on this direction. But at the end of the day, is always how we cooperate, how we work together in order to achieve something that we cannot do alone. So I'm not going to talk about Atlantos or about Belén Stadium, because we have in here Sofia Cordeiro, for example, that is going to speak later on about that. So yes, I'm going to talk about Air Center and how we try to organize this cooperation in the Atlantic Basin in order to tackle these problems and that will be related with global scale or with the SDGs, for example. So I think that this is very important also to use the international diplomacy of the science. Sometimes the states, just in the presentations before, we have seen that the relation is between the states. But I think that that is important, but also it's important to have another layers of understanding between the countries. And I think that the researchers in different centers, universities, we have another kind of understanding and also trying to focus jointly problems that sometimes the states are much difficult to deal. So I think that it's also important to have this dimension of how to try to organize all the kind of layers of cooperation between research centers, between research infrastructures, between infrastructures for observation, like vessels, for example, gliders or satellites or so on. So that is also the dimension that Air Center is trying to develop, and I'm going to show how we are going to do that. Finally, I think that it's important that we have to have a mission orientated. I mean, we have to try to tackle problems, joint problems, because at the end, that is what also keeps us working jointly. Sometimes when we have a different interest at the different institutions or different countries, it's much easier to put the people together. So I think that sometimes also we have to try to solve one common problem, and that creates also much opportunities for collaboration through Atlantic platforms. So yes, through the SDGs, for example, that is something that joined all of us in a common mission, or like what has been said before about the decade of the ocean. So we need these kind of things. So just a few words about the Atlantic, the Air Center, in which we are trying to have this international distributed network with different centers in different countries that are working together, but each center is supported by his own country. At the end, we are working together, but we are sharing technologies, we are working together in order to solve problems and also to have common standards, common approaches, and joint activities. So the countries you already know is UK, Portugal, Spain, and Cape Verde. You know, there's a large amount of countries, but also there's other like states that are not collaborating at the state level, but we are working with them in different universities and centers. I don't have much time to go in much more detail on that, but really with the different countries, we are trying to learn how to do this cooperation, because the different countries are organizing in different ways. Sometimes we have just one institution in one country that is coordinating the centers in that country. Sometimes that is not possible, so we have several institutions and we work together with all of them. The important thing at the end of the day is, I think that it's not the color of the cards, is the results. So we are trying to use different approaches in different countries according with the local requirements. So I think that this process of international diplomacy that has been supported by the Portuguese Minister of Science and Technology, Manuel Aitor, has been very successful during the last 3 years. He has organized a lot of high-level meetings with key researchers, key directors of the centers, and that has been developed the Earth Center in the Florianopolis Declaration, and after that through the different high-level meetings. So the next one is going to be held in USA, in the Penn States in next May, and will be important also for all the related issues with satellite especially. We are going to focus on there and all the processing images and so on. So the areas that we are working are in biodiversity, clean and healthy oceans, our mitigation and adaptation of climatic change. So these areas that has been shown this morning that are key and where we have several crises to solve, especially in mitigation and adaptation for the climatic change, as has been shown this morning. So the vision is just to share this common approach between the different centers and trying to provide added value for all the regions. We have to tackle global problems, but at the same time we have to develop local value for the different regions. So we are working in several kind of platforms, in several kind of areas. For us, it's quite important, for example, using the experience of the islands like Azores. The Earth Center they are based there. So the islands sometimes are like living labs in where you can develop some kind of technologies, but not only technologies, but also business models, approach to the people, in which then later on you can escalate the results of these these technologies or these approaches or this business model to the rest of the region, so to the rest of the area. So yeah, I know that we have to go very fast. I'm going to just show a few things about the ESA lab, for example. That is one of the labs that is going to be developed in the Azores using Copernicus images and providing products and services, especially for floods, for mitigation of climatic change, all the things related with coastal erosion. So that will be an important part of the equation. So this will be a very good component, the use of satellites, for example, for the healthy oceans, especially the pollution on plastics, for example. There is some sensors that are going to be developed on this site. It's a lot of work doing also on the treatment of the images. There's also application of artificial intelligence to these kind of things. So it's a lot of technology that could be developed. For us, it's also important to develop an area in the Atlantic space that we call Atlantic Geos, in which we can focus the observation. That is something that we have to work together with the international organizations in order to focus on that. But of course, it's not a question of satellites, it's a question of integration of in situ measurements. This is an important area in which several projects are going on. We are also like to contribute on that. And then some kind of projects that we are doing, like Mission Atlantic, for example, for mapping and assessment the present and future status of the marine ecosystems and the climatic change. There is other kind of projects also in relation with aquaculture that we are working with in order to have alliance for aquaculture across the region. I think that we have to learn from each other, don't reinvent the wheel here and there. We have to share the knowledge, we have to transfer the knowledge and not start it from scratch every time. So that is important. There's other kind of projects related also on that. I'm not going to be much more detailed, but the idea is always the same, just sharing the technology, don't trying to have mobility of the people. That is quite important. At the end of the day, it's not only just a question of attracting the people, it's just a question of provoking mobility from one place to another, and these interactions, these Atlantic interactions are creating value for the global scale and for the local scale. We are working also on biodiversity. With MBOND, we are going to have in Azores a center there for the Marine Biodiversity Observation Network. That is together with the Blue Planet. In the issue of multi-use offshore platforms, we are going to work also there. We have also some experience in our network. For example, in the area in Plucan, in Canaries, we already have been working on that with several questions for marine energy, for example, also for offshore wind energy, providing new prototypes. So this is the kind of activities and technologies that we are working on. And just the final slide is that we need, in this kind of approach, we need much more innovation on the kind of interaction, on the way that we have to work together. We live in a liquid time, so we have to put that into actions. We are not solid rocks anymore. The universities and research centers, we are knowledge that are moving from one part to another, and we have to do the implementation of that in the practical way. There's many tools that we are experimenting, but later on, if you're interested, I can go in much more detail. So thank you.
So we can pass now for Flavio. The next one, please. From SEMA.
Okay, so good afternoon, everyone. I was asked to compress in 10 minutes what I was preparing for 20. So some of the slides, I will just read the title. But anyway, so I changed a little bit the title of my presentation for the role of SEMA in ocean observation and modeling, lessons from the Atlantis project. And I will start by presenting a background of projects that led to the Atlantis, namely the Argomarine project and the Ocaso project. And then I will refer briefly different aspects of the Atlantis, focused more on what we have developed here in SEMA, but also referring to other work from other groups. So the background, I would say this was an important project in the University of Algarve, the Argomarine. The aim was to develop an automatic oil spill detection system, and it was focused on the Tuscany archipelago in the Mediterranean, in the coast of Italy. It was run from 2009 to 2012, and it was a FP7 project. Our main objective was to create operational model to forecast oil spills, basically. And we did, what you see here is an animation of a system of 3 levels of downscaling of oil spill forecasts. And during the time of the project, this happened. It was the Costa Concordia accident. And because of the Costa Concordia accident, we had the ability to show that our system was working. If you remember, the accident was somewhere here in the Giglio Island. And the Coast Guard was really concerned about the possible spills in that area. So what we did was to create an additional level around the island with a very high resolution, and we have been running during almost 1 year forecasts of 3 days of oil spills in that area. And we were helping the Coast Guard, and we were every day giving those forecasts and helping the Coast Guard in the management. So this was an interesting project. Another interesting project was the Ocaso project. In fact, it is ending now. It is an Interreg project that joins the University of Cadiz, which is the leader, the University of Algarve, the Hydrographic Institute of Portugal, the Oceanographic Institute of Spain, and Puertos del Estado. And what we are doing is to create an observatory, so a network that combines observations and simulations, forecasts of different groups, and we put all together in the same structure, in the same base. What we have is observations, we have tide gauges, oceanographic cruises, HF radars. We have acquired this AUV to complement the data. We are operating with the tsunami alerts using high-frequency radar data and tide gauges. So basically, we are putting all together in the same system. And the same with the models. We have many different types of models. The University of Algarve contributes with one model, but other groups have other models, and we are integrating all the data in the same platform. And with that, the objective is to create products for the society. So basically, we are creating products for the society. So this is just an example of the cruises we are doing with the cooperation of the Portuguese Navy. We thank very much the Portuguese Navy because they are helping us pro bono on putting the systems on the sea. The UV is here and a drone over there. And this is an example of one of those products that I was talking about. This is an example of how we can, using that data of the observatory, we can pick an observation of an oil spill, and we run our models backwards in time. So basically, we can, picking that spill, we can run backwards in time and forecast the possible positions of the spill before the detection. And if we cross the positions with the AIS references of the ships, we can somehow, with these error margins, we can identify the possible guilt, the possible ship that made the spill. The offender, that was the word. Another example is our collaboration in the exercises with the Navy, with the POLEX exercises with the Navy, where we run also our models and we give this kind of forecasts. So coming to the Atlantis, Atlantis is a very big H2020 project. So 62 institutions, 20 million euros. And the general aim of the project is to optimize and enhance the integrated Atlantic Ocean observation system. So basically, to define the new generation of observation system in the Atlantic. So the objective is to integrate the so far loosely coordinated set of existing ocean observing activities into a more sustainable, efficient, and fit-for-purpose integrated Atlantic Ocean observation system. So this is the big objective. Because we are using a lot of network, we need to create a network. We have a few partners that are networks, network partners, basically. So these are the work package of the program. We have been working on this work package, which is the demonstration of the utility of the new ocean observation products. So it has many different products to show, from harmful algal bloom mappings, coastal floodings, aquaculture site selection, reanalysis to improve the policies, management of tuna stocks, safe ship routing, oil spill, training, and all these products have been certified using the opinion from the end users that was collected with some inquirers. So these are examples that I will pass very briefly. Harmful algal bloom. So basically, in all the cases, what we want to do is to integrate data. Integrate data from observations, from modeling, from in situ, and using the expert interpretation, create products. Basically, it is the same in all the products, in harmful algal blooms, in coastal floodings, in ship routing. So basically here, what we are doing is using current data to optimize the route of the ships, in offshore aquaculture siting, in reanalysis for helping the policies, in tuna populations to forecast tuna populations. And what we have been working more in deep was the oil spill hazard mapping, where we have been creating oil spill hazard mappings for the entire Atlantic Ocean. And that was made using meteoceanographic simulations, using the products from the Copernicus marine system. And what we do is hypothetical oil spill accidents along all the coast of the Atlantic. And it represents about 1 million simulations. It's a very, very computational demanding process. So we have been optimizing that. And what I show here is an example in a single point. So these are the results of many different discharges, many different virtual oil spills, if you want, in different periods of time. And the aggregated result of that can create maps like this of probability of a spill of a certain dimension arriving to the coast. And with that results, we can create hazard indexes along the entire coast of the Atlantic using functions like this. So this is the result. You can see it in this site, and we have it for the entire Atlantic Ocean. And this is it. I have a movie here that I don't have time to show. Okay,
Atlantos.
Thank you very much.
Thank you so much for being attention for the time. We have not so much time. Now we have Sophia.
Well, Flavio did not have the time to show you that video, but I really suggest that you have a look at it. It's in the Atlantos project website, and it's really, really interesting. Go there and have a look. So I'm searching my presentation. Okay, yeah, done. Okay, so first of all, I would like to thank you to Professor Maria João Biano and the CIMA team for inviting me to be present here today. And this is the title of my presentation, Transdisciplinary in Ocean Sciences and Technology Activities from the Ocean Program at FCT. I will inform you what is the Ocean Program at FCT, what are we doing, and then I will speak briefly about two of the activities that have a transdisciplinary approach. Okay, so I'm almost sure that everyone knows, but the Foundation for Science and Technology is a Portuguese national funding agency for science and research. FCT's mission is to establish Portugal as a global reference for research, technology, and innovation. and also to ensure knowledge generated by scientific research that underpins social and economic development. So I just put these two images here in order to try to discuss or to understand what is transdisciplinary. So differently to the multi or interdisciplinary, transdisciplinary not only intends to define a problem together with the different areas of knowledge, but also share methods and also provide policy solutions. So it really takes into account the societal problems, and then through co-creation together with different stakeholders, we will achieve results and solutions that face these societal challenges. So it's really the main thing here, it's co-creating in order to provide solutions that are suitable for the problems that we are facing, these societal problems. So regarding the Ocean Program, it was created in 2015, and its main activities are to be an advisor to FCT Board of Directors for marine research and related matters, coordinates FCT ocean-related activities at national and international level. Below you have several European initiatives where we do the representation of FCT and or Portugal, depending on the initiatives. Then we also maximize the dialogue among national and international stakeholders, and here you have an example at national level, the Ocean Research and Innovation Agenda, that it was a huge effort that involved 55 experts from the community, and we are almost finalizing this document. And then we have the Air Center that at the international level that Joaquin already spoken about, and then the support to the implementation of the blank statement that Nuno briefly mentioned this morning. And then we also establish synergies with national entities with competencies in ocean-related themes, and we have developed some work within the Ministry of Foreign Affairs and also with the Ministry of the Sea. And with the Ministry of the Sea, we have worked on the SeaMind project, working on indicators for research, ocean research, and also work together with TGPM and the Ministry of the Sea towards, or in the working group, the OECD working group on ocean economy. So the idea is really to integrate and have a holistic management of the initiatives promoting research and innovation in marine science and technology. Of course, we are not doing this because we want. We are doing this because it's important, and we are contributing to national and international strategies, as the Sea Strategy for Portugal, the National Sea Strategy, the 2030 Agenda for Sustainable Development, where we have the SDG 14, and also to the Ocean Decade that has been mentioned quite often today, MFST, and, for example, also the blank statement for cooperation in the South Atlantic with an all-Atlantic perspective. So regarding the two activities that we are developing, the first one that I will mention is the Ocean Research and Innovation Agenda. It's born from a top-to-bottom process. It was started by our ministry, Manuel Heitor, and the idea was to develop 15 research and innovation agenda in several knowledge areas, and one of them is in the ocean. This process started in 2017. So really the goal is to promote a collective reflection. And the objectives are promoting the dialogue between the scientific and business communities and other ocean-related communities, building a medium and long-term vision for the Portuguese research and innovation system, contributing to the creation of information sources that are capable of inspiring and supporting decision-making processes. So in terms of process, and here it's we can see the transdisciplinary coming out. It was an inclusive and bottom-up approach. We had a group of experts, as I said, 55 experts from both the scientific and the business community. There was also a public consultation with the wider community, public discussion with the wider community at the National Forum for Research and Innovation at the Ciência event. Then we also had a consultation with the public administration bodies by means of a specific questionnaire, and then a draft agenda was again put to public discussion in May 2018, and lately we had the result of the assessment by FCT's Scientific Council, and we are at the moment incorporating its comments, and hopefully this agenda will be finalized at the beginning of next year's. So the group of experts led the development of the agenda, and FCT only provide technical and logistical support. So really this is a product, it is a bottom-up product in order to implement activities that are crucial to promote ocean sciences in Portugal. The second activity that I would like to speak about is the All Atlantic Ocean Research Alliance. This alliance is being implemented through a coordination and support action that it's called ANCOR, All Atlantic Cooperation for Ocean Research and Innovation. It is being coordinated by FCT. It's a consortium of 17 partners from 9 countries. At the Atlantic level from both sides of the Atlantic. The ANCOR project is supporting the implementation of the All Atlantic Ocean Research Alliance that born from science diplomacy efforts involving several countries in the Atlantic. It started with the Galway Statement in 2013, then it moved to the blank statement that was signed in 2017, and then in 2018, administrative arrangements. So we have at the moment, sorry, I will count, 1, 2, 3, 4, 5, 6 Atlantic countries plus the EU in these diplomacy efforts in order to promote marine research and innovation in the Atlantic. And why do we need an alliance for the Atlantic, for marine issues in the Atlantic? Because the Atlantic Ocean is an invaluable resource that is shared by several Atlantic countries, and we cannot manage it alone. Why do we want to manage it? Because we need, and our human life needs that our Atlantic Ocean is healthy, resilient, safe, productive, and understood. The basis of this All Atlantic Ocean Research Alliance is creating societal impacts. So it has at its basis the societal needs, and what do we need or which activities do we need to implement cooperatively in order to impact the society. So we will create impact by enhancing the All Atlantic Ocean Research community, putting together everyone to speak, because we know the faces, we know that we are around, but we really don't know what each of us are doing. We also aim to increase operational efficiency within marine research, and also, of course, develop knowledge on the Atlantic Ocean. And very, very important is to promote capacity building, because if we want to enhance the cooperation, especially with the less developed countries, we really have to train this young generation. Otherwise, we might be doing efforts within the rich countries or the more developed countries, but then we will not have the involvement of the less developed countries. In this Atlantic Alliance, these are the areas that we are tackling: climate variability, ocean observation, ocean resources, ocean technology, emerging pollutants, and polar research. The project has started in 2018, of course it follows up the Galway implementation and the All Atlantic Ocean Research Alliance, the AORA project that has been mentioned quite a lot today. And the alliance is, as I was saying, being implemented through cooperation activities. One of these activities are working groups or stakeholder platforms that are being implemented through the coordination and support actions, both AORA and ANCOR. Also the implementation of joint research activities. We have heard about Atlantis, Flavio has just mentioned it, but there are other projects that have been funded with this Atlantic scope and are promoting the implementation of both Galway and the Blaine statements. In terms of deliverables, the working groups in the North Atlantic, so under the AORA, have already developed roadmaps, vision documents, strategies, and they also have, in scope of the Atlantis project, in fact, one of the main achievements, I would say, in the Atlantis project is really that they are trying to move forward from a project to an integrated program, an all-Atlantic ocean observing system. And it's important that we move forward from project-based activities to program-based activities that are longer term. So this is, I think, very an achievement of this alliance. Other activities that involve the community are the All Atlantic Ocean Research Forum. The first one already took place in Bahia in 2017. The second one will take place in Brussels this year on the 6th and the 7th of February. Those of you who are interested in working in the Atlantic Basin, please participate because it will be a very, very interesting forum. We are developing the program. Then we have already developed an All-Atlantic Ocean Research portal and database, and this has been developed through the ANCOR project. You have the link here, so if you have information on, or if you know activities, initiatives, projects, programs going on the Atlantic level, let us know. I will leave you with my email, and we will include it in the portal. Really, the idea is that the portal is a one-stop shop for the Atlantic marine research and innovation. There are already several ocean awareness activities, the Go Atlantic Blue Call for Action, and more recently, the All Atlantic Ocean Youth Ambassadors that they were trained this August in Galway, and they are implementing campaigns in order to create awareness of the Atlantic Ocean. So my last slide, I believe, it's my last one. From the working groups from AOR and what they have reached, now in the south of the Atlantic, with an all-Atlantic perspective, we are implementing stakeholder platforms. These stakeholder platforms will start or have already started in November. And they count with experts from across and along the Atlantic Ocean. The aim is to propose specific transatlantic action that support the political framework of this alliance, and the actions will be implemented by existing initiatives. So really the idea is not to invent any other initiative or any other institutions, is using the resources that are already there, and with those resources to align the efforts and to come up with something that is relevant for the whole Atlantic. The platforms will work in these 5 cooperation means and will tackle all these scientific teams. This is really my last slide. So here we are speaking about OWA, the World Ocean Assessment, and the UN Decade for Ocean Science. And in fact, what we are doing at the All Atlantic Ocean Research level is contributing to, here with these teams, we are contributing, or we will contribute to the UN Ocean Science societal outputs. And really the main message with this slide is that we are already promoting cooperation in the Atlantic Ocean, and the cooperation that we are promoting can be seen as a model for an enlarged cooperation in ocean research and innovation at the UN Decade level. So this is my email. If you have initiatives, please send them to us, and we will put them in the portal. Thank you.
So let's go to the last presentation from this panel. Sonia, Christina, and Priscilla. Please.
Okay. Good afternoon. I'm Priscilla Guella, and me and my colleague Sonia Cristina will be presenting you this topic of ocean color in Atlantic and in the next few minutes, and the effort that has been conducted so far in the last years to contribute to the global assessment of oceans health. I would like to thank CIMA for the opportunity, and because we are short of time, I will pass very quickly to the next. I'm going to present a quick overview of the topic, and then Sonia Cristina will also give you a quick overview of the results we achieved so far and what we are planning to keep working. So as we all heard today, our blue color of our planet is mainly to the fact that most of it is covered by water. It's not the news. And the life inhabiting the oceans, it's very important in shaping Earth's climate. This is why it's a major, it's not a matter of now a curiosity, but monitoring this the ocean is now a requirement. Our capabilities to keep a close eye on what's happening in this system, ideal approaching real time, is not, it's now more and more a challenge. If we think in the case of Portugal, with monitoring such an extensive exclusive economic area is and will probably come even more a challenge which has to be addressed, and for which better monitoring tools need to be developed. And indeed, the oceans monitoring has been a major motivation for several spatial missions and satellites launching across global space agencies with spaceborne sensors designed to collect information about sea surface temperature, remote sensing altimetry, and the ocean color sensor, which we want to draw your attention at in this talk. And the ocean color gives us an indication of the concentration of its optical constituents. In deeper and oceanic waters, the color that the ocean shows is predominantly driven by the phytoplankton concentration, but as their concentration increases, the color changes from blue to green. In shallower and coastal waters, besides phytoplankton, there are other constituents that are also driving ocean's color, and that has optical and that are optically active and interfere with remote sensed signal. Ocean's color sensors derive, just a bit technical part in the end of the day is always good. Ocean color sensors derive concentrations of ocean constituents by first measuring the intensity of the upward spectral radiation at the top of the atmosphere, and the varying intensities are then used to retrieve water leaving radiance after atmospheric correction, and finally leading to the retrieval of optically active marine components. This technique is called ocean color radiometry or ocean color remote sensing, and has proved to be one of the most successful and productive remote sensing technologies. However, its data quality relies on how well and adjusted are the algorithms and how well they are calibrated. The better adjustments they are, the higher quality of the data we can retrieve, and the better we can discriminate between the different constituents of water column. From these constituents, the most important, or one of the most important, and that has received most of the attention, is determination of phytoplankton concentration, and remote sensors do that by determining the concentration of chlorophyll A as a proxy. Relating remote sensing reflectance with what we know of chlorophyll pigment concentration has allowed to develop really good algorithms for remote sensing signal. And why is it important? You all probably today all know, but just a small parenthesis, phytoplankton is the basis of the marine food web, a significant factor in ocean carbon cycle. And on the other hand, it's also related with a number of undesirable effects on water quality, some of those very hard to cope when matters to coastal management, such as, and also public health, which is happening, for example, in harmful algal blooms or eutrophication, and which can cause major social economic losses. And this is why most of space agencies around the globe have invested in the development of ocean color sensors. The first one, Coastal Zone Scholar Scanner, has been launched more than 40 years ago in the late 70s. But since then, more than 20 ocean color satellite sensors have been launched. This is a list of the most used by the scientific community and most well-known. Two of them, Mary's and Olchi, are being operated, or were and are being operated by European Space Agency. In this slide, you can have an idea of several images that are retrieved in this case with Olchi, which is on board of Sentinel-3 satellite. It is now on mission. And at your right, you have an image of total chlorophyll A, then total suspended matter, and at your right, color dissolved organic matter. All of these colors are concentration scale, so data can be extracted from each pixel and used for quantitative analysis. Whoops. Sorry. This is where our team enters. I'm just moving to Sonia. This is our team. Our team is working on the validation of the data retrieved by these ocean color sensors, Mary's and Olchi. I will just draw your attention to the final bullet points in each case, which are the products that we need to ground truth with data. And that's where we are working, providing good and quality in situ data to validate and calibrate the algorithms that are working with in these sensors. Sonia now will going to present you the results we achieved so far, and then the planets.
So, good afternoon. Thank you, Priscilla. So, here we can see where our fieldwork were developed, where we are taking the samplings. Our work was developed in the southwest coast of Portugal, mostly in a transect from the coast areas until 10 nautic miles from shore, encompassing stations with high influence from the coast till more oceanic stations. We are a multidisciplinary team that assembles colleagues from oceanography, from marine biology, and also chemistry. With these different backgrounds, it gives us more strong. And since 2008, we are doing in situ samplings, campaigns, and laboratory analyses that have been conducted according to protocols that were defined by the European Space Agency, enabling the construction of a significant database for the calibration and the validation of ocean color sensors imagery. Our team are part of the MARIS validation team, and now is part of, sorry for the image, now is part of the Sentinel-3 OLSHI validation team. EF contributes with data to deliver to the ESA Mermaid database, which according to the Copernicus program is released publicly and freely for any users. We collect in situ data that allow to test, where we test the MARIS algorithms that were developed to retrieve the total chlorophyll concentration, the algal pigment index 1 that was developed mainly for oceanic waters, the MARIS algorithm pigment 2 that was developed for coastal waters, and also we have developed regional algorithms where we used our in situ chemical and oceanographic parameters, such as the total particulate absorption, phytoplankton pigments, and remote sensing reflectors that allow the construction of regional algorithms that are more adequate to our waters in the west and in the south coast of Portugal. And we test these regional algorithms with the standard algorithm that was developed for the ocean color sensors. Our algorithms were tested for other regions in Portugal, not just in the south, but we tested with data from the north, center, and the south of Portugal, and they give a very good results comparing with the standard algorithms developed by the ocean color sensors that in this case was tested with MARIS algorithms. These were the outputs of our research since 2008 until 2017. They are the mainly projects of validation that we have been involved. The first two dedicated more, related more with MARIS, ocean color sensor, and now we have this last project is dedicated with the validation of OLSHI, ocean color sensors on board Sentinel-3 missions A and B. But we move forward. Now we want, because the European Space Agency and the European Commission put a lot of efforts in these satellite missions, so now we want to apply the ocean color data. So these were some of the EU projects that were involved in, with this exception of the votes. The other three projects were mainly focused in aquaculture, and in the votes it was the focus on the application of new tools to understand the marine diversity and assessing the good environmental status, where we show how can satellite remote sensing data can be a useful tool to help the implementation of European directives like the Marine Strategy Framework Directive or the Water Framework Directive. Now I will present here our present and future developments and what we are planning to do in the next years. It's essential that ocean color remote sensing validation keep going, because we need to understand the problems and provide accurate satellite data after the use of them for different applications. So Sentinel-3 OLSHI mission validation campaigns will be continuing to be developed in the southwest coast of Portugal, as this is one of the study sites for validation in ocean color validation. We are going to keep using the same strategy that we used before, but now we are integrating another equipment. Like now we have, with the collaboration with the company Sagres Marisco and CIMA, we are have a capability of having radiometric measurements in the water and a system, the trials radiometer above the water that measure radiometric measurements, also atmospheric measurements. We have a buoy system now that is integrated inside an aquaculture offshore that is going to take measurements also in real time. And also, of course, we will keep the in situ water samples for the characterization of the optical constituents in the side of the water. The applications, we're now starting to move on in the part of the application to support the blue economy. In this case, the two sectors that we are going to be focused will be in the aquaculture sector and the coastal tourism sector, like the beach tourism and ecotourism. And in terms of offshore aquaculture, the water products, as the case of chlorophyll and suspended particulate matter acquired by the ocean cause affect the conditions of the growth of the organisms in the offshore aquacultures. And then with the remote sensing data, we support identification of sites for aquaculture, warnings on the potential potential water quality threats, as the case of harmful algal blooms, and monitoring the environment impact of aquaculture. In terms of coastal tourism, we will make a study jointly with some companies here in the south to see the correlation about the sites of the cetaceans and the biomass of chlorophyll, of phytoplankton, sorry. We're also going to make applications of ocean color data to support EU directives, such as the Water Framework Directive and the Marine Strategy Framework Directive. Although ocean color remote sensing have a great potential, the scientific and the management communities are a bit skeptical about this applicability. In this way, there is a room for more studies on the applicability of this data, which now is freely available. So we are trying to develop studies in this field now. Thank you very much.
Okay. Well, we have 5 minutes for questions for this bridging knowledges. One here.
One very fast. Thank you for your presentations, for you and for yourselves about the HAPS detection. Are you able to early detect or only to detect when it's already there?
When it's already there.
What about you, Flavio?
It's not my expertise, but I agree. There are some models that can somehow predict what's going to happen, but it's a very complex process. So we are still working on that, but it's not something that is a process.
Because that would be the surplus, the added value for the process. Thank you.
Just like to add. Of course, if we can obtain good quality data with remote sensing, at least, we will be able to give more to the community to improve those studies. But so far,
so the models don't rely on
Other questions? I have one for both.
Okay.
The depth, you and you, your modeling.
Modeling so far, but Sonia can help me if I say something wrong, but CSER, remote sensing imagery deals with the top layer of the ocean. Although the retrieval of some components such as chlorophyll A, there have been some attempts to derive the in-depth chlorophyll concentration with, if we know, it's not my area of expertise so far, but there are some studies that relate the in-depth chlorophyll concentration with the top layer concentration, if we know the layer concentration, but it's still developing, but remote sensing deals essentially with the top layer and deep.
For now, it's
the same
it's one of the limitations.
Okay.
Yeah.
We actually take in situ data below the surface. Usually to the second depth.
Till?
Yeah.
Where?
I mean to the second depth. So
Second depth, yeah, euphotic zone, yeah. And the purpose is, this is...
This is supposed to be applied for offshore aquaculture. They're producing somewhere there in the range of producing 3,000 tons of mussels in that aquaculture site. And to the depth of about 10, 15 meters.
10, 15 meters.
That's the area
Oh,
that we're interested in.
okay.
That's the area that we want to get samples from.
That's why I was asking. Because 10, 15 meters is different from 100 to 100. That's what I would like to know about this depth.
That's why we integrate data. We integrate data, remote sensing, and the part of optics and other in situ samplings. It's effort to join different things.
Other questions? So we have used this 5 minutes. We are 15 minutes is not a delay. 15 minutes, it's not a delay. I'd like to ask you, applause for them. And thank you so much for your attention for this fully day.
Okay, so thanks very much for keeping this late, and we're going to have some drinks at Ciência Viva in Faro. Okay? Yeah, we have to, it's not the main entrance, it's the next door entrance. So there's some drinks waiting for everybody.
That sounds a very good idea. I need to collect my stuff together.